Hi guys, hi. Hello everyone. Everything clear now? Cheppandi okasari. Yes, I hope everything is clear now and we are good to go, right? Yes. Please let me know about the updates andaru. Is my voice clear? Am I audible? Am I visible? Audio video clear unda leda? Good afternoon guys, good afternoon. I hope it is audible now. And we are good to go, right? Right. Yes. Clear. Okay, perfect. Andaru, yes. Right. So we are good to go. Student, so ippadaaka your class 11 physics has been completed, right? So starting from units and dimensions completed, vectors completed, kinematics 1D, kinematics 2D, and then Newton's laws of motion, friction, work power energy, circular motion, rotational motion. I believe this part is completed, right? Cheppandi okasari. Yes. So in session lo we are going to talk about the electrodynamics, okay? And then, so it's completely about electrodynamics, class 12th part 1, okay? Electrodynamics ante the name of the chapters we will be studying is electrostatics, point number 1. After electrostatics we are going to talk about your capacitors, okay? Yes. Next one will be current electricity. దాని తర్వాత we will be talking about your magnetism, okay? Moving charges and magnetism. Basically magnetism, okay? Next ante electromagnetic induction and then alternating currents. Any chapters sir? 3 plus 3, 6 chapters in session lo we are going to cover. I can't see your charts guys. Yes, students okasari reply ibbandi, okay? If everything is clear, there is some technical glitch from my side, but I hope you can listen to me and you can, I am audible and visible, okay? Am I audible? Not audible, right? Yes, clear. I hope so. Stop. Okay, so let us continue. Andar. Right? Yes. A very good afternoon to everyone. Semiconductors will be completed in your modern physics round. Okay. Possible we will cover this also and we will try to do SHM also. Okay. SHM, simple harmonic motion. Dan tarvata we are going to talk about your waves tarvata wave optics. Okay. Wave optics. I don't know if it is possible to cover all these chapters in these sessions or not. Syllabus chala vast. Okay. Yes. Hi guys. Hi. Yes. Please give me 1 minute. So, let us start. Okay. Yes. So before starting the class, let me again introduce you to the result, solid preparation, outstanding results of Vedanta students. Okay. Yes. 994, 989 and 98.90%. Okay, these are the students. These outstanding result is a part and is a result of the dedicated hard work and the continuous mentorship. Okay. So these are the students that have scored extremely good in the IPA sessions. Alagi, at the same time, these are the students who have cleared NEET 2025 with All India rank 234, 293, 413, 475 and so on and so forth. And yes. So the students who are planning to take a drop are students suppose Vedanta offline centers. Vedanta learning centers is the platform all over Andhra Pradesh and Telangana. So these are the places at which your offline centers are present. Okay, yes. So let us continue. The name of the chapter is Electrostatics, okay? Yes. We will be trying to cover the PYQs also, okay? Kabatti, it will take a little time. Kani, Andaru, I want everybody to access the week quiz, okay? So, each chapter is tarvata, we have 2 week quizzes. So I want everybody to go and log into the week quizzes section so that we can start the week quiz. Timings mark cheskondi. The week quiz number 1 will start at somewhere around 4 p.m. Alage second week quiz will start at 7 p.m. and your post session test will be at 10 p.m. Okay? Yes, student. So let us start this session, guys. I'm not able to walk properly now. Okay, right. Here you go. So the name of the chapter. Yes. So దీంట్లో కూడా we are going to talk about the fixed topics, okay? Just give me a minute so that I can write the topics related to the NEET itself, okay? So, the first topic is electric charges and Coulomb's law, okay? First topic ఏంటంటే this is going to be your Coulomb's law and electric charges. దాని తర్వాత we will be studying about electric field, okay? Electric field. And then we are talking about electric potential, okay? Potential and potential energy. Next, electric dipoles, okay? We will be talking about dipoles also. And lastly, we have your Gauss law, flux and Gauss law, okay? Yes, Gauss law. So let us start with the electric charges and Coulomb's law of attraction. Coulomb's law, okay? That also I am just specifically going to talk about your Coulomb's law. Okay. మీ అందరికీ తెలుసు కదా. So when you have two like charges, they repel. అలాగే two unlike charges attract one another. ఇదే కదా? Yes. Coulomb's law quantitatively talks about the value of the forces of attraction లేదా repulsion. Okay? మీ దగ్గర రెండు charges ఉన్నప్పుడు, let us imagine that you have two like charges, sir. This is a negative charge, ఇది కూడా negative charge లేదా positive అనుకోండి. Yes. So this is your positive charge, ఇది కూడా positive charge. ఇప్పుడు కండిషన్స్ కావాలి. వాట్ ఆర్ ద కండిషన్స్ సార్? డిస్టెన్స్ బిట్వీన్ ద టూ చార్జెస్ ఆర్ అనుకోండి. అలాగే ద వాల్యూ ఆఫ్ ఫస్ట్ చార్జ్ Q1, ద వాల్యూ ఆఫ్ సెకండ్ చార్జ్ Q2. సార్ లైక్ చార్జెస్ వచ్చినప్పుడు there is always going to be the force of repulsion between the two charges. ఇదే కదా. What is the value of that force, sir? Charge get added algebraically. We'll do that. Okay, yes. So if you see the Coulomb's law of repulsion in this case, so force of repulsion ante it is directly proportional to the product of the charges, and F is directly proportional to Q1 multiplied by Q2. Similarly, it is inversely proportional to the square of the distance, and F is directly proportional to Q1 Q2 divided by R square. Every single student knows about this formula. Kani when it comes in applying the formula or converting it into vector formula, there is the real problem that starts. Okay, good afternoon everyone. Good afternoon, sir. So a directly proportionality symbol ki place lo, you have to replace with a constant of proportionality. So that constant of proportionality is K. So K multiplied by Q1 divided into Q2 whole divided by R square. So this is going to be the force of repulsion between the two charges. Depending upon the nature, if the charges are like charges, it is going to be repulsive. Leda unlike charges unnappudu, it is going to be attractive force. Vachindi andariki? Yes. Similarly, now I want you to observe this scenario. Student, this is going to be our first charge Q1 anukondi. Alage this is going to be our second charge Q2 anukondi. Okay, now we want to do some analysis. So this is a charge Q1, this is a charge Q2. The repulsive force until they are directed away from one another. So you can say, sir, a charge paina there is a force due to second charge ante force on first charge due to second charge. ఇదే కదా. అలాగే on this charge there is going to be a force on second charge due to first charge. ఈ రెండు ఫోర్సెస్ కి డైరెక్షన్ ని చూసి దే ఆర్ ఆపోజిట్ ఇన్ డైరెక్షన్స్. ఇదే కదా. yes, equal in magnitude and opposite in direction. ఇదిగో పాయింట్ నెంబర్ 1 to be noted about Coulomb's law. Force on the first charge because of the second charge is equals to negative of a force on the second charge due to first charge. Condition number 1 to be noted. Alage condition number 2, you can simply say that, sir, if we vectorially add the two forces f bar 1 2 plus f bar 2 1, its value should be equals to 0. Vachindi andariki? Yes. What does it mean, sir? It means that electrostatic force is an internal force. Internal force unte it is not going to change the center of mass of the system. Aithe the center of mass of the two charges is going to stay the same. Similarly, your gravitation force is also internal force kada. Yes, point number 1 to be noted. Andaru ippudu we are going to talk about the vector form of your Coulomb's law. Andaru in the vector form, ఇది చాలా important, okay? And this is where the situation gets complicated. Okay, students are watching. Students, please like this session. Right. So for your vector form, you basically have to transform these two charges into your vector system. So this is your first charge Q1. అలాగే ఇదే this is your second charge Q2 కదా. yes, values కావాలంటే values కూడా ఇవ్వండి. ఇదే charge Q1 అనుకోండి, this is your charge Q2. now I want you to draw the position vectors of both the charges. so Q1 charge की position vector R1 అనుకోండి, this is the position vector of Q1 charge R1 bar. అలాగే this is the position vector of the second charge R2 bar. వచ్చింది కదా. yes. Now when you are talking about the force of a repulsion, ఈ రెండు charges అంటే పాజిటివ్ అనుకోండి అందరూ. yes. so we basically have to use the triangle law of addition of vectors. okay. yes. ఈ distance r bar కదా, r bar. ఇప్పుడు when you are going to talk about force on the charge Q1 due to charge Q2, what is the direction, sir? ఈ force కి direction అంటే away. ఇదే కదా force on the charge Q1 due to charge Q2. అలాగే force on the charge Q2 due to charge Q1 ఇదే కదా. yes, this is going to be the direction of force. yes, అందరూ చూడండి. so when I am talking about force on the charge Q1 due to the charge Q2, the screen is zoom out change half meters. Okay. I'm sorry. Let me just zoom out the screen, okay? Now it's clear? I hope it's clear now, right? Chepan, everything is clear? Right. Now everything is clear, right? Sir. yes, direction చెప్పండి రా. so the direction is upward కదా, పైనకి ఉంటుంది. that means your r bar direction should match the direction of force. అయితే ఈ force కోసమే your r bar should also look like this. so sir, what is the equation of r bar అంటే ఇప్పుడు చూడండి, r2 bar plus r bar is equals to r1 bar. ఈ కేస్ కోసమే r2 bar plus r bar is equals to r1 bar. triangle law of vector addition కదా. yes. అంటే మీ r bar value is nothing but r1 bar minus r2 bar. You can write it this way also, substitute చేయండి. so sir, force on the charge Q1 due to the charge Q2 is equals to K multiplied by Q1 into Q2 divided by r square. r square అంటే r1 bar minus r2 bar కదా. this r1 bar minus r2 bar whole square. If you want to write it in the vector form ante r1 bar minus r2 bar divided by mod of r1 bar minus r2 bar kuda raavachu. that means force on the charge Q1 due to the charge Q2 is equals to K Q1 Q2 divided by R1 bar minus R2 bar whole cube times of R1 bar minus R2 bar. This is the vector form of your Coulomb's law. Okay? It looks a little complicated, Kani, okasari ee formula ni by heart chesinappudu it seems very easy for you. Okay? This is the force on the first charge due to the second charge. Alage vice versa cheppandi. What is the vice versa condition? So for this charge, the vice versa condition F bar on Q2 because of the charge Q1 is equals to K Q1 Q2 divided by R2 bar minus R1 bar whole cube times of R2 bar minus R1 bar. And now, these two forces ni add chesinappudu your net force should be 0. That means this force is the internal force of the system and the center of mass due to this force should remain the same. Okay? Yes. So now we are going to do some questions. Give me 1 minute, okay? If there are some questions based on the same topic, let us do those questions, okay? Children. Yes, I think we are good to go with the questions, right? Okay, so that let me just add this to the notebook itself. Notes Coulomb itself. Okay. Downloads. Not there in downloads. Yes, I hope it's clear now. Yes. So let us start with the Coulomb's law. So ippardaka law completed kada. Now we are going to see the questions. So this is the first question. Japan. 2-point charges A and B having charges plus Q and minus Q respectively are placed at a certain distance apart. And the force acting between them is F. If 25% charge of A is transferred to B, then the force between the charges becomes dash. Okay. NEET 2019. 2019 question is try change. So screen with a full lighting in this center. We can't do anything in that. This is completely new office. Kotta office. Okay. So new setup, new office, new problems. Can teacher matrame? Same teacher you have. Okay, students, I am expecting the likes from everyone. Okay. Yes. Andaru. Okasari like cheyandi. Yeah. Good. Very good. Chuddam. Idi andaru. So let us see for the solution. Question number 1 kada. Yes. For the question number 1, me దగ్గర రెండు charges ఉన్నాయి. First charge is a plus Q. అలాగే second charge అంటే minus Q. ఇదే కదా? Yes. The distance between them is not given R అనుకోండి. That's it. So ఇప్పుడు force F కదా. So F is equals to KQ square divided by R square. Equation number 1. So this is going to be the base step. So ఈ బేస్ నుంచి మనకు ఐడియా కావాలి. So what is going to happen in the next scenario? చూడండి 25% of the charge gone కదా from air. So ఇప్పుడు Q by 4 charge gone. అయితే 3Q by charge మిగిలి ఉన్నాయి. అలాగే here also minus 3Q by charge is remaining sir. ఇప్పుడు force చెప్పండి. New force F dash is equals to K multiplied by first charge. ఎంత sir? 3Q by 4. into second charge, ఇది కూడా ఎంత sir? 3Q by 4. Signs I am not writing because it's attractive force divided by R square. So F dash is equals to 9 by 16 multiplied by K into Q square divided by R square. మీ ఎగ్జామ్ హాల్లో కూడా this should be your speed of calculation. అందరూ జాగ్రత్తగా వినండి. ఓకే. yes. So compare చేయండి. So this KQ square by R square F కదా. So lift and shift here. కాబట్టి మీ new force F dash is equals to 9 divided by 16 times of F. That's it. Done? Not done. 9 by 16 F అంటే option C is the correct answer. Very good, Janvi. Very good, very good, very good. Okay. Good. Very good guys. Very good. Next question కావాలంటే తీసుకోండి. We will take 2-3 questions or not more than that. Okay. అందరూ చూడండి. So this has been asked in 2017. Suppose the charge of a proton electron differs slightly. Okay. We have actually done this. But stop. Not this question, okay? Not this question also. Not this question also. Yes. You can take this question. two positive ions, each carrying a charge q, are separated by a distance d. If F is the force of repulsion between the ions, number of electrons missing from each ion will be dash. Okay, this question your concept of mole chemistry should be very good. Okay, then and only then you can attempt these type of questions. Chapali. Somebody said that I am looking like some serial doctor. Ever try substituting the initial force into the equation? Very good. Invasion. Very good. Very good. Very good. Yes. 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 Okay. This question, students, my dear students, this question is helping you for your chemistry also. Okay. Chemistry lo kuda extra charge on the ions and all these things that are there. Okay. C. Yes. 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 Gayatri. Very good. C itself. C is the. I don't know for this question, okay? This question goes so question number 5 kada. Every question, each and every single question is based on your Coulomb's law, okay? We have just covered the Coulomb's law. Coulomb's law statement, then there are the formulas and vector representation, and after that we are doing these formulas, okay? Student in the questions, first of all, question chadud. Two positive ions, each charging a charge of plus q are separated by distance d. If F is the force of repulsion between them, number of electrons missing from each ion will be dash. Okay, charge kavali, and there is this quantization of rules kada. Q is equals to n times E. Yes. So you have two different charges. This is the first charge. Same charges kada. Same charges, right? Carrying a charge Q, right? So here also plus Q charge is there. Alage ikkada kuda plus Q charge is there. Now the question reduces to a single question, Ram. Sir, the object paina plus q charge unnappudu any electrons missing unnai. How many electrons are missing? So if one electron is missing, ante plus e charge usti. If two electrons are missing, plus 2e charge will be there. Alage sir, if 3 electrons are missing, 3 charge is there. Alage, if n electrons are missing, and then naku ee n value kavali kada. Point number 1 to be noted. Total charge should be equals to the number of electron multiplied by each charge. Okay. Yes. So this is the total number of electrons, and the Q is equals to Ne. And ippudu naku n kavalante n is equals to Q divided by E. Ide kada? Yes. And 50% of my question has been completed. Okay, 50% question completed. N is equals to Q by E. Single statement, question gone, question dead. Now I want to find the value of Q. Like find chestaru sir. So to find the value, chudandi. Force F. Alage distance D kada. Yes. So these two charges ki madhyalo distance D is there and there is this force F. Mari substitute cheyandi Coulomb's formula. What is Coulomb's formula, sir? Your F is equals to K multiplied by Q1Q, Q2 divided by R square into D square. That's it. So sir, your force is equals to K times of Q square divided by D square. వచ్చింది కదా మరి ఏం కావాలి మీకు Q value కావాలి సో ఒకసారి ఇక్కడ నుంచి Q value వచ్చిందంటే remove it and substitute it there itself divided by E అంటే your total number of charges will be available. Okay, now expect denominator. Yes ఇదిగో denominator కూడా వచ్చింది కదా అందరూ చూడండి denominator E వచ్చింది అంటే whenever the denominator E is not there you are going to eliminate that option. Okay, ఇది స్మార్ట్ ఎలిమినేషన్ మెథడ్ కదా ఆప్షన్స్ డి గాన్ ఎందుకంటే ఈ నాట్ దేర్ హియర్ అలాగే ఇక్కడ కూడా ఈ లేదు కదా అయితే యువర్ ఆప్షన్స్ ఆర్ డెఫినెట్లీ గోయింగ్ టు బి దిస్ వన్ లేదా దిస్ వన్. ఓకే, వన్ అమాంగ్స్ దిస్. రైట్ ఆర్ రాంగ్ దిస్ మెథడ్ వర్క్స్ ఆర్ నాట్ వర్క్స్ రా does this method work or not work? It should work. It should 100% work cheyali. You don't have to solve the entire question kada. Meanwhile, I am telling you smart intelligent methods andaru student. There is one more option. Okay, there is one more option. I did not solve this question ippadaaka nenu solve cheyaledura kani common sense ni observe chesi you can save a lot of time and efforts and confidence in the examination hall. Okay, 11 days kada ippadi nunchi mee exam kosame ee 11 days lo ide smart guessing strategy ante you should adopt it. Okay, yes, another student. So if the force value is this, I then Q square kadara. So Q square unde Q value kaval kosame I basically have to square root it. So answer lo root maatrame compulsory ga undali kada. Yes, alage denominator lo E undali. So sir answer lo root undali, denominator lo E undali. I think naaku adi kuda telidu kada. Okay, I don't know if this is answer or not. Kani na gut feeling ra. My gut feeling is telling that option C is the answer. ఎందుకంటే ఈ ఆప్షన్ లో రూట్ కూడా ఉంటుంది అండ్ అలాగే డినామినేటర్ లో e is also there. రూట్ ఆఫ్ e స్క్వేర్ అంటే e ఓన్లీ కదరా. yes ఇదిగో ఈ ఆప్షన్స్ కోసమే డినామినేటర్ లో q స్క్వేర్ హియర్ డినామినేటర్ d స్క్వేర్ ఇస్ దేర్. ఇదిగో ఇక్కడ e స్క్వేర్ ఇస్ దేర్. మీ ఆన్సర్ కోసం e స్క్వేర్ అక్కర్లేదు కదా. you need e in the denominator. yes ఇప్పుడు let us solve it systematically. okay yes. okay ఇదిగో so let us solve it systematically and let us see which is the answer. okay substitute చేయండి. ఇక్కడ నుంచి your q value is nothing but q square కదా. q square అంటే f into d square divided by k. k అంటే ఏంట్రా 1 by 4 by epsilon naught. so sir q square value is equals to f into d square divided by 1 upon 4 by epsilon naught. వచ్చింది కదా. అంటే f into d square into 4 pi epsilon naught is the value of q square. ఎక్కడ నుంచి రూట్ తీసుకోండి అదే. సో సార్ your square root of q square అంటే q value is equals to root of every quantity f d square multiplied by 4 pi epsilon naught. అదే మరి ఏం కావాలి నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ కదా. సో సార్ n is equals to q by e అంటే ఈ మొత్తం వాల్యూ f d square multiplied by 4 pi epsilon naught divided by e. అదే but if you want everything to be in root of e square తీసుకోవాలి. అదే that's it. so e square వచ్చినప్పుడు number of electrons n is equals to root of f into d square into 4 pi epsilon naught divided by e square అని వస్తుంది. and that's it. same answers kada. f d square 4 pi epsilon naught by e square. you don't have to work completely wrong. okay yes some student have said a very good answer. okay very good afternoon everybody. yes okay smart elimination ra babu. me NEET exam lo nobody is checking if you know the concept or not. final answer వచ్చినప్పుడు finished. ఇదే కదా. కాబట్టి ప్రతి ఒక్క క్వశ్చన్ కోసమే you basically have to use the elimination methods. okay అది కూడా smart elimination methods యూస్ చేయాలి. ఇదిగో there is one more option actually. number of electrons kada. yes so number of electrons కావాలంటే you can also verify this in the dimensional formula ra. dimensionally కూడా verify చేయొచ్చు. this will also give you the result if you go for dimensional analysis. ఎందుకంటే ప్రతి ఒక్క టర్మ్ కి డైమెన్షన్ వేరే వస్తుంది కదా. that's sir. so let us go for the next question. when air is replaced by a dielectric medium of constant k, maximum force of attraction between two charges increases, decreases, remains same, don't. okay చూడండి in your Coulomb's law force value and sir force formula F is equals to k value k అంటే 1 upon 4 by epsilon naught multiplied by q1 q2 divided by r square. ఇదే కదా. ఈ మొత్తం ఫార్ములాలో we have seen almost everything రా. కానీ ఒక సింగిల్ టర్మినాలజీ కోసమే we have not gone the full focus mode. what is that terminology? epsilon naught. చూడండి what is epsilon naught sir? ఏంట్రా ఇది epsilon naught? నీ epsilon naught అంటే it has its special significance. okay ఇప్పుడు చెప్పాలి మీరు what is this epsilon naught? ఏంటిది epsilon naught? epsilon naught అంటే it is the permittivity of free space. ఇదే కదా permittivity of free space. అందరూ చాలా జాగ్రత్తగా వినండి. yes so ఈ ఫార్ములాలో మీ epsilon naught ఏంటంటే it is nothing but the permittivity. అందరూ ఇదే కదా. yes permittivity of free space అని అంటారు. okay your epsilon naught is the permittivity of free space. అందరూ అలాగే if the two charges ఈ ఫార్ములా చార్జెస్ కోసం కాదురా. yes so if you have two charges so ఇదే ఫస్ట్ చార్జ్ సెకండ్ చార్జ్ ఎయిర్ లో ఉన్నప్పుడు this is the force. so చార్జెస్ కి వాల్యూస్ కూడా తీసుకోండి. okay let us say the value of the first charge ప్లస్ q1 అనుకోండి, ఇక్కడ ప్లస్ q అనుకోండి. ఈ రెండు చార్జెస్ కి మధ్యలో డిస్టెన్స్ కూడా r అనుకోండి. అయితే these two charges are there in the air లేదా vacuum లేదా air అనుకోండి. okay this is a force. కానీ ఇదే ఈ రెండు చార్జెస్ ని వాటర్ లేదా ఆయిల్ లేదా హనీ okay whatever mediums are there వాటర్ లో డిప్ చేసినప్పుడు there will be different force అంటే ఫోర్స్ మారిపోతుంది. okay yes sir if the same charges are dipped in another medium ఇది వేరే మీడియం ఉంటే ఇప్పుడు ఈ మీడియం కోసమే పర్మిటివిటీ కూడా వేరే వస్తుంది. ఓకే ఎప్సిలాన్ నాట్ అంటే ఎయిర్ కి లేదా వాక్యూమ్ కి పర్మిటివిటీ, Kani, if you are dipping them in a liquid, it will have its own permittivity. So sir, for a different medium, చెప్పండి, for a different medium, you basically write that force inside the medium, okay? Force inside the medium is equals to 1 upon 4 pi epsilon naught kaadu. Epsilon of medium, okay? Andaru chala jagattaga vinandi. Epsilon of medium kada, epsilon of medium multiplied by q1 q2 divided by r square. Now I am assuming that your calculation is good enough. Equation number 1 anukondi, ide equation number 2 anukondi. Now I want everybody to divide these two equations. These two equations ni divide cheyandi okasari and let us see what is the result, okay? Divide equation number 1 and 2. Divide chesi cheppandi andaru. So F by F medium kada leda F naught ante force in the atmosphere leda air, okay? So F naught divided by F of medium. Force in open air divided by force in the medium. Q1 Q2 by r square gone. 1 by 4 pi kuda gone. It is just coming out as epsilon of medium divided by epsilon naught. Epsilon of medium divided by epsilon naught. Ante ee ratio ni oka special term kuda untundi. It is known as the relative permittivity. Relative permittivity andaru. This is known as the relative permittivity. Force in atmosphere, force in vacuum divided by force in medium is nothing but relative permittivity. So if you want the force in medium, ela calculate cheyali sir. So force in medium is nothing but force in vacuum divided by epsilon relative. Idigo ee epsilon relative ki parallel lo leda there is a terminology known as a dielectric of that material, okay? K of the material. Student, you will simply say now, sir, force in the medium is nothing but force in open air divided by K. So this K corresponds to the epsilon relative, okay? Chala jagrataga vinandi. There is the list of most important formulas. So sir, force in any medium, okay? Direct relationship ante ide. So force in any medium ante force in vacuum divided by relative permittivity of that medium, okay? Relative permittivity of the medium itself. Ayipondi kada? Yes, so this is all about your Coulomb's law. Okay? Ippudu cheppandi. Andaru everything's clear? Not clear? Guys, like cheyandi ee video ni. Right. Let us now talk about the superposition of the forces, okay? Is it clear? Is it clear? Not clear? Let us make it clear. Okay. Right. So now we are going to talk about the superposition of forces. This is chala important topic, okay? Andaru, there have been questions, direct PYQs based on this concept. Superposition of the forces. Superposition of forces. Forces. Okay. Nothing. 1 plus 1 2 kada. 1 plus 1 2 only. Kani vector form lo. Vector lo 1 plus 1 2 ledu kada. Yes. In your vector representation, 1 plus 1 is not equal to 2. Okay. Yes. మీ వెక్టర్ ఫామ్ లో 1 plus 1 is not 2, right? ఎందుకంటే సార్ డైరెక్షన్ ఆల్సో మ్యాటర్స్. అదే సేమ్ థింగ్ హియర్ ఆల్సో డైరెక్షన్ ఆల్సో మ్యాటర్స్. ఓకే, yes. మరి ఇప్పుడు చూడండి అందరూ, ఇఫ్ యూ హ్యావ్ మల్టిపుల్ చార్జెస్, ఈ చార్జెస్ కి వాల్యూస్ అనుకోండి ఇదే. సో ఫస్ట్ వాల్యూ ఆఫ్ ద చార్జ్ Q1, ద సెకండ్ చార్జ్ Q2, అలాగే థర్డ్ చార్జ్ ని Q3 అనుకోండి. ఓకే, ఇట్ ఈస్ అ వెరీ ఫేమస్, వెరీ స్టాండర్డ్ ప్రాబ్లం అందరూ. ఓకే, distances ra, prati okka charge ki distance a anukondi. So this distance is a, here also the distance is a, and here also the distance is a. I'm not going to skip anything, okay? A marathon lo full syllabus meeku vastundi. The only thing is that you should take each and every formula seriously, okay? And good news for you, after every single chapter I am going to make a full formula list right in front of you, okay? Yes. And the student, so ippudu the question is, question తీసుకోండి అందరూ, find Okay, charges కూడా సేమ్ తీసుకుంటారా, నాట్ Q1 Q2 Q3, ప్రతి ఒక్క చార్జ్ Q అనుకోండి, దట్స్ ఇట్. Q కదా, yes. Find the net force. Okay, అందరూ క్వశ్చన్ తీసుకోండి. Find the net force on charge A. Okay, charge A అంటే ఇదే. So ఇదే charge A, this is your charge B, this is your charge. Try it. Everybody try చేసి చెప్పండి నాకు. Okay, after every formula we are going to make the formula list. After every chapter, okay, ప్రతి చాప్టర్ తర్వాత కంప్లీట్ ఫార్ములా లిస్ట్ ప్రిపేర్ చేద్దాం. రైట్, 90% completed sir. What completed 90%? Data. Baba. Number cheppu ra, number cheppu. Tell me your number, I'll give the recharge. Okay, let us see how many students are rich ra, rich. That's what I'm telling you. Good, Banu, very good. Okay, right. Okay, there are lots and lots of rich students who are attending the class. Kabatti 90% data అయిపోయిందంటే number చెప్పు. Okay, we'll write the number here itself on the board, and if there is some Srimantudura, okay, you will recharge your phone, don't worry. Okay, hi. ఇదిగో చూద్దాం అందరూ. Same things, same way, same property, okay, same approach, same method. So ఈ రెండు చార్జెస్ ని అబ్జర్వ్ చేయండి, చార్జ్ A అండ్ చార్జ్ B కదా. yes, సేమ్ చార్జెస్, నేచర్ మాత్రమే సేమ్ ఉంటుంది, ప్రతి ఒక్క చార్జెస్ పాజిటివ్ ఓన్లీ. ఓకే, yes. రష్మిత, కరెక్ట్ ఆన్సర్. ఓకే, వెరీ గుడ్ రష్మిత. అండ్ యూ సే యూ డోంట్ నో ద ఆన్సర్స్ రా, ఇదే కదా, దిస్ ఇస్ ద ఆన్సర్, రైట్? yes. So sir, the interaction between A and B, positive charges ఉన్నప్పుడు repulsion ఉంటుంది. సో ఇదే, సో force on a charge A due to charge B. ఓకే, B charge వల్ల A charge పైన force డైరెక్షన్ తీసుకోండి, ఇదే repulsive force కదా. అలాగే the force on charge A due to charge C, F bar A, C. అర్థం చేసుకోండి, force on charge A due to charge, ఇదే కదా. ఈ ఫోర్సెస్ వచ్చిందంటే వాల్యూస్ కావాలి. ఓకే, వాల్యూస్ అదే. యాంగిల్ చెప్పండి ఒకసారి. So sir, net force superposition ki formula ante ide. This is the only formula for the superposition of the forces. Sir, net force F net bar is equals to F1 bar plus F2 bar plus F3 bar plus so on so forth up to Fn bar. Done? Not done. Now when I write the F1 bar plus F2 bar plus F3 bar, ante it should be understood that this vector addition has been done over here. Mari ela add cheyali sir? Simple gaane you take these vectors into yourself. So you take this entire setup and angle calculate cheskondi. Ee angle 60 degrees kadara, endukante prati okka angle 60 only. Kabatti mee daggara rendu equal forces untayi. Equal forces enduku sir? Because the distances is same. అలాగే the charges are also same. కాబట్టి F అనుకోండి. So this is also F, ఇది కూడా F. Now when you talk about the net force of this charge, ఇదే కదా charge A. This is your force F. అలాగే ఇది కూడా మీ force F only. Angle is 60 degrees. మరి సార్ నెట్ ఫోర్స్ కావాలంటే ఫార్ములా రాసుకోండి. సో నెట్ ఫోర్స్ అంటే రూట్ ఆఫ్ F1 స్క్వేర్ ప్లస్ F2 స్క్వేర్ ప్లస్ 2F1 F2 cos of angle theta. Theta అంటే 60 degrees వచ్చింది కదా, మీ అందరికీ తెలుసురా, క్లాస్ 12th స్టూడెంట్స్ మీరు. ఓకే, 10 days లో నీట్ రాస్తున్నారు. సో F square plus F square plus 2 times of F1 F2 F square multiplied by cos 60 half తీసుకోండి, అంటే root of 3 times of F square, అంటే F root 3 వచ్చింది. కరెక్ట్ ఓన్లీ. సో దిస్ ఇస్ ద నెట్ ఫోర్స్. కానీ ఇప్పటికి కూడా the answer is not complete. ఈ ఆన్సర్ ని కంప్లీట్ చేయాలి కదా. yes. how are you going to complete this answer? Not zero ra, not zero. Re. Ela zero ra, not zero kada. It is 60 degrees, not 180 degrees ra babu. 60 degrees, okay? Yes, 60 degrees. 180 unte zero vastayi kada. Ippudu chudandi andaru. So here basically F value రావాలి. So F is equals to KQ square divided by A square kada. Ade as simple as that itself. అందారు కదా. Yes, మరి substitute చేయండి force value. What is the value of force? KQ square upon A square kada? Yes. So sir, the total final answer for this question F net is equals to, చెప్పండి, net force F net is equals to KQ square divided by A square root 3. That is the final answer. Done? Very good, very good, very good, very good. Idigo. So this question was actually for a triangle kada? Ide triangle. Can in the exam lo triangle asal raadu, okay? They will ask you about hexagon. They'll ask you about pentagon, octagon, heptagon, no, all these things, okay? Going on, all these things. And then, let us see one question that perhaps is using hexagon as the question itself, okay? So I think there is a question that is asking about the hexagon itself. Chudandi, forces between multiple charges kada? Yes, alagi. Question number 7, తీసుకోవాలి. Okay, it's a question. Andaru, listen to me very carefully. Okay, it has been asked in NEET 2013. చూడండి, NEET 2013. Okay, listen to me very carefully. ఇది చాలా important question. 1995 and 1988 also similar questions recent ka kuda it has been asked, but in a different form. Field. Here it is asking about field. In another question it is asking about the field. Here it is asking about force. In another cases it is asking about the field itself. Okay, kabatti jagrataga cheyali ee question. Okay, let us solve this question and then let us try to solve this question itself. Okay. Okay, next part, in the next part, linear force, okay, linear charges, linear charges, it is a special point that I am teaching you because of the weightage. So, in linear charges ante maamulugane mee daggara moodu charges untayi, okay, all in a straight line. First charge, second charge, third charge, finished. And ఇప్పుడు చూడండి, okay, ఇది ప్లస్ q charge, అలాగే ఇది కూడా ప్లస్ q charge and this is minus q charge. అందరూ okay? Yes, it is kept at the center point. ఈ total distance 2d అనుకోండి, అలాగే this distance is d and this distance is also d. Proper question చెప్తున్నా చూడండి. Question is, what is the value, okay? What is the value of charge minus q? What is the value of charge minus q? Of charge q kada? Such that the system is in equilibrium. Okay, such that the system is in equilibrium. Andaru, such that the system is in equilibrium. చెప్పండి. మరి forces equal చేయాలి కదా? So you basically have to equal the forces, nothing other than that. Options లేదు. Okay, tell me the answer. Direct answer చెప్పాలరా. Okay, let us see the direct answer now. Okay, guys, like the video. Yes, చూడండి ఎందుకు. So if you want the value of charge q కదా, అయితే ఈ minus q charge పైన ఫోకస్ చేయండి. ఎందుకు? రైట్ సైడ్ ఫోర్స్, లెఫ్ట్ సైడ్ ఫోర్స్ మాత్రమే ఈక్వల్ ఉండాలి కదా. రైట్ సైడ్ లో కూడా అట్రాక్షన్ ఉంటుంది, లెఫ్ట్ సైడ్ లో కూడా అట్రాక్షన్ ఉంటుంది. అంటే ఇట్స్ అ గర్ల్ రా, బ్యూటిఫుల్ గర్ల్. ఓకే, అండ్ దీస్ ఆర్ టూ గైస్. అండర్స్టాండింగ్? సో ఇఫ్ దర్ ఇస్ ఈక్విలిబ్రియం అంటే yes, Janvi, very good. It's a formula, okay? I want you to remember it as a formula. Andaru chaala vinandi, jagrata. Okay, dr, what will happen if the values are not same? Let us take that case also. Andaru చెప్పండి. మరి సార్ ఈ స్మాల్ క్యూ పైన దేర్ ఆర్ టూ డిఫరెంట్ అట్రాక్షన్స్. ఇదే ఫస్ట్ అట్రాక్టివ్ ఫోర్స్, సెకండ్ అట్రాక్టివ్ ఫోర్స్. వాల్యూస్ మాత్రమే సేమ్ ఉండాలి కదా. సో టేక్ ద వాల్యూస్ రా బాబు, వాల్యూస్ సేమ్ కావాలి. సో లెఫ్ట్ సైడ్ అట్రాక్షన్ ఫోర్స్ K క్యాపిటల్ Q స్మాల్ q డివైడెడ్ బై d స్క్వేర్. ఓకే, షుడ్ బి ఈక్వల్స్ టు మరి ఒక్కసారి K క్యాపిటల్ Q స్మాల్ q డివైడెడ్ బై d స్క్వేర్. ఇదే కదా. If the distances are same, If the charge value is the same, okay. Alage, if everything is same ante sir, kq by d square, gone. Q is equals to q, and whatever charge you want, you can put the value. Correct? Leda. Idigo. Left side force, right side force equal undali kadara. Yes. Are they equal? They should be equal. And the two forces equal unnappudu kq by d square, kq dq by d square. Valid. Kq by d square, gone. And q is equals to q vachindra babu. So 1 equals to 1, 2 is equals to 2, T3 is equals to 3 ante whatever charge you want, you can take it. Correct? Leda. Background music. There's no background music, okay? Yes, there is no condition of this Q. Is there any condition? Is there any condition? Should there be any condition on Q? Or you can take whatever you want to take. Symmetry, sir. Symmetry is charge everything is the same. Chudandi. This approach tapura, okay? You should not go in this approach. Chudandi. Are you understanding? This system equilibrium lo unnappudu, it is not creating problem at all. Central charge ni choose, it is always happy only, okay? The disturbing part is coming from these two charges. This positive charge. These two charges ki maddhalo repulsion untundi kada. So they are trying to break the equilibrium. Aithe these two charges ki maddhalo repulsion force ra, and this repulsion force should be balanced by the attraction force. Aithe mee concentration lift cheyandi. This is not the area of interest. This is the charge of our interest. Aithe the left force and right force should be same. Okay. Left side force ante repulsive force ra. Aim charge wala sir plus q charge wala repulsion force kada. That's it. Alage right side force ante attractive force. Now here we have to apply the equilibrium condition. Chudandi, conceptual clarity gaane undali, okay? There are lots and lots of things that are going on andaru. Okay? Yes. Mari equate cheyandi. So sir, net force left side, right side same undali. Left side force enta sir, right side force enta sir. Cheppandi formula Coulomb's law kada. Coulomb's law. Left side force ante k capital Q square divided by 2d whole square ra babu. Ide kada. Should be equals to right side force sir, k capital Q small q divided by d square kura cheppochu. Ippudu k gone, q gone. There is one q left, okay? Alage d square kuda gone. So sir, q by 4 should be equals to q. Ide magnitude ochindi. Mari sign kavalante attractive force negative charge undali. Okay. This is a condition. So center point unnappudu your condition is a q by 4, okay? Divided by 4 undali. Minimum condition idi. Okay, if you want to extend this question, you extend kuda cheyochu. But extend chesinappudu you have two different charges anukondi. Idi kuda plus q charge only, and that is also plus q charge only. And I am going to make you perfect try. You don't have to see any other video after you see this video once. Okay? Kabatti jagrataga vinandi. If you see this video, this video ante more than sufficient for your NEET examination. No question, no, nothing will be more than the scope of this video. Clear? Yes. Plus q charge, idi kuda plus q charge anukondi. But I am taking a negative charge ra babu. Ide minus q charge teeskondi. Okay. Kani, in case lo, this minus q charge is a little close to the left charge, okay? There is something going on, okay? Gulu. Minus q charge anukondi. Okay, this is the minus q charge. If the distance is kavalante teeskondi. So this distance is d1. Okay. Alage ee distance d2 anukondi. And the total distance between the two charges is 2. Ide kada. Naku magnitude of q kavali. I need the magnitude of small q such that the charges are balanced. What is the magnitude of small q? And chudandi. So for magnitude of small q, and left side and right side force matrame same undali. Aim charge paina sir, left charge paina. Endukante it is having the distributive part. And disturbance is coming from left or right side charge only. So ippudu ma target ante left side charge ra babu. Left side lo oka force untundi, right side lo oka force untundi. Kani left side force ante repulsive force and the right side force ante attractive force. Vachindi andariki? Yes, the two forces should be same. Mari formula cheppandi okasari. So sir, repulsive force kada leda F left side is equals to force in the right side. Formula కావాలంటే రాసుకోవచ్చు. So K multiplied by capital Q divided by total distance. Total distance ఎంత 2D whole square should be equals to K multiplied by capital Q multiplied by small q multiplied by D1 whole square. వచ్చింది అందరికి. ఇది చాలా ఇంపార్టెంట్ కండిషన్. ఓకే, even if D2 is not given to you, D1 కూడా ఇచ్చినప్పుడు question is sufficient and you can definitely calculate the answer. Okay, yes, minus q by 3. Let us see. Gayatri, very good Gayatri. I don't know the answer. Kani. I salute for your efforts. Okay, yes. So KQ gone. Aithe q divided by 4 into d square should be equals to small q divided by d1 square. Ide kada small q value kavalante small q is equals to capital Q into d1 square divided by 4 times of d square. Good petkondi. This is also one of the most important formula. As a formula remember cheyali. Ippudu symmetric case kada. So if you have a symmetric case, ఆ పాయింట్ ఆఫ్ టైం లో యూ కెన్ సబ్స్టిట్యూట్ ద సిమెట్రిక్ వాల్యూ. ఓకే, ఈ ఫార్ములా కోసమే ఫార్ ద సిమెట్రిక్ కేస్ అందరూ వాట్ ఈస్ గోయింగ్ టు బి ద కండిషన్. ఓకే, ఫార్ సిమెట్రిక్ కండిషన్స్ వాట్ ఈస్ ద సిమెట్రిక్ కండిషన్ అందరూ చెప్పండి. మామూలుగానే your d1 వాల్యూ d2 వాల్యూ ఆర్ సేమ్ అండ్ ఈక్వల్స్ టు d itself. ఇదే కదా, మరి సబ్స్టిట్యూట్ చేయండి. సో సార్ small q charge is equals to q multiplied by d1 square divided by 4 times of d square. ఇదే కదా, అయితే q multiplied by d1 d కదా, d square divided by 4 times of d square gone. Very final answer is q by 4. కానీ charge sign కావాలంటే negative charge తీసుకోండి. ఓకే, అయితే this is the most general formula for your equilibrium condition. అర్థమైంది అందరికీ? yes. Now let us focus on the next part. Okay, next part అంటే next question కూడా చెప్పొచ్చు. ఓకే, దెన్ ఇదిగో అలాగే సేమ్ కండిషన్స్ కదా. yes, so if it is q by 4 అంటే సిమెట్రీ ఉండాలి. సిమెట్రీ చూడండి, సిమెట్రీ అంటే ఇదే. so these are your two charges కదా, ఇదే రెండు చార్జెస్ ప్లస్ 4q ప్లస్ 4q. సో ప్లస్ 4q is there రా. ఓకే, ప్లస్ 4q అనుకోండి, ఇదే ప్లస్ 4q. అరే ఓకే, దిస్ చార్జ్ ఇస్ ప్లస్ q. అలాగే ఇది కూడా ప్లస్ 4q ఓన్లీ. అండ్ ద బ్యాలెన్సింగ్ చార్జ్ అయితే సెంటర్ లో ఉంటుంది మైనస్ q itself. ఇప్పుడు చూడండి 4 టైమ్స్ కదా, రెడ్యూస్డ్ బై 4 టైమ్స్ అంటే ఇట్స్ సిమెట్రిక్ కండిషన్. కాబట్టి దిస్ మైనస్ q చార్జ్ షుడ్ బి ఇన్ ద సెంటర్ ఇట్సెల్ఫ్ రా. సెంటర్ లో ఉండాలి. దట్స్ ఇట్. ఓకే, ఆల్ ఆర్ ఇన్ స్టేబుల్ ఈక్విలిబ్రియం అండ్ ద చార్జెస్ షుడ్ బి ఇన్ ద సెంటర్. విచ్ చార్జ్ రా? negative charge should be in the center itself. వచ్చింది కదా అందరూ? yes. next part, now we are going to discuss about electric field. okay, next concept ఇది done. so this was all about your Coulomb's law. okay, ఇప్పటిదాకా ఏదైనా డిస్కస్ చేసింది all of that comes into Coulomb's law అందరూ. so Coulomb's law we talked about the statement, అలాగే we talked about the formula, vector representation, దాని తర్వాత superposition of the charges, forces, and alage we have talked about the equilibrium condition. So Coulomb's law has been completed. Okay, now I want to focus on something known as electric field. Student, okay, electric field kada. yes. Students, what do you mean by electric field? Electric field ante it is the mean ra. mean aithe if basically there are two people ra, human beings unnappudu interaction cheyadaniki hands unnai kada. yes, alage if there are charges ra, so if you want to push someone you have your hands, లేదా if you want to pull someone you have your hands. కానీ charges కోసం అట్లా కాదు. సో చార్జెస్ ని రిపల్ లేదా అట్రాక్ట్ చేయడానికి ఫీల్డ్ ఉంటుంది. ఓకే, ద ఫీల్డ్ ఇస్ నథింగ్ బట్ ద హ్యాండ్స్ ఆఫ్ ద చార్జెస్. అర్థమైంది అందరికి? yes. అలాగే ఒక హ్యూమన్ బీయింగ్ దగ్గర రెండు హ్యాండ్స్ ఉన్నాయి, కానీ ఒక చార్జ్ దగ్గర ఇన్ఫైనైట్ హ్యాండ్స్ ఉన్నాయి, అండ్ దోస్ హ్యాండ్స్ ఆర్ నోన్ యాజ్ ద ఫీల్డ్ ఆఫ్ ద చార్జ్ ఇట్సెల్ఫ్. ఓకే, లేదా ఫీల్డ్ ఈజ్ నథింగ్ బట్ ద ఇన్ఫ్లుయెన్స్ ఆఫ్ ద చార్జ్ దట్ ఈస్ క్రియేటెడ్ యాజ్ సూన్ యాజ్ ద చార్జ్ ఇస్ అపియర్డ్. ఓకే, ఇది బేసిక్ ప్రాపర్టీ రా. ఓకే, fundamental property of the charge is the electric field. So there is no situation in which the electric field is not there but the charge is there. Atla kaadu, okay, it is not possible. So eppudaina mee daggara charge unnappudu field 100% vastayi. So edina normal metal teeskondi, ee normal metal nunchi electrons remove cheyandi, okay, extract chesinappudu positive charge vastayi. So once the conductor has a positive charge, and it will create the electric fields within itself. It is the fundamental property of the charge. Inevitable, unavoidable property of the charge is the electric field itself. Okay? Yes. And then, so when you are talking about the fields, there are two different types of fields. Leda, two different types of charges. So if the charge is a positive charge, then the field will have different nature. Alage negative charge is unnappudu, field will have a different nature. Yes. Sir, student. So field and it completely depends on the charge. Okay. So if you have a positive charge, if you have a negative charge. Let us see the properties of field also. Kani, ee mattam discuss chesi mundu I want to talk about field lines. Okay. So if it is a positive charge unte, the field lines are always directed away from the charge in all the directions under, okay, not in a single direction or two, in almost every single direction. It actually chala difficult to visualize, kani meeru efforts chesinappudu matrame you can visualize it easily. So if you have a positive charge, okay, you are saying something, I'm sorry, I did not see your message, okay, aithe sir ilanti a q naina, yes Gayatri, yes, correct only, okay. If you have two different charges, Q anukondi, and if they are balanced by a negative charge, if the negative charge is in the center, then the value of that negative charge must be Q divided by 4. Okay, 1 by 4 times the either charge. Minimum condition. Okay. And the field line from a charge is actually directed in almost every single direction. Okay. It is in a 3-dimensional figure, 3-dimensional shape, okay? Sir, it a vector and conservative field. Yes, correct, okay? Electric field is a vector quantity and is conservative. Conservative, it does not steal the energy of the system. Aithe, edina energy initial it will always conserve the energy. Yeah, the forms might change, right? Kinetic to potential, potential to kinetic, kani energy matrame conserved, okay? That is the condition. Other student, right? So if you have a positive charge, the field lines will be emitting out of the charges. Alage negative charge kosame atla kaadu. For your negative charge, the field line will be directed towards the charge itself. So either negative charge kosame, this is the field line. Okay. So this is the condition for a negative charge. And from every single side, the field is actually converging towards itself. Okay. So this is your negative charge. Alage, ide me positive charge kada. And 243, we have to complete the entire chapter, sir. How is it even possible? We are going so slow. Sir, ardham kale, Manideep, em ardham kalra. Yes. Negative charge, negative field towards the charge. Okay. I don't have much time. We'll have to cover the entire chapter. But direct formula okay. So if you have a positive or negative charge, okay. So me charge whatever the value of the charge is, okay. Let us say it's plus Q or minus Q. So me charge at any given distance, okay, at a random distance, at a random distance r, if this is the point at which you want the value of electric field, and there first of all observe the charge, positive and negative. Positive, the field lines are always going to be away from the charge itself. Value kavalante sir, the value of field is nothing but the total force experienced by a unit charge placed at that distance. What are you talking, sir? This is theoretical language. You are not understanding any language, sir. Let us see this in terms of formula itself. Okay, what is formula? Formula is electric field E is equals to KQ divided by R. Finished. అయితే సార్ సేమ్ డిస్టెన్స్ తీసుకోండి కానీ వేరే పాయింట్ సేమ్ డిస్టెన్స్ వేరే పాయింట్ అంటే ఇది సార్ ఈ పాయింట్ లో కూడా సేమ్ వస్తాయి yes at this point also your electric field is same ఎంత సార్ E is equals to KQ divided by R square. అలాగే సార్ can we make the collection of such points? You definitely can make the collection of such points. What is it sir? Circle or sphere. అయితే if you consider an imaginary sphere around a charge, ఒక చార్జ్ తీసుకోండి, ఈ చార్జ్ కి అరౌండ్ ఒక ఇమాజినరీ స్ఫియర్ ఇమాజిన్ చేయండి. ఈ స్ఫియర్ కి ప్రతి ఒక్క పాయింట్ పైన ద ఎలక్ట్రిక్ ఫీల్డ్ వాల్యూ ఇస్ సేమ్ and the value of that charge field is KQ divided by R. K అంటే 1/4 pi epsilon naught. అదే the same story will repeat again. K value 1/4 pi epsilon naught permittivity of free space or vacuum if it is another medium. Either the field will decrease by K times. What is K sir? K is the dielectric of that material, the relative permittivity of that material itself. Okay, so capacitors అనే ఒక చాప్టర్ ఉంటుంది కదా. So capacitors లో we do have something known as dielectric constant. అలాగే here also we have relative permittivity. Both are used in the same extract. Okay, same meanings ఉంటుంది ఈ రెండిట్లో కూడా. How they are same sir? Because the distance is same కదా. ఇది కూడా distance r and this distance is also r, right? So ఇది కూడా distance r, this also distance r, this also distance r. ఇప్పుడు చూడండి అందరూ your electric formula ఏంట్రా? electric field is K into Q divided by R square కదా. Yes. So K value is fixed. So if you are fixing the medium, అయితే ఈ medium కోసమే K value is 100% fixed. అలాగే Q value is also fixed because you are fixing the charge itself. So ఈ charge ని మార్చిపోయినప్పుడు then the value of the field will change. కానీ ఒక ఫిక్స్డ్ చార్జ్ ఫిక్స్డ్ మీడియం కోసమే KQ ఫిక్స్ అయింది కదా. మరి ఓన్లీ వేరియబుల్ that you have is radius. So sir, if you have a point in space, ఈ పాయింట్ నుంచి equidistance point ఎక్కడెక్కడ ఉంటుందిరా? So all the equidistance points are there across a sphere. Circle की definition ఏంటి sir? Circle is the collection of points equidistant from a given point in the plane. అలాగే sphere की definition ఏంటి? Sphere is the collection of points in the 3D space equidistant from a given point. That given point is known as the center of that sphere. The charge always remains unchanged. Yes, Gayatri, charge always remains unchanged. Mamulgane observations kosame the charge will not change. Okay, but if you want to change the charge ante you basically have to do some operations. Earthing cheyandi leda bring some extra charge, remove some extra charge and all these things. Okay, yes. So with that being said, గుర్తుపెట్టుకోండి electric field at any random distance is given by KQ divided by R square. కానీ direction depends on the nature of the charge. Positive charge ఉన్నప్పుడు it is radially away from the charge. Negative charge ఉంటే it is radially towards the charge itself. Okay? Yes. అర్థమైంది అందరికీ? Right. Good. So now I want you to visualize that. ఇది చాలా complicated diagram కదా. Wasting the pages, increasing the number of PDF, increasing the storage of the mobile. చూడండి. So if it's a positive charge, okay, comparison చేద్దాం. Okay, plus Q charge ఉన్నప్పుడు the field line at a given distance. Okay, so imagine చేయండి, it's a sphere, right? It's not a circle. Okay, so whatever I'm drawing, it's not a circle, it's a sphere అందరూ. Okay, ఇది స్ఫియర్ అనుకోండి, ఇట్ ఈస్ అ స్ఫియర్. అయితే ఈ స్ఫియర్ కి ప్రతి ఒక్క పాయింట్ లో ద ఫీల్డ్ వాల్యూ ఇస్ సేమ్. ఎందుకంటే డిస్టెన్స్ ఇస్ సేమ్ కదా. డిస్టెన్స్ r ఉన్నప్పుడు ద ఫీల్డ్ వాల్యూ అట్ ఎవ్రీ సింగిల్ పాయింట్ ఆన్ ద స్ఫియర్ ఇస్ గివెన్ యాజ్ K into Q divided by R square. మరి సార్ పాజిటివ్ చార్జ్ ఉన్నప్పుడు ద ఫీల్డ్ ఇస్ డైరెక్టెడ్ రేడియల్లీ అవే ఫ్రమ్ ద చార్జ్ ఇట్ సెల్ఫ్. అలాగే నెగటివ్ చార్జ్ ఉంటే ఇట్ ఇస్ నాట్ లైక్ దిస్. ఓకే, నెగటివ్ చార్జ్ కోసమే అట్లా కాదు. సో ఇఫ్ యూ హ్యావ్ అ నెగటివ్ చార్జ్ మైనస్ క్యూ అనుకోండి. ఓకే, ఈ ఆర్ నెగటివ్ చార్జ్ రా బాబు, ఇది మైనస్ క్యూ చార్జ్ ఉంటే సిచ్యువేషన్ విల్ చేంజ్. ఓకే, హౌ ఇస్ ద సిచ్యువేషన్ చేంజింగ్ సార్? హౌ ఇస్ ఇట్ చేంజింగ్ అంటే ఈ స్ఫియర్ పైన ప్రతి ఒక్క పాయింట్ కోసమే ఫీల్డ్ మాత్రమే సేమ్ ఉంటుంది. ఓకే, yes, field is same. So sir, if I want the field at this point అంటే yes you can calculate sir. And direction అంటే towards the charge. Radius r ఉన్నప్పుడు your field E is nothing but KQ divided by R square. వచ్చింది కదా, towards the charge. That's it. So what will happen if you have two charges together now? Have you ever tried to visualize? J kada, it's going into G. Visualize చేయండి అందరూ. We want to stay at the ప్రాక్టికల్ గ్రౌండ్స్ కదా. అందరూ ఈ వీడియోని లైక్ చేయండి ఒకసారి. ఓకే, if everyone likes it, it goes 100 right now itself రా. ఓకే, ఫీల్డ్ వాల్యూ వచ్చింది మీ దగ్గర. yes, ఇప్పుడు let us discuss about the properties of field line. okay, అందరూ చూడండి, properties of field line. These are the spheres, okay, not circles అందరూ. so these are the spheres. spheres అంటే ఏంటి తెలుసా మీకు? so basically I can simply say that if we imagine text section ఉంటుందా లేదా ఇక్కడ, there was this text section, they have removed it. I don't know what happened to it. Sir, always positive is q and negative is q. No. Gayatri, it does not matter, okay? Positive, negative charge values may change or the values may not change. It's all up to you, okay? No. Plus q ante atla kaadu, always plus q minus atla kaadu, okay? You can also say minus q also. Both are same itself. No difference in this, okay? Plus q minus q kuda raavochu. But if you are taking plus charge, that means field line is going away from it. Negative charge unnappudu field line is coming towards it. That is the only difference, right? Good, very good. How can I say plus q or minus q? You can't say that, okay? You can't say that, right? So if we assume, okay, an imaginary sphere, okay, if we assume an imaginary sphere keeping the charge at the center, okay, keeping the charge at the center, appudu the electric field, okay, then the electric field at each point, okay, the electric field at the each point of that sphere, is the same, okay? Sphere is same. This is the most important statement under chudandi. So sphere ante it's a 3D shape. Ide kada? Yes. Eppudu let us talk about the properties of electric field, okay? Yes, andu. So now we are going to talk about the properties లేదా electric field lines discuss చేద్దాం మొదటిగా. So we have to talk something about the electric field lines. What are the properties of electric field line? First property మీ అందరికీ తెలుసు. So if it's a positive charge, the field line is radially outwards. Negative charge, point charge, okay, negative point charge, field line is radially converging అంటే towards itself, okay? First property is this. అందరు చూడండి. So if it's a positive charge, for a positive charge, okay, field lines are radially away from the charge, okay? Field lines are away from the charge. అలాగే if it's a negative charge కోసమే చెప్పండి అందరూ. If it's a negative charge, same thing, the field lines are towards the charge, okay? Field lines are towards the charge itself. Uchinda leda andu? Yes, field lines are towards the charge. Done. Point number 1 to be noted. Alage point number 2 regarding the electric field lines. Cheppandi, what is the second point, sir? The field lines will never intersect. Never intersect at the end, sir. Will they never intersect? Yes. Never cut, never touch, never intersect one another, okay? Electric field E bar, is a symbol of E bar, yes. Electric field lines never intersect one another, okay? Electric field lines never intersect each other, okay? Whatever be the condition, okay? Never intersect each other. Mari oka confusing condition untundi, okay? There is a confusing condition that I want to discuss. Very good. Okay, very good. So the situation looks something like this. You have two like charges, right? So this is a charge. Idi kuda you have one more charge. So these are the two like charges, and I want to draw the field line, okay? Positive charge anukondi, whatever you can take, okay? Positive charge. Now I want to draw the field line according to your first property. If positive charge is there, I get field line away from each other. That means for the left charge, the field line should go away. Idiko. Alage, me right charge kosami kuda field line should go away. So if they are going away, and there is a chance of accident kada. Accident. Sir, K is equals to, what are you saying? I did not see your message. Okay. Sir, K is equals to formula no plus positive Q and other negative Q only. No, Gayatri, adi kuda not compulsory, okay? Plus Q minus Q is completely depending on you. Letters aithe it got nothing to do with capital or small letters, okay? Nothing at all. Okay. Yes. So there is a chance of accident, kada. Mari, what is the condition? So if you keep on taking it, they will intersect one another. Mari, in one another intersection, kada. Then how are you going to stop this intersection? Ela stop cheyali sir ee intersection ni. You understand me? So if you have a positive charge, field lines are going away from the charge. Alagi, to this positive charge also, field lines are going away from the charge. So rendu positive charge, rendu field lines going away from one another, chances of hitting killa. Yes. But we don't want the field lines to intersect. But em cheyali sir? Ripples are not ripples, okay? At least I got one answer, no? Balraju has given the answer. Ripples, not ripples, okay? Not ripples. Okay, not ripples, curved, student. So they curve. I think the first field line that you have, student, okay? As soon as you bring out the two charges, they will communicate. In communication appudu, they'll just take the field lines and they'll curve one another. So this is the first field line, second field line. This accident ni avoid cheyadaniki they basically repel. Similarly, like this. Okay, similarly like this. 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 And so on and so forth. It's a question, okay? This question diagram gurtu pettukondi. It could any time be asked in your examination. So if you have two positive charges, the field line arrangement due to that two positive charges looks like dash. So four options will be there. Out of this is the correct option, okay? Good pettukondi. Under understanding, so direction of field line is like this. Student D. Okay. Yes. Done? Not done. So this is the condition. Basically, they will not intersect, they will not touch, they will not cross one another. Point number 3, the property number 3, sir, electric field lines, okay, E bar lines never form closed loops, okay, never form closed loops. There is exception, induced electric field ane oka exception kuda untundi. Deentlo we will be talking that in your electromagnetic induction, okay? In your electromagnetic induction, when you change the magnetic flux, there is an electric field induced, okay? So there is an induced electric field with corresponding to the change in the magnetic flux. So that induced electric field always exists in closed situation, okay? Student, never form closed loops. Point number 1. Point number 3, okay? Fourth point, student. So, work done by the electric field lines, okay? Work done by electric field on charge in a closed loop, okay? In a closed loop is always 0. Always 0. I take conservative field. Electric field is conservative in nature, okay? Is always 0. Clear? Yes. That means your electric field is conservative in nature, okay? Enter raskondi. Electric field E bar is conservative. Very conservative at the end, sir. That means it is conserving the total energy of the system. Potential to kinetic to potential, total energy matrame conservative avutadi, okay? Yes, electric field is conservative, okay? Done. Ippudu units cheppandi endaru. Units should be very strong, okay? Units and dimensions kada. So that is the basic chapter. So prati okka quantity kosame units matrame 100% clear ga undali. What is the formula for electric field? Idigo ippudu units kosame I am telling you one more formula andaru. Unit of electric field kada cheppandi. So unit of electric field E bar is nothing but F bar divided by Q. Kani deentlo kuda oka malli long story untundi, which is charge, what is the electric field, what is the force. Idigo if you have two different charges, again I basically want to take out that entire bag of discussion and again I will have to explain every single thing. Ide charge q1 anukondi, this is the charge q2, ee rendulo distance r anukondi, capital R. Now if you want to calculate the field due to q1, okay, electric field due to q1 andaru cheppandi. So electric field due to q1 is equals to total force between the charges divided by the second charge, okay, q2. గుర్తుపెట్టుకోండి. అలాగే electric field due to q2 is nothing but total force divided by the opposite charge q1. అర్థమైంది? Okay, this is the condition. కాబట్టి యూనిట్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్ అంటే F bar by Q కదా. ఫోర్స్ కి న్యూటన్ ఏంట్రా? న్యూటన్ పర్ కూలంబ్. చార్జ్ కి యూనిట్ కూలంబ్ కదా. yes. So electric field ki unit is what, sir? The unit of electric field is Newton per Coulomb. Gravitational field Newton per kg. Electric potential, sir. Electric potential, sir. What is electric potential? Cheppandi andaru. Done? Not done. Yes. So this is all about the electric field. Now this electric field is a vector quantity kada. So now you basically talk about superposition once again. Idigo superposition ide kada. Are ends are the superposition of the field. Okay, superposition of the field. Again the same things, sir. E net bar is equals to E1 bar plus E2 bar plus E3 bar and so on and so forth. Done? Not done. Right? If you have two different charges, idigo first charge q1 anukondi, okay, alage second charge q2 anukondi, and let us say you want the field at this point, electric field at point A. If distance r1 anukondi andaru. So if this distance is r1 and this distance is r2, ee angle theta vachinappudu you will simply say that the net field at point A kada. Yes. So sir, net electric field, net E bar at point A. What is the formula? E net is equals to E1 bar plus E2 bar. Ide kada. E1 bar ki formula enti? K Q1 divided by R1 bar square plus K vector formula kada. Vector formula andaru. Yes. So let us do one thing. R1 bar by R cube. R1 bar by R cube. Vector formula representation kavalante R cube raskoni here divided by R1 bar. Alage plus k times of q2 divided by r2 cube into r2 bar. Okay, you basically have to add the two vectors. Either root of idigo ee mottam value ni e1 kada, so it is nothing but e1 square plus e2 square plus 2 times of e1 times of e2 times of cos of angle theta, depending upon the conditions. If you have the value of angle theta, well and good. Ledante then give you. Okay. Yes, good afternoon everybody. Good afternoon andarki. Yes, andaru NLM ledra ikkada. NM sara. NM ante entra. Newton meter. Newton NM ante enti. I am not understanding. Sir, done? Not done. Now there is a very famous formula. Okay, I want everybody to remember this formula. Andaru. Okay, null point ane oka point untundi. Null point. It's for Jaira. I'm not going deep into the discussion. Okay, let us keep the discussion restricted. Chudandi andaru. So null points ante if you have two charges and let us say the nature of the two charges is same. Aithe idigo ee plus q1 charge anukondi, alage this charge is plus q2. Okay, capital small letters lo don't get confused. Okay, plus q1 plus q2 anukondi, that's it. So sir, if you take a general point ide general point, ee general point paina if you want to talk about the net electric field, okay, net electric field superposition kada, so you have to take the vector sum of the two fields. So if you're talking about the superposition ante E1 bar plus E2 bar value calculate cheyali ide kada. So if you have a plus q charge, the electric field E1 bar will be directed away from the charge. Alage second charge q2 unte E2 bar will again be directed away from the charge itself. Okay, andaru. Now if you have the total distance d between the two charges, what is the distance of the point from any one of the charge? Idigo total distance d anukondi, alage should I remove it? Yes, I think I should remove it. Idigo ee point of time lo your net electric field is 0. Okay, yes, this is your point ra ee distance d1 anukondi, alage this distance over here is d2 ide kada. Yes, So sir, at that point only the electric field is a zero. Mari d1 d2 value kavali kada. So d1 d2 value kosame gurtu pettukondi, formula maatrame gurtu pettukondi. Okay, so sir, k capital Q1 divided by d1 square should be equals to k capital Q2 divided by d2 square. Done? Yes. చెప్పండి మరి ఏం చేయాలి? ఫీల్డ్స్ మాత్రమే సేమ్ ఉండాలి కదా. k gone. So sir, Q1 divided by Q2 is equals to d1 square divided by d2 square. Square root తీసుకోండి, అయితే d1 divided by d2 is equals to root of Q1 divided by Q2. It is having a PYQ based on this formula. ఇది చాలా important, okay, చాలా important. Focus చేయండి, that's it. So if you want the value of d1 only, మళ్ళీ ఒక ఫార్ములా ఉంటుంది, d1 plus d2 కదరా. సో ఈ రెండు డిస్టెన్స్ ని యాడ్ చేసినప్పుడు your total distance is d. Okay, one more formula that we have, sir, d1 plus d2 total distance kada, and that value is d. అదే మరి ఈ రేషియోని కాంపోనెంట్ చేయండి. కాంపోనెంట్ డివిడెండ్ అనే ఒక ప్రాపర్టీ ఉంటుంది కదా. yes, so if the value of d1 divided by d2 is root of q1 divided by root q2, that's it. So sir, d1 plus d2 divided d2 is root q1 plus root q2 divided by root q2. d1 plus d2 అంటే d కదా, substitute. Total distance d by d2 is equals to root of q1 plus root of q2 divided by root of q2. ఇప్పుడు ఇన్వర్ట్ into చేయండి, take the reverse of it. So when you are reversing it, you will get one more property. So sir, d2 divided by d is equals to root of q2 divided by root of q1 plus root of q2. వచ్చింది కదా. ఇక్కడ నుంచి d2 వాల్యూ వస్తే రా బాబు, d2 is equals to root of q2 divided by root of q1 plus root q2 multiplied by total distance d. అలాగే if you want to find the value of d1 also, you can simply say symmetry kada ఇది. So sir, distance d1 కావాలంటే root of q1 divided by root of q1 plus root of q2 whole multiplied by the distance d. Okay, ఇదే d1 ఫార్ములా, this is d2 ఫార్ములా. అందరూ ఇది చాలా ఇంపార్టెంట్ సార్. ఇక్కడ root q2 by root q2 cancel over. No, not cancelling. Okay, so it only cancels when you have root q2 by q2. So if you say 2 divided by 2 plus 4, if you cancel this 2 అంటే 1 by 4 answer రా. But if you see the answer, so 2 divided by 2 plus 4 is 6. Final answer is 1 by 3. ఇదే కదా, you cannot cancel out 2. గుర్తుపెట్టుకోండి, mathematical properties. Okay, formulas మాత్రమే గుర్తుపెట్టుకోండి. Okay, good. Can't understand it. If you don't understand, speed up. Yes, we have to speed up. Done. Electric field అయిపోయింది కదా. Yes, based on electric field we do have some questions. ఇదిగో ఎలక్ట్రిక్ ఫీల్డ్ లైన్స్ కదా. Take this question. The given figure gives electric line of forces due to two charges Q1 and Q2. What are the signs? For Q1 charge కోసమే field lines చూడండి ఒకసారి. So the field lines are coming towards Q1 charge. ఇదే కదా. These are the field lines. Okay. అలాగే Q2 charge కోసమే these are the field lines. That means both the field lines are coming towards the charges ra. అంటే ఏంటి sir? That means both the charges are negative. Negative ఉండాలి. Okay? Both charges should be negative. Done? Mr. Funny Boy here in this class, no one talking with me. Hello, Indriki. Yes. That means both the charges should be negative. ఏది నా ఆప్షన్స్ ఉంటే టిక్ చేయొచ్చు కదా. Yes. Next part, Rabab. Next part, okay? Andaru. For the next part of the discussion, field completed kada. Electric field అయిపోయింది అందరూ. Now we are going to talk about the next topic, అంటే electric potential. Coulomb's law done, field done. Let us talk about the potential. Field law, there is one more thing that I have just skipped. Okay, మళ్ళీ ఒక discussion run. There is one more discussion that I have just skipped under. So let us take the discussion and then we will move on. Okay, electric field due to spheres. Okay, electric field E bar due to spheres. ఇది చాలా 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 important. అందరూ చూడండి, graphs, formulas, every single thing could be asked over here. Okay, electric field due to spheres. So మామూలుగానే you can basically classify your spheres into two types, okay? Your spheres could be classified into two categories. So మామూలుగానే మీ దగ్గర sphere ఉన్నప్పుడు you can basically categorize this sphere into two categories. చూడండి, first one is your solid sphere. Alage, the second one is the hollow sphere, okay? Yes, hollow and solid. Give me 1 minute. So first one is your hollow sphere, okay? The second one is your solid sphere. ఇదే కదా. ఇప్పుడు సాలిడ్ లో రెండు రకాలు ఉన్నాయి. The first type is conducting sphere. Okay, solid low, first type of sphere that you have is conducting sphere. The second type that you have is the non-conducting sphere. Andaru chudandi, non-conducting kada, and this is the important part of the discussion. So if you have sphere deetlo kuda solid and also conducting ante, the two cases are same, ante it will match exactly a hollow sphere condition. Okay, hollow sphere condition. Hollow lo conducting, non-conducting ledu asalu, okay? So if you want to talk about conducting sphere, non-conducting sphere in a hollow part ante, it becomes very complicated, goes to JEE advanced level, okay? Mains, not even mains, NEET purpose kosame you basically have to talk about a hollow sphere, and that also conducting hollow sphere, okay? Yes, whenever you say about hollow, right, is assume that is conducting hollow, okay? Hollow and conducting, they give same results, okay? Ippudu మూడు positions ఉన్నాయి, okay? So if you have hollow sphere that is conducting sphere, you have three different positions. Position number 1 ra internal position kosame for internal points. Andaru internal points ante electric field inside the hollow sphere leda inside the solid conducting sphere is always zero. Electric field zero, okay? Alage on the surface paina electric field kavalante, this is your sphere. ఈ స్ఫియర్ పైన ప్లస్ q చార్జ్ అనుకోండి, ఓకే? చార్జ్ ప్లస్ q, రేడియస్ r. if you are assuming this, so sir, electric field on the surface is nothing but kq divided by r square. అలాగే external points కోసమే you will basically talk about it. చెప్పండి అందరూ. So this is the sphere, plus q charge అనుకోండి on the surface itself, and small r అంటే distance of the point where you want the electric field, okay? Distance of point where you want the electric field. Aithe your electric field is simply equals to చెప్పండి అందరూ ఏంట్రా, k into small k capital Q కదా, అరే k capital Q divided by small r square. వచ్చిందా లేదా అందరూ? Yes. So this is the exact condition about your hollow conducting sphere. Graph కావాలంటే graph తీసుకోండి, okay? Graphs are also very important. So the graph of electric field versus distance kada. Yes, so this is the distance r, ide electric field e anukondi andaru. So the graph looks something like this. Chudandi, so this is your electric field from 0 ra. So r is equals to 0 ante origin nunchi the surface varaku the field line is always 0. Ante exactly at the point r is equals to capital R ante surface point kada, ee point nunchi the field starts decreasing gradually till infinity. Ade okay, మరి ఫీల్డ్ వాల్యూ ఎంత సార్? k capital Q divided by r square. That's the graph for the hollow లేదా solid conducting sphere or hollow conducting sphere. Both are the same. Done? Yes. Similarly for the solid sphere, ikkada you have the real deal, okay? The real discussion is just lying for your solid spheres. So solid lo kuda non conducting unnappudu you have three different positions, okay? అర్థం చేసుకోండి అందరూ, ఇది చాలా 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 ఇంపార్టెంట్. నాన్ కండక్టింగ్ కోసమే you have three more positions. చెప్పండి, three positions are something like this. First position అంటే outside point రా, I'm doing it in the reverse, అంటే outside నుంచి స్టార్ట్ చేయండి. సో బయటికి నుంచి లోపల రావాలి, ఓకే? outside point, అలాగే electric field on the surface, and lastly you have electric field in the internal point, okay? Internal point ante r is equals to small r తీసుకోండి, okay? Internal point. So this is the third position లేదా internal position. ఇదే కదా student. So when you talk about electric field outside raba, so outside field kosame this is completely solid sphere kada. total charge capital Q, radius R ra, kani binding point distance R anukondi, your electric field is just like the normal field ra. What is the electric field, sir? E is equals to K capital Q divided by R square. Finished. Alage surface lo kuda edina problem ledhu asalu. So on the surface also, this is your solid non-conducting sphere, total charge Q, total radius R unte, surface point paina electric field is almost same itself. So electric field on the surface is again equals to KQ by capital R square. R ante radius, okay? Kani internal points kosame matram it is going to be little lengthy leda hectic anukoni, okay? Yes. So if you want the electric field in the internal point due to the solid non-conducting sphere, either the formula for the general point R anukondi ide kada. But sir, if you want the electric field at the distance R, okay, point A anukondi sir. So electric field at point A is equals to K capital Q small r divided by capital R whole cube, okay? Good pet point. This is the formula. This is the formula. But graph kavali kada. So graph kosam I think we need to restrict this entire discussion again. Okay. So if you want to draw the graph kosam, the graph looks something like this. Student, మరి ఒకసారి distance versus electric field. Distance R, electric field E kada. Yes. So when you talk about the graph, sir, the graph should look something like this. Idigo directly proportional to distance kada. E K Q by R. Ante your electric field is directly proportional to distance. E point of time lo electric field constant K. E point of time lo electric field inversely proportional to R square. Outside points, inside points. Inside surface, outside. Inside surface, outside. Inside kosame directly proportional. Surface kosame constant. Outside kosame inversely proportional to R square. So inside ante directly proportional up to the radius mark. Okay. R is equals to R. But sir, this point lo electric field value anta sir K times of capital Q divided by R square. But ikkada nunchi again the field will drop. That's it. Okay, graph difference chudandi. Ekkada it's a straight line. Okay, there. But here it's not a straight line. It's just 0, 0, 0. Okay, sir, this is common, sir. Hollow or solid conducting. Okay, I wasn't able to see your message. Let me see it again. Sir, this is common, sir. Hollow or solid conducting. Okay. Charge. Yes. Gayatri, it is common. Okay, 100% common. If you have a solid conducting sphere, that means the entire charge is going to come out of the surface. Electrostatic equilibrium ane oka condition untundi. That means if you have no external electric field or no external electric potential, in point of time lo, you see the internal point of the conductor, and at that internal point the field is always going to be 0. Okay, good petkondi. Statement are star mark petti statement raskondi andaru. So statement is this: at electrostatic equilibrium, okay, at the electrostatic equilibrium, what is the condition, sir? Good petkondi. Electric field inside the conductor, okay, electric field inside the conductor is always 0, okay, always 0. But what do you mean by electrostatic equilibrium, sir? And there should not be any external electric field or any external electric potential. Field ochindante there will be induced electric field now, depending upon the conditions. Okay. Yes. Okay, done. Now let us talk about the potential, most important topic now. Okay. Yes, andaru electric potential kada. It goes in lots and lots of deep discussion. I'm avoiding it. It's not there for your syllabus kada. So it depends on the type of material also. Okay, if it's a conductor in there, electrostatic equilibrium should be 0. That means electrostatic equilibrium will be attained when the external field is variable. Okay, variable external field kada. So if external field is balanced, the charge will rearrange the conductor will rearrange the charges. This rearrange process kosame at that point of time the field inside the conductor will not be 0. So if it's a graphs, mali explain cheyandi sir. Graphs and nothing to remember. Okay, good petko. Okay, so let me just draw the graph. Okay, once again let me draw the graph. Idigo, so E versus R graph. E versus R graph. And electric field versus distance graph kada. Chudandi. So this is for the conducting or the hollow sphere. Ide for non-conducting solid sphere kada. This is for the conducting. This graph is for conducting or hollow sphere. Okay, conducting solid or hollow sphere. Rendu kosame kuda conducting solid sphere leda hollow sphere. Okay, yes. Similarly, this graph is for solid non-conducting sphere. Okay, solid non-conducting sphere. So what do you have to do? X-axis lo always distance. Y-axis lo you will always have electric field. Alage here also X-axis lo you will always have distance, and on the Y-axis you always have electric field. Ide kada? Yes. So when you have conducting or hollow sphere, the point of time lo idigo oka special point ra r is equals to capital R ante radius of the sphere. Ikkada kuda r is equals to capital R ante radius of the sphere. So sir, from r is equals to 0, ide kada r is equals to 0. Here also r is equals to 0. Graph is the most important stuff. Okay. So r is equals to 0 to r is equals to r. Your field is on the x-axis. That is 0. No field along the x-axis itself. Kani ekkada atla kaadu. So r is equals to 0 to r is equals to r. The field line will go up ra. There is no up kada. Sleeping ra. Continue 0. But sir, common ippadi nunchi everything is common. Okay. So when you reach this r is equals to r point, now the field line will decrease gradually in a parabolic path. Okay. Here also almost the same thing. So till r is equals to r, field line is straight. Kani r tarvata it is going down itself. Okay. Yes. E values matrame gurtundali sir. So e point of time lo this is the graph kada. So what is the value of this height? E height value kavalante electric field is equals to kq divided by r square. Here also the same thing. So if you want the value of this height at day, electric field is equals to kq divided by r square. Okay, done. This one. Break is coming at 4 or 4:15, 4:30. Okay, 4:30 lo we'll have a break. Okay, done. Now let us talk about electric potential. And the electric potential is your electric potential it is nothing but the work done per unit charge, okay, to bring that charge from infinity to a given distance close to the another charge itself. Okay, casual ka maan. Focus here. Okay guys, focus here. Right? Not right? Idi oka chudandi. So I'm not going into the deep definitions. Formula kavali kada, formula teeskondi. Formula is this. So if you have a plus q charge, positive, negative, ekkada electric potential is a scalar quantity. Okay, scalar quantity but the superposition and everything is not here. Okay, scalar quantity. So sir, plus q charge unte, if you want the potential due to this plus q charge at a given point and telusa meeku a distance anukondi, if distance is r, if this distance is r, aithe sir ee point lo potential enta. So potential at this point is given as kq divided by r andaru. And one more thing, okay, there is nothing known as the absolute potential. So eppudaina potential gurinchi maatladide we always talk about potential difference. But sir enduku v rasavu sir ikkada? Because whenever I say v, it is the potential difference between 2 points. First point ante ide, alage second point is the infinite point ante infinity and this point potential difference ante v at this point only. Done? Not done. And then yes, so sir potential due to a charge is given by kq by r. So positive charge unte plus raskondi, negative charge unnappudu minus raskondi. That's it. So if it's a negative charge babu, minus q charge unnappudu at the same distance r, potential at this point v at a kada. So potential at point A is given as minus k into capital Q divided by r. Chudandi. So these are the two formulas. Now here you don't have anything like superposition of the potential. Okay, directly add cheyochu. So sir, potential net is equals to simply V1 plus V2 plus V3 plus so on so on. Done. What is the unit of potential, sir? Cheppandi. The unit of potential kada. Potential formula enti? First of all, there is a relationship between potential and field. Okay, this is chala important. Relation between electric field E bar and potential V. ఇదే కదా. What is the relationship, sir? So if you want electric field E bar అంటే del V by del x I cap plus del V by del y j cap. అరే సింప్లీ డిఫరెన్షియేట్ చేయండి రా బాబు. ఓకే, del V by del z into k cap. What is that? Partial derivative, sir. Partial derivative. Nothing at all. Nothing at all. Okay. అలాగే if you want electric potential from field అంటే ఆ కోసమే కూడా the formula is different. So sir, potential is nothing but negative of integral of E bar dot dx bar లేదా dr bar లేదా dl bar అంటే చిన్న చిన్న లెన్స్ తీసుకోండి. Okay. Yes. So if you want this as the formula, question తీసుకోండి. Okay. If the potential V is equals to 3x square y plus 3yz plus 3xz square. Full stop. Find. ఏం కావాలి? Find the electric field. That's it. Okay. మరి ఎలా క్యాలిక్యులేట్ చేయాలి సార్? ఎలక్ట్రిక్ ఫీల్డ్ E bar is del V by del x I cap plus del V by del y j cap plus del V by del z k cap. అయితే del by del x of కంప్లీట్ ఎలక్ట్రిక్ ఫీల్డ్ చెప్పండి. సో ఎక్కడైనా xx ఉన్నప్పుడు డిఫరెన్షియేట్ చేయండి. సో ఇఫ్ యు ఆర్ డిఫరెన్షియేటింగ్ ఇట్, ఫైనల్ ఆన్సర్ రాస్తున్నారు అందరూ. యూ క్యాన్ ఆఫ్టర్ దిస్ క్లాస్ ఈ క్లాస్ తర్వాత మీరు సొంతంగా కూర్చి యూ క్యాన్ అనలైజ్ దిస్. ఓకే, ఐఎమ్ జస్ట్ గోయింగ్ టు రైట్ ద ఫైనల్ ఆన్సర్. చూడండి, సో పార్షియల్ డెరివేటివ్ విత్ రెస్పెక్ట్ టు ఎక్స్ ఏంటి సార్? అది 6y ప్లస్ 6z కదా, నాట్ 6z రా, 3z కదా. ఎస్. సో సార్ ఎలక్ట్రిక్ ఫీల్డ్ E bar is nothing but 6xy ప్లస్ 3z స్క్వేర్ I cap ప్లస్ ఇప్పుడు చెప్పండి, యాక్చువల్లీ ఇట్ షుడ్ బి మైనస్. గుర్తుపెట్టుకోండి, ఇట్ షుడ్ బి మైనస్. సో ఇఫ్ యు ఆర్ రైటింగ్ టేక్ ఎ మైనస్. అలాగే j క్యాప్ లో కూడా పార్షియల్ డెరివేటివ్ ఆఫ్ y చేయండి. సో హియర్ ఇట్ ఇస్ 3x స్క్వేర్ ప్లస్ 3z j క్యాప్ ప్లస్ పార్షియల్ డెరివేటివ్ విత్ రెస్పెక్ట్ టు z అంటే హియర్ ఇస్ z, హియర్ ఇస్ z. సో సార్ ఫైనల్ ఆన్సర్ అంటే 3y plus 6xz k cap. That's it. Negative sign. So this is electric field under. Okay. So now differentiation ravatledu. So you can practice. Okay, Gayatri, you have to practice it. Understanding? There's no other option. Exam hall lo nobody will be yes. Alage V is equals to integral of minus e into dx. So question ante ide, if the value of electric field E is given as kq divided by x square, full stop. Find the potential at distance r. Okay, at a distance r kada చెప్పండి. సో సార్ V is equals to negative of integral E bar dot dx bar. ఇదే కదా, అంటే negative of at a distance r కావాలంటే 0 నుంచి స్టార్ట్ చేయండి r వరకు. That's it. So ఈ వాల్యూ సబ్స్టిట్యూట్ చేయండి. What is the value of E? kq divided by x square into dx. నెగటివ్ సైన్ కదా. ఇప్పుడు ఇంటిగ్రల్ ఆఫ్ kq కామన్ తీసుకోండి, కాన్స్టెంట్ కదా, బయటికి తీసుకోండి, డివైడెడ్ బై మైనస్ 6 రా. దిస్ ఈస్ ద వాల్యూ 0 to r, బట్ దేర్ ఇస్ వన్ మోర్ మైనస్ సైన్ అవుట్ సైడ్. సో ఇదే, దిస్ ఈస్ ద పొటెన్షియల్ వాల్యూ సార్, నెగటివ్ ఆఫ్ చెప్పండి kq డివైడెడ్ బై అప్పర్ లిమిట్ అంటే మైనస్ r, లోవర్ లిమిట్ ఇస్ 0. ఇదే కదా. దట్స్ ఇట్. నాట్ ఇన్ఫినిటీ, నాట్ 0, ఇట్ షుడ్ బి యాక్చువల్లీ ఇన్ఫినిటీ. ఫ్రమ్ ఇన్ఫినిటీ కదా, ఫ్రమ్ ఇన్ఫినిటీ చెప్పండి. So minus minus gone ra, kq divided by r. So this is the potential formula due to a point charge. Okay, yes. Now let's talk about the potential energy. Okay, under potential energy. Started the class at 1:40 kada, 1:45, 1:40 and 3:40, 2 hours gone, almost 2 hours. I just gave it. Okay, sir. అందరూ ఈ వీడియోని లైక్ చేయండి ఒకసారి. yes, పొటెన్షియల్ ఎనర్జీ అంటే చూడండి. సో పొటెన్షియల్ ఎనర్జీ మామూలుగానే u is nothing but minus q multiplied by q. okay, negative sign only for the attractive part. Okay, attractive part అంటే if you have two charges, if it's a negative charge, negative both end are, you will get confused in negative and positive charges. Okay, so potential energy is equals to q into v. ఇదే అయితే v అంటే ఏంటి సార్? పొటెన్షియల్ డ్యూ టు పాయింట్ చార్జ్ కదా. చూడండి, సో ఇఫ్ యూ హ్యావ్ అ పాయింట్ చార్జ్ ప్లస్ q1, అలాగే ఇఫ్ యూ హ్యావ్ అ పాయింట్ చార్జ్ ప్లస్ q2, ఇదే కదా, there is this distance r రా, అంటే potential energy is nothing but charge q2 multiplied by potential due to charge qv1, okay, q1. అలాగే if you want to write potential energy, it is charge q1 multiplied by potential due to charge q2. గుర్తుపెట్టుకోండి, వేరే వేరే చార్జెస్ ఉండేరా, okay, don't get confused అందరూ, okay, you might get confused looking at this formula, కానీ confuse class up to start in friends. The class has started at 1:40 p.m. okay, 1:40 p.m. Sir, charge student important charge unte I am definitely seeing it, okay. Candy sir, ella unnaru sir, handsome sir, these comments are I am just skipping because we don't have much time. ఇదే కదా పొటెన్షియల్ ఎనర్జీ ఆఫ్ ద సిస్టమ్ గురించి మాట్లాడుతున్నారు చూడండి, ఇదే కదా. yes ఇప్పుడు there is something known as work done kada, work done ra, but I don't want to go into that much of detail. Sare, this is fine, okay. So multi charges system kada, yes, మీ multi charges system kosame the potential energy will be different. చూడండి, so this is the potential energy due to two charges. కానీ if you have multiple charges kosame the formula is different. yes and multiple charge system, okay, లేదా multi charge system కోసమే potential energy రావాలి. So if you have multiple charges system, then assume it. So first charge, second charge, third charge, fourth charge, 4 charges తీసుకోండి. You can also talk about the corresponding distances between the charges andaru. Ee distance r1 anukondi, this distance is r2, this distance is r3, this distance is r4, alage this distance r5 and this distance is r6, okay. yes, diagonal values ra andaru confusing avadi, don't get confused. r5 ante this distance, okay, alage r6 ante this distance. Done? Not done. yes. ఇప్పుడు you can give the values to the charges also. So idigo charge q1, charge q2, charge q3, charge q4. So if you want the total energy of the system ante, you will say sir potential energy net is equals to potential energy 1 లేదా sum of all the potential energies. So ఈ point of time lo you basically have to make the pairs of two charges. ఎన్ని pairs ఉన్నాయి sir? There are 4 charges కాబట్టి there will be 6 pairs. 3 charges ఉన్నప్పుడు 3 pairs will be there. 4 charges కాబట్టి 4 pairs will be 6 pairs will be there, okay. First pairs prepare చేయండి. First pair charge q1 q2, second pair will be of the charge q2 q3, third charge ra babu q1 q3, then you have q1 q4, okay. q1 pairs completed. ఇప్పుడు q2 చూడండి, q2 q3 q2 q4 కదా. yes, ఎన్ని ఉన్నాయి సార్? 5 కదా. and you are left with q1 q4 got q3 q4. last pair will be q3 q4. that's it. ఇప్పుడు ఈ రెండు pairs కి మధ్యలో డిస్టెన్స్ రాసుకోండి. సో q1 q2 has distance r2, అలాగే q1 q3 has distance r5. similarly q1 q4 has distance of r3, q2 q3 distance r1 yes r1 అలాగే q2 q4 distance r6 అలాగే q3 q4 distance is r4. substitute the values sir. so potential energy net is equals to k multiplied by first pair ఏంట్రాది q1 q2 divided by distance ఏంటి sir? r2 plus second pair sir k multiplied by q1 q3 divided by distance is r5 plus third pair sir k multiplied by q1 q4 divided by distance is r3 plus k multiplied by చెప్పండి, you can write everything కదా, ఇప్పుడు యాడ్ చేయండి. that's it. so that is the total potential energy of the system. done. so if you want to change the energy of the system ante ee system paina work cheyali. so what is the work done on the system ante total change in the potential energy of the system. so you can also calculate the work done, okay. లేదా to change the energies of the kinetic energy of the system kuda you basically have to talk about the work done. ide kada. yes, you can write it. done. now let us break kavaliya. you need the break or what? Yes. Andaru, am I audible? Not audible, right? Potential happening. The potential energy also completed. Now let us talk about dipole. Okay. I don't think 10 charges uste kada. Not 10 charges, right? There will be 4 charges and 6 pairs. Okay, that's it. Not 10 charges. There are 5 charges. 4 charges only. Okay, 4 charges only. 4 charges only. Where are 10 charges? Only 4 charges, right? Q1, Q2, Q3, Q4. 6 pairs will be there. 1, 2, 3, 4, 5, 6. 6 pairs at 12 different expressions will be there. Okay. Yes, all the charges should be coming. Right. So dipole ante it's a special type of electrostatic arrangement. This arrangement lo mee daggara rendu charges undi. First is positive charge, second is negative charge. Okay. Yes. So first charge is plus Q, alage second charge is minus Q. Andaru chudandi. Ee charges ki madhyalo separation between the charges. It is usually represented by 2 times the distance d. Ide kada? Yes. So if you want to talk about the various quantities of this dipole, okay, first of all we are going to talk about the dipole moment. Okay. What do you mean by the dipole moment, sir? Dipole moment ante strength of this system maamulgane ide. So if you want to talk about dipole moment, it is usually represented by letter P. Okay, andaru chudandi. What is dipole moment? First of all, this dipole moment is a vector quantity. Where is the application, sir? The practical application is there in your chemistry. Molecules, polar molecules, non-polar molecules. H2O is a polar molecule, non-polar molecule. All these things, okay? Linear molecules, CO2 is a non-polar molecule. H2O is a polar molecule. So you talk about polar dipole moment from that. Okay, andaru, yes. Dipole moment ante it is represented by the letter P bar, and the value of the dipole moment ante Q multiplied by the distance 2d. Okay, vector quantity unnappudu that dipole moment also has the direction. So the direction of the dipole moment is direction kada. Yes, so for the dipole moment the direction is from negative Q charge to positive Q charge, from minus Q to plus Q charge. Ide kada? Yes, so this is the direction of the dipole moment. Andaru chudandi. Yes. So either if this is your minus Q charge, if this is your minus Q charge, ide kada minus Q charge. Alage if this is your plus Q charge, andaru plus Q charge unnappudu the dipole moment direction will be from minus Q to plus Q charge. Dipole moment ante mu. Okay, P bar leda mu maamulugane P bar represented. Okay, ippudu chudandi formulas undi, you just have to remember those formulas, that's it. Okay, so if you are good with those formulas, nothing more is required. Formulas, okay, formulas leda quantities. Number 1, we talk about electric field due to this dipole andaru. So electric field kosami kuda you have 3 different positions where you can find the electric field due to dipole. Number 1, it is your axial position. Okay, number 2, sir, equatorial position. Alage number 3 is the general position. Ide kada. And third position ante general position. Formula gurtu pettukondi, more than sufficient. Okay, if you remember the formulas, that is more than sufficient. Right? Axial position ante entra. So in your axial position, your dipole will be looking something like this. Either negative charge, this is your positive charge, minus Q plus Q. Okay, distance 2d anukondi. And axial position ante at this point. Okay. And always remember the distance will be taken from the midpoint of the dipole. This distance R anukondi. That's it. So electric field at the axis of the dipole is given as Kp divided by Rq. Ide kada? Yes. 2Kp by R. Okay. Similarly, equatorial points kada. Equatorial points kosame cheppandi andaru. For your equatorial points, this is a negative charge minus Q. Ide positive charge plus Q anukondi. Equatorial point and a point on the perpendicular bisector of this dipole. Okay. Yes. So let us say the distance mali okkasari distance 2d anukondi, and the equatorial point ante it will be the equatorial distance d anukondi from the center. Ide kada. Now you talk about the electric field, it is simply equals to Kp divided by Rq. Okay, P ante dipole moment. Okay, andaru chudandi dipole moment ante 2 into Q into d. Ade. Similarly, general point paina electric field kavalante you have one more formula for the electric field at the general point. So this is your minus Q charge. Alage this is your plus Q charge. Ide kada. Getting too lengthy. I'm trying to finish this chapter as soon as possible. And not happening. By em cheyal sir. Adi kuda naaku kuda teliyadu. Chudandi. Let us say the distance between the two charges will be written something like this. Okay. And if you want the electric field at a general point, this should be the line making an angle theta, e point distance r anukondi. So electric field at angle point theta is given as, what is the formula for electric field? Kp divided by r cube into root of 1 plus 3 cos square theta. Done? Not done. Similarly, we talk about electric potential also. Okay, this is electric field. Alage we have electric potential. Formulas are very clear. Okay, electric potential under. Cheppandi. So if this alage 3 points kada. Position number A, axial point by the electric potential. Option number B is your equatorial point. Okay. Option B, equatorial point, and lastly you have general point. So third position ఏంటంటే general position తీసుకోండి. ఇదే కదా. So for axial points, sir, these are your two charges. ఇదే అనుకోండి, charge q1, charge q2, this is the axis. ఇదే కదా, మరి డిస్టెన్స్ కూడా సెంటర్ నుంచి క్యాలిక్యులేట్ చేయాలి. సో దిస్ ఇస్ ద సెంటర్ పాయింట్ అండ్ దిస్ డిస్టెన్స్ ఇస్ r. If you want the potential at this point, so potential V is equals to, at the axial point kada, point A అనుకోండి. So potential at point E is given as Kp divided by r square. That's it. Okay, equatorial point ante the 2 points will look something like this. So this is your minus q charge, this is your plus q charge. Ee rendu points ki madhyalo distance 2d anukondi, and the equatorial point will look something like this. So this is the equatorial point, distance r unnappudu potential at point A is always 0. Endukante potential is a scalar quantity. Idi vector kaadu. Okay, it's a scalar quantity. Andaru clear or not clear? And similarly, for a general point, it is Kp by r square into cos theta. That's it. So for a general point kosame, idigo, this is minus q charge, this is plus q charge, and distance r anukondi ee rendu ki madhyalo. And then there is this general point kada. This is the general point. Ante angle theta, distance r unnappudu potential at a general point theta is given as Kp into cos of theta divided by r square. Done. Okay. Now let us talk about 2-3 more formulas. The first one is the torque on the dipole. Okay, formula number 3 under weighting torque on the electric dipole. Okay, torque on the electric dipole. Similarly, we will have energy of the dipole, lay the work done to rotate the dipole in the external electric field. Yes. Torque on the electric dipole. Ide kada. Yes, so torque kosame you need the external electric field. Andaru idi చాలా important. Okay, yes, so you need the value of external electric field. Idigo, you assume that this electric field is E bar. Alage ee external electric field lo oka dipole imagine cheyandi. This charge is minus q, alage this charge is plus q kada. Angle theta anukondi andaru. So here you can talk about torque is nothing but p bar cross e bar. P bar ante dipole moment q multiplied by 2 times of d bar cross e bar kuda cheppochu. Okay, so 2q multiplied by d bar cross e bar is the dipole torque. Okay, leda maamulugane value kavalante you can simply say Pe sin theta. What is theta, sir? Theta is mentioned above. చూడండి ఇదే మీ theta. Second formula అంటే energy of the dipole అందరు. Okay, energy, potential energy of the dipole. కాబట్టి ఈ energy కోసమే you have a little formulas. Okay, చూడండి, so if this is your electric field లేదా external electric field, if this is your external electric field, అంటే in this external electric field if you are putting the dipole, ఇదిగో ఈ minus q charge అనుకోండి, if this charge is plus q, distance 2d అనుకోండి, ఈ point of time లో angle theta ఉన్నప్పుడు the potential energy stored inside the dipole is minus p bar dot e bar లేదా p into e into cos theta కూడా చెప్పొచ్చు. Done? Not done. That's it. So alage there is one more extension of this topic, work done by the external agent to rotate the dipole. Okay, yes, extension ante ide. So sir, if this is the energy of the dipole ante you will say work done by external agent, okay, to rotate the dipole from angle theta 1 to angle theta 2. ఇదే కదా. సో వర్క్ డన్ ఇస్ నథింగ్ బట్ చేంజ్ ఇన్ ద పొటెన్షియల్ ఎనర్జీ. ఎందుకంటే సార్ ఇట్స్ కన్సర్వేటివ్ ఫీల్డ్ కదా. ఎస్, సో u2 minus u1 అదే. సో సార్ Pe into cos of theta 2 minus cos of theta 1. That's it. So this is the work done by the external agent. Jagrataga andaru. Be careful because this question has already been asked in your NEET 2025 examination. Direct formula based question adi kuda. Okay? Yes. Lastly, you have force on the electric dipole. Okay? Yes. Last topic is force on the electric dipole. Force on electric dipole. Kani ikkada kuda condition untundira. So the force will always be experienced in the presence of a variable electric field. Aithe nee daggara constant electric field unnappudu you don't have any force kada. Yes. So if this is your electric field andaru kani it should be variable. Okay? Electric field as a function of distance leda as a function of position anukondi. That's it. So ee electric field lo if you have the dipole minus q charge anukondi, here it is plus q charge, angle theta unnappudu force on the electric dipole is equals to cheppandi end side adi p bar cross de bar divided by dx. Other. Okay, this is the force on the electric dipole. Completed. Now we have something known as the last concept ante Gauss law. Okay, and yes, Gauss law in electrostatics. Kani discuss chesi mundu I want to talk about electric flux. Okay, what is electric flux, sir? Electric flux ante maamulgane represented by the letter phi. So this electric flux is nothing but the dot product of the electric field and the area vector. Okay, chudandi. So flux is nothing but the dot product of E bar dot A bar. But sir, aim area, sir, simple terms lo cheppalante you can also call it to be E into A into cos of theta. This is your total flux andaru. Aithe if this is your ring, okay, circular ring imagine cheyandi, radius r aithe area A, alage there is this electric field that is passing through the ring. Ade kada. Yes. Student, electric field A and E anukondi, area is A. Okay, area vector is A. Vachindi kada, electric field A, area vector A. E case lo your flux is nothing but E into A. Endukante theta is 0. Area vector untundi and sir, is this not cos 0 in the torque? No. Yeah. Kabatti cos 0. Torque is not cos ra. Okay, torque formula ante P bar cross E bar. Okay, good point. Okay, not cos. Okay, not cos theta. Torque lo it is always sin theta. Okay, in flux it is cos theta. Clear or not clear? Yes. So if you need to find the flux, you can take the different situations. If the area vector has been tilted, kani electric field straight unnappudu, you basically take the area vector. So ela teesukovalsa area vector will always be perpendicular. So this is area vector and this is your electric field vector, angle theta anukondi, that's it. So sir, e point of time your flux is nothing but E into A into cos theta. Vachindi kada? Yes. So last topic ante Gauss law. What does it say? Your Gauss law basically talks about the total flux. Okay, Gauss law. Andaru cheppandi, what does the Gauss law state? 1 to 4 3 hours completed, just a single chapter. So it basically talks about flux. Flux is nothing but closed integral of E bar dot dA bar and its value should be equals to internal charge divided by epsilon naught. Chudandi, ఇది చాలా important. Okay, అయితే for symmetric object, not symmetric objects, for closed objects kosame total flux passing through that closed object will be internal charge divided by the epsilon naught value. Okay, yes. Chudandi, so this is the total flux. So for example kavalante ee example anukondi. Okay, this is your Gaussian surface kada. Yes, ee Gaussian surface lo you have a charge. Okay, ee charge anukondi. So let us say you have a charge plus q enclosed into it. Ide kada? Yes, and the value of this charge is plus q andaru and this radius of this surface is r kada. Yes. So sir, ee charge nunchi there will be electric field lines that are emitted in almost all the direction. E bar area is A. Substitute cheyandi andaru. So integral of E bar dot dA bar is nothing but q divided by epsilon naught. Ide kada. So integral of electric field constant ra bayatiki teesukondi. So closed integral of dA is equals to q divided by epsilon naught. So electric field multiplied by chinna area add chesinappudu you get the total surface area of the sphere and the total surface area of the sphere is 4 pi r square. Ide kada. So electric field multiplied by 4 pi r square is equals to q divided by epsilon naught and the electric field is coming out as q divided by 4 pi r square epsilon naught. That's it. So sir, electric field at a given point due to a point charge is given as the formula electric field E is equals to q divided by 4 pi epsilon naught r square. Ide kada. So sir, Q and Q into 1 and this 1 upon 4 pi epsilon naught and K kada. So electric field is equals to KQ divided by R square. Student, again at the same results we arrived. Okay, so this was all about electrostatics and the electrostatics. Now the next chapter we basically have to start is your capacitors. Okay, next chapter it is going to be your capacitors. Okay, so in PDF law I am also attaching the PYQs. Okay, sorry, PYQs through go through change. Okay, yes. Next chapter under electrostatic potential and capacitances. Okay, yes. Electrostatic potential and capacitors. Kani, just give me 5 minutes. Huh? Let me just take the update. Students, please like the video. Okka nimisham agandi. Just I will be back in a minute, okay? Just 5 minutes, okay? I will be back in 5 minutes. I will be back in 5 minutes. Yes. I'm back. Let us continue, okay? So break will be given around at 6 p.m. 6 p.m. Yes. So it's 4 p.m. right, guys? All of you, I'm expecting likes from you are. No break till 6 p.m. okay? अरे ना कोसम इदी चाला कष्टम कदा. At least for you just have to sit, but for me I have to stand straight and I have to teach now. So it's more difficult for me. So if I'm not taking break, and there's no question of you asking for the break also, okay? Yes. Capacitors. Next chapter is going to be the capacitors. Okay. We covered Gauss law kada. Ippude Gauss law cover indi kada. Sir, give 4:30 break. 4:30 not possible. Look at 4:30 we will be in the mid of the chapter, okay? So this chapter complete chesi, we will take week quiz and week quiz tarvata. Let us take full 1 hour break for dinner, okay? Yes. I am anadi bhai. Arey. What happened? Need a break. Yes. Full boring, guys. Abba. But em kavalra niku? Do you want me to dance or what? Dance cheyali nenu. He removed it, why writing again? Because I wrote a wrong name, capacitances, but it is capacitor. Okay. And then, let us continue with the Gauss law. Okay. Gauss law. What does it say? Gauss law, it basically tells you that the total closed integral of electric field and dA vector. Okay. Total flux is nothing but Q inside by epsilon. So let us start with the application of Gauss law, such that you also have the grip, okay? Gauss law application. So this is the Gauss law kada. Statement ends here. So imagine if you have a full infinite metallic sheet kada. Yes. So if you have a full infinite metal sheet, yes. Face wash kadra. Just I have poured the water on my face. Okay. Freshness kosam. Freshness ante chaala important. Sir, so this is the sheet under. Imagine this sheet paina you are giving a total positive charge of Q. Okay, Q not Q. Epsilon ante charge density. Epsilon ante enti sir. It is known as the areal charge density of the sheet. Okay, epsilon ante enti sir. It is areal charge density. Yes. If you want to find the electric field due to this charge density, you have to imagine the cylinders. Okay, cylinders ni imagine cheyandi. Wait, I take a glass of water. Abba. Yes. Sir, na maata break kavali we will take a break. Week quiz is there, okay? That is the important section. So, okasari me week quiz complete endante, we will take a break. Naaku kuda break kavalra. I'm also tired kada. Hey, student, mari em cheyali sir? So, if you see that electric sheet, charged sheet, okay, infinite sheet ante piece of paper na daggara ledu, adi kuda ledra. Okay. But you imagine you have a sheet of paper, okay? So, ee paper ante right side lo kuda, left side lo kuda, it is emitting the field lines. And then, this field lines ni cover cheyadaniki we need 2 cylinders kada. 2 cylinders. Right side lo oka cylinder kavali, alage left side lo kuda oka cylinder kavali. Andaru chudandi. Yes. So, this is your first cylinder and this is your second cylinder. Aithe all the field lines that are coming out of this sheet chudandi. Yes, these are all the field lines that are coming out of the sheet. Okay, they will be blocked. Okay, sure. అయిపోయింది కదా, all the field lines are blocked. కాబట్టి total charge చెప్పండి ఒకసారి. సో if the area of this sheet is A, అందరూ చూడండి ఏరియా A ఉన్నప్పుడు ఇది కూడా ఈ షీట్ లో కూడా సేమ్ ఏరియా A ఉంటుంది కదా. yes, so sir total charge is nothing but sigma into A. గుడ్ పెట్టుకోండి. done. ఇప్పుడు ఏం చేయాలి సార్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటూ ఏరియా, టోటల్ ఫ్లక్స్ కదా. yes, ఇది ఫ్లక్స్ నెంబర్ 1, ఫ్లక్స్ నెంబర్ 2. సో సార్ రైట్ సైడ్ లో ఫ్లక్స్ ఎంత సార్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటూ ఏరియా EA. అలాగే లెఫ్ట్ సైడ్ లో కూడా ఫ్లక్స్ ఎంత సార్, E ఇంటూ ఏరియా. మరి టోటల్ ఫ్లక్స్ కావాలంటే టోటల్ ఫ్లక్స్ ఈజ్ నథింగ్ బట్ 2 times ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్ E ఇంటూ ఏరియా వచ్చింది. దట్ షుడ్ బి ఈక్వల్స్ టు చార్జ్ డివైడెడ్ బై ఎప్సిలాన్ నాట్ కదా, Q ఇన్సైడ్ డివైడెడ్ బై ఎప్సిలాన్ నాట్. అదే సో సార్ 2EA is equals to sigma by area, sigma into area, sigma into area divided by epsilon naught. area gone. మరి ఎలక్ట్రిక్ ఫీల్డ్ కావాలంటే సిగ్మా డివైడెడ్ బై 2 epsilon naught వచ్చింది. సో ఇఫ్ యూ హ్యావ్ ఎన్ ఇన్ఫైనైట్ షీట్, ఓకే, అంటే తెలుసా మీకు ఏంట్రా ఇది, ఇఫ్ యూ హ్యావ్ ఎన్ ఇన్ఫైనైట్ షీట్, the electric field due to that infinite sheet is sigma by 2 epsilon naught. Okay, mari golden statement ide. What is the statement, sir? Electric field due to infinite charge sheet kada. Yes, infinite sheet having charge density sigma, okay, having sigma as the charge density. అయిపోయింది కదా, having charge density sigma is given as E is equals to sigma by 2 epsilon naught. గుర్తుపెట్టుకోండి, the most important foundation for this chapter. ఓకే, ఈ ఫార్ములా అంటే ఈ చాప్టర్ కి ఫౌండేషన్ అందరూ. yes, like the video guys. చూడండి, so now let us visualize you have two different sheets కదా. yes, so this is the first sheet, అలాగే this is the second sheet. done. Should I directly start it? I should not directly start it. Okay. Yes. So first of all, let us talk about capacitor. Okay. Capacitance. Under capacitance. What is capacitance, sir? In simple terms, the capacitance is nothing but the capacity. Okay. Capacitance and entra capacity to store the charge. That's it. To store the charge. And Mamul Gani, we talk about the charge storing only for the conductors. Okay. Yes. Okay, sir. Sir, sunflowers and get done. ఇప్పుడు చూడండి ఇదిగో. So capacity to store the charge ఇదే కదా. yes, is known as the capacitance of the system. గుర్తు పెట్టుకోండి అందరూ. సో ఇప్పటి నుంచి the capacitance formula is Q upon V. Q అంటే the amount of charge stored. Okay, formula లో terminologies కూడా చాలా ఇంపార్టెంట్ అందరూ. Q అంటే ఏంట్రా, the Q value is nothing but the amount of charge stored. Okay, amount of charge stored. అలాగే V value, what is V value, sir? V value is nothing but the potential of the surface. Okay, potential of surface with respect to infinity. Potential of surface with respect to infinity. Andaru clear ah leda? Yes, this is the formula. So if you want to find the capacitance of a general system, మామూలుగానే random system తీసుకోండి. What can be the random system, sir? Random system could be your sphere కదా. yes, so let us try to calculate the capacitance of the sphere. Okay. yes, so ఒక sphere కోసమే for a sphere చెప్పండి, అయితే ఒక sphere imagine కూడా చేయాలి. so if this is your sphere and we are going to revise it in a very quick manner. okay, yes, ఈ sphere పైన plus q charge is there, అలాగే radius of the sphere is r, capital R అనుకోండి. so this is the radius, this is the charge కదా. yes, what do you need? Capacitance కావాలి sir. so the capacitance of this sphere is given as total charge on the sphere divided by the potential on the surface of this sphere. total charge ఎన్ని ఉన్నాయి? Q. what is the potential on the surface, sir? KQ by R ఇదే కదా. yes, what is happening? Q gone కాబట్టి capacitance is equals to R by K. R by K. K and enter 1 upon 4 pi epsilon naught. And R divided by 1 divided by 4 pi epsilon naught. And the capacitance is simply equals to 4 pi epsilon naught into R. Gurtpetkondi, me normal sphere kosame, the capacitance is given as 4 pi epsilon naught multiplied by R. So this is the capacitance of the sphere. Under Gurtpetkondi. Now, children, left side ni choose, you have the formula for capacitances. So if you see the left side part, C is equals to Q by V. The students will get confused. Capacitance depend on the charge, leda on the potential. Okay, and the capacitance under chudandi, this is statement and it has been asked in the PYQ. Okay, capacitance of a system. Okay, the capacitance of the system or configuration is independent. Okay, the capacitance is independent. Independent of what? Independent of charge or potential. Okay, charge or potential. And the answer, the capacitance only depends on the configuration. That's it. Point number 1 to be noted. Alagi here point number 2. And the answer, the capacitance of the system only depends on the configuration. Okay, on the configuration. That's it. Finished. This is the condition. Aithe configuration ante geometry ra maamulgane. Your configuration in the sense is the geometry of the system. Okay, configuration ante geometry. Chudani here also we got the value of capacitance is directly proportional to R kada. So for a sphere the capacitance is directly proportional to R. And if you take a larger sphere, capacitance kuda ekkuva untundi. That means you can store more amount of charge on the larger sphere. Ide kada? Yes. Next type of sphere that we have is the parallel plate capacitor. We need to finish this chapter by 5:30 anyhow. Okay, the next type of capacitor that we have is the parallel plate capacitor. How to calculate the capacitance, sir? Chudandi. Point number 1 to be noted. And the parallel plate capacitor kosame I am dividing it in 3 categories. Okay, so first of all we will find the value of potential, then we will find the value of charge kada. Yes, andaru ee video ni like cheyandi. I am expecting likes ra. Okay, chudandi, parallel plate capacitors unte ee parallel plate capacitor kosame you have 2 different plates. Okay, first sheet alage this is the second sheet, infinite second sheet. Done andaru? Yes, so these are the 2 sheets. First sheet paina మీ దగ్గర పాజిటివ్ చార్జ్ ఉంటుంది. అలాగే on the second sheet you have the negative charge. ఇదే కదా? Yes. అందరూ ఇప్పుడు జాగ్రత్తగా చూడండి. సో పాజిటివ్ చార్జ్ ఉన్నప్పుడు చార్జ్ డెన్సిటీ ప్లస్ సిగ్మా, నెగటివ్ చార్జ్ కోసమే చార్జ్ డెన్సిటీ is minus sigma. ఇదే కదా? Now I want to consider the general point in between the 2 sheets. Okay, between the capacitor plates కావాలి కదా. కాబట్టి ఒక జనరల్ పాయింట్ ఇమాజిన్ చేయండి. సో లెట్ us consider the general point between the 2 sheets అందరూ. ఓకే, ఈ జనరల్ పాయింట్ పైన you talk about the electric field. It is sigma by 2 epsilon naught due to positive charge. Away kada, repulsive. Positive sheet ni choose, the field line is away. Alage negative sheet wala, the field line is towards itself. Alage sigma divided by 2 epsilon naught. Kabatti total electric field inside the sheet kavalante, between the sheets. Okay, between the sheets kavalante E due to positive sheet plus electric field due to negative sheet. Positive sheet wala field is sigma divided by 2 epsilon naught. Right side lo I cap plus ఇది కూడా సిగ్మా డివైడెడ్ బై 2 ఎప్సిలాన్ నాట్ I cap ఓన్లీ. ఎందుకంటే ఇట్ ఇస్ అట్రాక్టివ్ ఫోర్స్ రా, అట్రాక్టివ్ రిపల్సివ్ ఇదే కదా. సో టోటల్ ఫీల్డ్ ఇస్ సిగ్మా డివైడెడ్ బై ఎప్సిలాన్ నాట్ ఇన్ ద I cap డైరెక్షన్. వచ్చింది అందరికి? సో దిస్ ఈస్ ద ఫీల్డ్ వాల్యూ. ఇప్పుడు నాకు పొటెన్షియల్ కావాలరా. వాట్ ఈస్ ద రిలేషన్షిప్ బిట్వీన్ పొటెన్షియల్ అండ్ ఫీల్డ్ సార్? పొటెన్షియల్ ఈస్ ఇంటెగ్రల్ E బార్ డాట్ dl బార్. ఇదే కదా? డన్. సో సార్ ఇంటెగ్రల్ ఆఫ్ చెప్పండి, నాట్ క్లోజ్ ఇంటెగ్రల్ బార్. Yes, integral of E bar dot dl bar andaru. So potential of E bar and enti sir? E bar is sigma divided by epsilon naught integral multiplied by dl bar తీసుకోండి. So sigma constant, epsilon naught constant బయటికి తీసుకోండి. Integral of dl bar 0 నుంచి d వరకు, where d is the separation of the plates కదా. Yes. Substitute చేయండి ఇక్కడ నుంచి you get the value of potential as sigma d divided by epsilon naught. Point number 2 to be noted under. It is also a formula. Okay, it could ask as a formula. ఇది separate independent formula. Okay, yes. చెప్పండి డౌట్స్ ఉంటే చెప్పండి. ఓకే, ఫ్రీగా అడగండి బాబు. సో ఇఫ్ యూ గాట్ ద వాల్యూ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్, యూ గాట్ ద వాల్యూ ఆఫ్ పొటెన్షియల్ డిఫరెన్స్. ఇప్పుడు చెప్పండి సిగ్మా కదా. లెట్ us talk something about సిగ్మా. సిగ్మా అంటే ఏంటి సార్? చార్జ్ అపాన్ ఏరియా, ఇదే కదా. అయితే యువర్ చార్జ్ వాల్యూ Q is nothing but సిగ్మా ఇంటూ ఏరియా. ఇలా కూడా చెప్పొచ్చు. ఫార్ములా నెంబర్ 1, ఫార్ములా నెంబర్ 2 ఇదే కదా. ఇప్పుడు యూటిలైజ్ చేయండి ఫార్ములా నెంబర్ 1, ఇదే మీ ఫార్ములా నెంబర్ 2, దిస్ ఈజ్ యువర్ ఫార్ములా నెంబర్ 3. ఇదే కదా అందరూ. మరి ఏం కావాలి? కెపాసిటెన్స్ కావాలి. కెపాసిటెన్స్ కోసమే చార్జ్ అపాన్ పొటెన్షియల్. సో కెపాసిటెన్స్ చార్జ్ ఏంటి సార్? Q వాల్యూ ఇస్ సిగ్మా ఇంటూ ఏరియా. పొటెన్షియల్ కావాలంటే చూడండి సిగ్మా d బై ఎప్సిలాన్ నాట్ కదా, సబ్స్టిట్యూట్ చేయండి. సో పొటెన్షియల్ ఇస్ సిగ్మా d డివైడెడ్ బై ఎప్సిలాన్ నాట్. అయితే సిగ్మా గాన్, ద కెపాసిటెన్స్ ఆఫ్ ద సిస్టమ్ is A into epsilon naught divided by D. So if you have a parallel plate capacitor and the area A unte, separation between the plates D unnappudu, the capacitance of the system is given as A into epsilon naught divided by D. Done? Hi guys, hi. Hello everybody, hello. Yes, like the video guys? Yes. Done? The capacitance is A epsilon naught by D. Now you can take different cases kada. So if your first case is having with round plates and heats. Yes. So first plate, alage this is your second plate. Delete it. So it's all up to you kada. Now you can talk about the conditions, prospective conditions. Separation between the plates D unnappudu radius R, okay, radius R, that's it. మరి ఏం కావాలి మీకు? కెపాసిటెన్స్ కావాలి కదా. సో కెపాసిటెన్స్ is equals to A epsilon naught divided by D. ఏరియా ఏంటి సార్? pi R square multiplied by epsilon naught divided by D. ఇదే కదా the capacitance of this system. అర్థం ఎందుకు? Yes. So this is the capacitance. Done, not done. Let me just tell you, sir, any formula yes, you're right. Okay. Yes. Done, not done. Under. Right. Okay. So this is the capacitor. Now let us talk about the working of this capacitor. How the capacitor works. Chudandi. So in working kosame, I basically want to write this parallel plate capacitor. This is the parallel plate capacitor. Visible, not visible. Yes, student. So now what we are doing is we are basically connecting these two plates kada. Sir, quiz meeru start cheyaledu. Yeah. Not started, okay. We will start the quiz by 5:30, okay? By 5:30. Yes, we will start it by 5:30 because the quiz has the question from capacitors also. The chapter completed, not completed, right? Chudandi, so if you have these parallel plates, ide kada, ee parallel plates, what are you doing now? You are basically connecting these parallel plates with a battery. Idigo connect cheyandi oka battery toni. Ide kada, mari em aitadi sir, slowly ee neutral plates paina oka charge collect aitadi. Ide kada. So on this plate you will have a positive charge, on this plate you will have a negative charge. Ide kada. That's it. So on the left side you will have a positive charge, on the right side you will have a negative charge. Chudandi, so charge density kavalante plus sigma, alage ee plate paina minus sigma vastadi. Ardhamayindi andaru ippudu. Now understand, all of you, what we are going to do now, this charge density remains the same ra. Mari em cheyali? Now you basically remove this battery ra. Ee battery ni remove chesi you basically add another device ante bulb connect cheyandi. So if you are connecting this bulb, the extra accumulated charge, it will again flow back and becomes original neutral condition. Kani, while that charge was flowing, the bulb will glow for a minute. Yes. So this is the use of the capacitor. What is the use? Capacitor is used when we need huge amount of energy. When we need huge amount of energy for a very short period of time. Okay. Yes. Okay. So this is how your capacitor works. Chudandi, andar. Now let us talk about the combination of capacitors. Andar. Let us talk something about the combination of capacitors. రెండు రకాలు ఉన్నాయి. Number 1 series combination, number 2 parallel combination. Formulas చెప్పండి అందరూ. What is the formula for series combination? What is the formula for parallel combination? చెప్పండి. మీ series combination కోసమే the capacitors are connected in series. So this is the symbol of capacitor, okay? Yes. First capacitor, second capacitor, C1 anukondi, C2 anukondi. Here, understand, okay? Potential difference V1 across this capacitor, E capacitor ki across potential difference V2. Ide kada. Mari sir, we write V net is equals to V1 plus V2. Charges maatrame same undali, okay? Plus Q minus Q unte plus Q minus Q ikkada kuda undali. So sir, Q divided by C net is equals to Q divided by C1 plus Q divided by C2. Chindi kada Q gone. కాబట్టి 1 upon C net is equals to 1 upon C1 plus 1 upon C2 కూడా చెప్పొచ్చు. Okay, 1 upon C2. Here you have parallel combination kada. Parallel combination of capacitors lo potential across each capacitor should be same andaru. Yes, so if you are having the potential across each capacitor to be same ra, here also V, here also V. కానీ charges చూడండి, ఈ capacitor పైన Q1 charge, ఈ capacitor పైన Q2 charge. So you will write sir Q net is equals to Q1 plus Q2. ఇదే కదా, because the charge has been separated, distributed in the two branches la, కానీ total charge Q ఉంటుంది. So Q net అంటే C net multiplied by V should be equals to C1V plus C2V. ఎందుకంటే potential same ఉంటుంది. V cancel చేసుకోండి. Net capacitance is equals to C1 plus C2. ఇదిగో it's a reverse of your resistances కదా. So resistance series లో ఉన్నప్పుడు R net is R1 plus R2. అలాగే resistance parallel లో ఉన్నప్పుడు okay, PYQs. Let us do some PYQs. Yes, you know the formulas, but you want me to do the PYQs, ade kada? Yes. So let us start with the PYQs for capacitors. Any odds there? So let me just send it back to the working space. Do we see capacitors? Capacitors, right. Sir, so here are your capacitors. Yes. I direct capacitors to them. Okay. Yeah, so this is all talking about potential. Potential already completed kada. Yes, equal to potential surface, potential energy of the system and charge is also completed. Capacitors and capacitors. Student, so this is the question. And the question number 31 తీసుకోండి. Okay, question number 31. We can discuss every question ra. Actually I have discussed almost each and every question from this, okay? Student, two metallic spheres of radii 1 and 3 cm, charges of -1 and 5. If they are connected by conducting wire, final charge of the biggest sphere. Idi kuda, it's not from the capacitor, okay? It's there from the electrostatics. Potential same undali, okay? Yes. Distance separation, force of attraction kavali kada. So let us discuss that also later on, okay? Yes, after disconnecting charge in the battery between the plates, let us move to the next topic. Okay. Not there. Okay. Teeskondi. Question number 42. Andal. Let us take question number 42. Charges. Idi kuda. I did not cover this also. Kada? Yes. Parallel plate, capacitor, condenser with oil between the plates. Parallel plate area separation is filled with fold. Dielectrics la idi. E volt then connected in parallel unchanged capacitor. Yes. Question number 44 తీసుకోండి. If you want the question number 44, you can take it as the question. And the question number 44. Yes. What is the question? See, చెప్పండి. A capacitor of capacitance C1 charged up to V volt connected in a parallel to uncharged capacitance C2. Final potential difference across each capacitor. So this is your first capacitor value C1 anukondi. Okay, this capacitance is a C1. So this capacitance has been charged by a potential difference of V. Okay, so this is the battery. So this is the battery potential V on. Yes, V. Now there will be the charge on the capacitor. Okay, okay, charge వస్తుంది. What is the charge on the capacitor, sir? ఇదిగో. So C1V here plus ra ekkada minus C1V charge వచ్చింది కదా. ఇప్పుడు what we are doing is we are removing this battery. ఈ battery ని remove చేసి we are attaching one more capacitors of capacitor C2. Okay, C2 attach చేసింది. ఇప్పుడు we have to calculate the potential difference across each capacitor kada. So what is happening, sir? When you are connecting that capacitor ante koncham charge flow ayindi ide kada. So some charge flows from capacitor C1 to C2. Idi kosam initially the charge C1V was here kani koncham charge C1V minus Q ante Q charge flow ayindi. So this is the charge Q flown to the capacitor C2 ante plus Q charge minus Q unnappudu it will be a plus Q charge. Ardhamaindi andariki? Yes. Now understand the potential across each capacitor should be same. This is a parallel connection kada idi. So potential same unnappudu you will simply say, sir, C1V ide kada C1V minus Q charge on the plate of this capacitor divided by the capacitance C1 should be equals to Q divided by C2. Ochindi andariki? That's it. Ippudu simplify cheyali. Q value calculate chesinappudu Q divided by C2 chesi I will get the potential difference. Ide kada multiply cheyandi, simplify cheyandi. Idigo. So C1 C2V multiply these two ra. So C2V into C1 ide kada C2 multiplied by C1V minus Q should be equals to C1 multiplied by Q. Ochindi andariki? That's it. So C1 C2V minus C2Q is equals to C1Q minus C1 C2Q becomes plus C2Q kada. So C1 C2V is equals to C1 plus C2 into Q. Vachinda leda? So Q value is equals to C1 C2V divided by C1 plus C2. That's it. Mari em kavali meeku? Potential kavali kada. So potential is the same across the parallel plate. So potential is Q by C again. So sir, potential difference is nothing but Q divided by C2. Q value ochindi kada. So C1 C2V divided by C1 plus C2 divided by C2. Idigo C2 gone. So potential difference across each capacitor ante C1V divided by C1 plus C2. Ochinda leda andaru? Yes. There is the option there or not there? Option B is there. Correct. Very good. Andaru very good. C1V divided by C1 plus C2 is the option. Very good. Okay. Let us discuss one more question now. So these questions are actually out of syllabus also. Konni syllabus I did not teach. Okay. Chudandi. So for 45 question number 45 తీసుకోండి. Okay. 45th question. What is the equivalent effective capacitance between X and Y? So ide మీ point X and this is your point Y. Effective capacitance కావాలి అందరూ చెప్పండి. Calculate చేసి చెప్పాలి. Okay. These are the options. 12, 18, 24, 6. Should I write here? Can I write here also? Yes. Let us solve here itself. Idigo chudandi andaru. So there are how many points ra? Point A, point C, point B, point D kada? Yes. Is there any possibility of forming Wheatstone bridge? Chuddam. Okay. Yes sir. 4 points are there. First is point A. Alage there is something known as point C. Okay. And then there is something known as point B. And then there is something known as point D. CD C is connected to D. Okay. Then there is something known as point B and there is something known as point D. Ide kada andaru? Yes. Ippudu see the first capacitor C1 kada 6 microfarad. It is connected between the 2 points, point A and then point C. A C ki madhyalo 6 microfarad is there. So this is the first capacitor. Alage second capacitor ni chudandi. This is the second capacitor from A kada. Yes, enta sir idi kuda 6 kada, 6 between A and B. So A and B also it has somewhere around 6 microfarad. 6 ochindi kada. Ippudu understand 20 and 6 kada. Yes, C and B kada, C and B andaru C and B. This is the capacitor. Idi enta sir? This is 20 microfarad. Okay, this is 20 microfarad. Mari okkasari CD C ekkada ra? C here, D here. So CD ki madhyalo this is the capacitor having the value of 6 microfarad. Ochindha leda andariki? Yes. Alage last option ante B and D. Ekkada B and here is D. So B and D ki madhyalo mari okkasari 6 microfarad is there. Chudandi 6 microfarad. What do you want? You need the potential difference between A and D, not potential, net capacitance. Capacitance between A and D kada. Yes. So this is your point A, this is your point D. Chudandi, it's a balanced Wheatstone bridge. Balanced Wheatstone bridge. Ide kada. Mari em cheyali sir? You remove the central capacitor. That's it. So central capacitor ni remove cheyali. That's the only way you can get out of this situation. Finished. Central capacitor gone. Ide kada central capacitor gone. That's it. But what is remaining? You have series and parallel of capacitors. Student, these two series lo, not these two. These two are in series. These two are in series and then they are in parallel. Yes. So 6 series lo unnappudu the net capacitance becomes 3 microfarad. Okay. Yes. 3 microfarad andaru 3 microfarad. Alage idi kuda 6 series lo unnappudu they also become 3 microfarad. Okay. 3 microfarad. Ippudu 3 parallel lo unnappudu your answer becomes a 6. Okay. That's it. Done? Not done. Next question. Babu. Next question. Kavalante teeskondi. Okay, now don't say PYQs. Let us talk about the dielectric now. Okay, dielectric. Dielectric. Next concept is dielectric. The concept of dielectric. Yes, dielectric in case of capacitors. What is the time? 4:25. Is it possible to finish it by 5:30? Yes. Dielectric kavali kada. What is dielectric kada? So basically you add some material into the capacitance. That's it. So dielectric ante oka dielectric constant kuda untundi. Ajay sir has this tragedy has happened with him. Okay. So Ajay sir is currently not available for the classes, but definitely he will come and soon take on the classes. And by that time, if possible, we will continue our syllabus. Finished. Other student. So let us see the difference between a normal capacitor and the capacitor with the dielectric. Ide me normal capacitor kada capacitance C anukondi. That's it. Ide normal capacitor lo you have introduced a dielectric with a dielectric constant C. K. Other ipudu quantities ni maatrame chudandi. Number 1 ra electric field. Okay, electric field sir. Electric field E0. Alage electric potential cheppandi sir. Electric potential due to the potential kada. Yes. Electric potential between the plates ra enta idi V0 anukondi. Alage capacitance of the system. What is the capacitance of the system sir? Capacitance of the system is nothing but C0. That's it. 3 things ochindi. Energy also. Okay, but we did not discuss about the energy kada. Energy. Here also, after inserting the dielectric, and the student, okay, electric field E0, initial electric field E0, Kani final electric field enta sir. The final electric field E, adi value ఏంటంటే E0 by K. Electric field decreases, okay. E dielectric వల్ల electric field reduces. అలాగే electric potential, this also reduces. అందరూ జాగ్రత్తగా వినండి, okay. The electric potential V, and that is V0 divided by K. Once again the potential decreases. మరి ఏం కావాలి? Capacitance కావాలి కదా? Yes. So if you want to talk about the capacitance, the capacitance C, that is nothing but C0 into K. అంటే the capacitance value increases if you add the dielectric. అలాగే energy. Ajay sir's health is okay, but Ajay sir's grandmother has passed away. Okay, so he will not be able to take lectures for some time, but he will come back again. Okay, alage if you want to talk about energy of the capacitor, potential energy is nothing but K times of initial energy U0, and that's it. Capacitance formula ఏంటి sir? A epsilon naught by D. alage potential formula ఏంటి sir? Potential formula కావాలి ఎందుకు sir? Sigma epsilon naught divided by D కదా. అరే sigma D by epsilon naught. ఇదే కదా? Yes. Electric field కావాలంటే you can simply say sigma by epsilon. That's it. Okay, energy of the capacitor is a half CV square లేదా Q square divided by 2C. Here the energy is increasing K times. Okay, so these are all the formulas. Student, that's it. So if you add the dielectric, the capacitance of the system increases, field between the plates decreases, potential difference between the plates kuda decreases. Okay, done? Not done. Yes, andaru cheppandi. So next discussion andaru. So let us talk about the combination of dielectrics. Okay, yes. ఈ combination tarvata mari okasari we will talk about your PYQs. combination of dielectrics kada. Yes, combination of dielectrics. Yes, and so if this is your normal capacitor, okay, ee capacitor lo you are adding different dielectrics. Ide first dielectric, this one is the second dielectric, alage this one is the third dielectric. Andaru chudandi dielectric constant K1, K2, K3 and so on so forth. Thickness cheppalante thickness T1 anukondi, here the thickness is T2, here the thickness is T3. Done? Not done. If you want to talk about the net capacitors and the formulas, these are all the formulas. So formulas is what I am telling to you right now. Chudandi. So if you want the net formula of the capacitors, aithe cheppandi, these are three independent capacitors, sir. So due to the dielectric, okay, dielectric valla the capacitance due to dielectric. What is the value of capacitance due to dielectric? Cheppandi. So sir, dielectric constant K, ide kada area of the plate A and distance between the plates D anukondi. So sir, capacitance due to dielectric, net capacitance is nothing but K A epsilon naught divided by D. Ide kada K times the original capacitance. Ekkada chudandi. So first capacitance ante K1 A epsilon naught divided by D ante thickness T1. Alage the second capacitor here will become K2, K1 kada K2 A epsilon naught divided by thickness T2. Ardha idendariki. Similarly, third capacitance is, sir, the third capacitance is K3A epsilon naught divided by T3. Finished. Now, these three capacitances are in series. So, first capacitor, second capacitor, third capacitor. So, 1 upon C net value is equals to T1 divided by K1 A epsilon naught plus T2 divided by K2 A epsilon naught plus T3 divided by K3 A epsilon naught. But if you net capacitance value kavali kada, so you can definitely write about the net capacitance value. Direct ga rasinappudu, you can directly say that the net capacitor now C net value is nothing but A into epsilon naught whole divided by cheppandi em ravali K1 by T1 plus K2 by T2. Ide kada inverted cheyandi and you are left with A epsilon naught into yes, so sir, C net is equals to A into epsilon naught into K by T, T1 by K1, yes, so T1 by K1 plus T2 by K2 plus T3 by K3 and so on and so forth. So modu unnappudu T3 by K3, that's it, sufficient. So this is the net capacitance in series. Alage if the same dielectrics are in parallel, so idigo, this is your capacitor. Deedlo you have multiple dielectrics kada. Yes, first dielectric, second dielectric and then you have third dielectric. Student, area A1 anukondi, area A2, thickness maatrame same untundi, okay. Dielectric constant K2, dielectric constant K1. Mari em ravali sir, these are two independent capacitors. First one ide me, second one vachindi kada. Yes, formula cheppandi ra. First dielectric K1 A by 2 epsilon naught divided by thickness T. Alage K2 A by 2 epsilon naught divided by thickness T. Thickness same ra. But sir, C net is equals to C1 plus C2. Endukante parallel kada. So you will write K1 A by epsilon naught 2D plus K2 A epsilon naught divided by 2T again. That's it. So sir, C net is equals to K1 plus K2 multiplied by A epsilon naught divided by 2 times of thickness T. That's it. Okay. So this is the net capacitance of the system. Andaru ippudu kavalante we can also discuss some PYQs. Okay. Students, so this is the question, okay? Ide me question. adera. This is a question from NEET 2026. Okay, dielectric netted. Yes. So what do you want, sir? Ikkada ee question lo meeku net dielectric constant, not net dielectric, net capacitance kavali. Okay, teeskondi. It is K1, K2, K3, K4. Okay, did you understand the question? Yes, student. And here thickness between the plates, the distance between the plates is D, area by 3, area by 3, area by 3. Ade kada? Yes. So let us draw and let us solve this question. Okay, NEET 2016 lo ochina question idi. So this is the first dielectric, area A by 3, alage area A by 3, area A by 3. That's it. So first dielectric constant K1, K2, K3, K4 andaru. Thickness between the plates is D, alage ee capacitor kosame we don't understand kada. Yes, D by 2. Sorry sir. Idigo, this thickness is also equals to D by 2. That's it. So this is the first dielectric, the second dielectric, third dielectric, fourth dielectric. Which is equal. Now you have to calculate the net capacitors. But sir, these dielectrics ni independent capacitors laga treat cheyandi. Okay, you have to treat these dielectrics as independent capacitors. Student, 1, 2, 3 ra, 1, 2, 3 they are in series. Ide kada? Yes. Alage these two are in parallel. Andaru. Cheppandi. So this is your wire ra, wire kada? Yes. So, if it is confusing ante, you can just rotate this figure. Okay, this figure ni rotate cheyandi. It becomes completely normal for you. Very good. Student. Yes, that's it. So now you have basically 3 parallel, 1, 2, 3 parallel resistors, capacitors and 1 series. Ide. Aide idigo ee dielectric kada. In this dielectric you have a capacitors. Alage you have 3 more capacitances in a parallel. First one, second one, third one. That's it. Values chappali. That's it. Values is the most important thing. K4 kada. K4 area and the total area of the plate A into epsilon naught divided by thickness. Thickness is D by 2. And here the capacitance is 2K4 A epsilon naught divided by D. That's it. Value raskondi sir. 2K4 A epsilon naught divided by D. Ekkada cheppandi value area A by 3, distance D by 2. Ide kada. So K1 A by 3 epsilon naught divided by D by 2. That's it. So it is nothing but 2 by 3 K1 A epsilon naught divided by D. Alage ikkada kuda K2 area A by 3, thickness D by 2. That's it. So sir, D by 2 kada? Yes. Alage here also 2 by 3 K2 A epsilon naught divided by D, and this capacitor again 2 by 3 K3 A epsilon naught divided by D. That's it. Idigo ee moodu capacitors parallel lo unnappudu direct ga add cheyochu kada. Yes. So sir, the net capacitance comes out to be 2 by 3 A epsilon naught divided by D multiplied by K1, K2, K3. That's it. So this is the net capacitors. Ante mee daggara rendu capacitors migili unnai. So first capacitor ante 2K4 A epsilon naught divided by D, and this one ante 2 by 3 A epsilon naught by D multiplied by K1 plus K2 plus K3. Ochida leda? Yes. Now you basically have to add them in parallel. Series ante inverse chesi add cheyandi. That's it. So sir, 1 upon C net. C net kada. So C net ante D divided by K net A epsilon naught should be equals to 1 upon this plus 1 upon that. Either D divided by cheppandi 2K4 A epsilon naught plus D divided by entrali D divided not D ra 3D by 2 kada. Yes, 3 by 2D. So sir, 3D by 2 multiplied by K1 plus K2 plus K3 into A epsilon naught. Ee edina possible ite cancel cheyandi. A epsilon naught, A epsilon naught, A epsilon naught gone, D gone. And 1 upon K net is equals to 1 upon 2K4 plus 3 divided by 2 times of K1 plus K2 plus K3. That's it. Done? Not done. You can now definitely calculate the value of that. Okay. K net value kavali kada. So K net value is nothing but 2K4 plus 2 times of K1 plus. Arey, not like this, Ra. You can't do the inverted or like this kada. You can add and then inverted or chiyochu kada. Yes, that's it. Energy in the capacitor completed, dielectric completed. Then we have also covered about the capacitance of the capacitor. Mari, what are the terminologies remaining? Cheppandi. What is remaining? In your capacitors, what are the remaining concepts? Capacitors. Grouping done, capacitor done, energy also done. Now, force and charging and discharging of the capacitor. Okay. So, next topic, force, force between force radius. Let us take the break at 5:15. Okay, let us take the break at 5:15. Force between the plates of parallel plate capacitor. Okay, parallel plate capacitor. Cheppandi andaru. So force kavali kada. Let us say the sigma is the plus sigma minus sigma is the charge density of this capacitor. Ide kada? Yes. Mari em kavali meeku area A anukondi. Area is A, distance between the plates is D. Ide kada? So sir, force is nothing but Q multiplied by electric field. Q and entra A into epsilon. Q and into sigma A kada. Sigma into A is the charge. Electric field is sigma by epsilon. That's it. 2 epsilon. So sigma square A divided by 2 epsilon naught. So this is the force between the plates of a parallel plate capacitor. And okay, if you want to convert this, you convert pura cheyochu. So sir, force is equals to sigma square and take Q upon area whole square multiplied by area divided by 2 times of epsilon naught. And that's it. So force is equals to Q square divided by 2A epsilon naught pura rachu. So this is the force between the plates of a parallel plate capacitor. And the last topic that is known as the charging and discharging of capacitor. Okay, charging and discharging of a capacitor. Charging and discharging. Chudandi. So if this is the capacitor connected to a resistor with the battery, and the mamulga battery tone direct we don't connect the capacitor. Okay. Polarization. What is polarization? Not there now. Okay, polarization not there. What are we talking about polarization? Sir. Yes. So let us say the capacitor having capacitance C, resistance R, voltage V. Okay, and the two situations. There are two different cases or two different situations. Both situations lo meeru chala jagrataga undali. Okay, this is the first case. Alage this is the second case. And cheppandi, ee second case lo this is the battery and then this is the capacitor connected to a resistor connected to a battery. Voltage V, resistance R, capacitance C and B. Done. ఇప్పుడు చూడండి అందరూ ఫస్ట్ స్టేట్ అంటే ఇట్ ఈస్ నోన్ యాజ్ ద ఇనీషియల్ స్టేట్. ఓకే, ఫస్ట్ కండిషన్ అంటే ఇనీషియల్ స్టేట్. దట్స్ ఇట్. సో ఫస్ట్ స్టేట్ ఈస్ ద ఇనీషియల్ స్టేట్. అలాగే ద సెకండ్ స్టేట్ వుడ్ బి ద స్టడీ స్టేట్ ఆఫ్ ద కెపాసిటర్. ఓకే, ఇది చాలా 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 ఇంపార్టెంట్ అందరూ. ద సెకండ్ స్టేట్ ఈస్ ద స్టడీ స్టేట్. ఇనీషియల్ స్టేట్ అంటే ఏంట్రా బాబు? At this point of time, your time is equals to 0. Okay, t is equals to 0. And similarly, initial state and the capacitor is uncharged. Okay, uncharged capacitor. At your initial state, uncharged capacitor is there. Okay, so if the capacitor is uncharged, it will charge now. Okay, the capacitance will charge. Either the current. Okay, the charge flows through the circuit. గుర్తుపెట్టుకోండి అందరూ చార్జ్ flows through the circuit ఇదే కదా yes the charge flows through the circuit అంటే ఈ కెపాసిటర్ కి ప్లేస్ లో you replace it with a wire okay so basically whenever you are talking about the initial state లో replace the capacitor with a wire that's it మరి కరెంట్ వాల్యూ ఏంటి సార్ ఇనిషియల్ పాయింట్ ఆఫ్ టైం లో సార్ వైర్ తోనే రీప్లేస్ చేయాలి కదా సో రిమూవ్ ఇట్ అండ్ రీప్లేస్ ఇట్ విత్ ద వైర్ ఓకే ఈ కెపాసిటర్ కి ప్లేస్ లో ఒక వైర్ అటాచ్ చేయండి మరి సార్ కరెంట్ వాల్యూ ఇస్ నథింగ్ బట్ V upon R వచ్చింది కదా బట్ యువర్ స్టడీ స్టేట్ కండిషన్ రా స్టడీ స్టేట్ లో టైం ఇస్ ఈక్వల్స్ టు ఇన్ఫైనైట్ సెకండ్స్ లో స్టడీ స్టేట్ వస్తాయి అలాగే ద కెపాసిటెన్స్ ఇస్ ఫుల్లీ చార్జ్డ్ ఓకే ఫుల్లీ చార్జ్డ్ కెపాసిటర్ ఇస్ దేర్ fully charged capacitor ఇదే కదా yes that means no current will flow ఎందుకంటే ఆల్రెడీ చార్జ్ ఫుల్ అయింది కదా no flow of charge అయితే your current value is 0 అంటే తెలుసా మీకు ఏంటి సార్ if the current value is 0 అంటే ఈ కెపాసిటర్ కి ప్లేస్ లో you can simply break the circuit break చేయండి cut it okay break the circuit that's it so if you are breaking the circuit అంటే no current flow okay no current flow let us see a question based on this I think it has appeared in which year it has appeared but 100% it appeared I think 2025 itself okay yes so there is this question that has appeared sir uncharged ante ela mali charge avutundi uncharged ante the battery is connected kada the battery is connected so battery will slowly send the charge to the capacitor okay yes next let us directly discuss a question under okay 2024 question I have discussed it multiple times children so ide 10 volt battery okay this is somewhere around a 3 ohm or 2 ohm resistance 3 ohm resistance okay connected once again to the capacitor with 5 ohm resistor okay 5 ohm resistor alage it is also connected to 2 ohm resistor చూడండి మరి ఏం కావాలి current at the steady state okay question తీసుకోండి current at steady state is what current at steady state 2024 question here, okay NEET 2024 option A 0.5 ampere option B 1 ampere option C 1.5 ampere option D 2 amperes done not done A not correct ra A is wrong tappu okay steady state ra steady state ante enti telusa meeku steady state ante the capacitor has to be replaced with the break cheyandi ee capacitor ni ade so if the capacitor has been broken ante are entra if you are breaking the capacitor andaru are entra idi yes అయితే no current flowing in this branch ra అంటే ఈ branch ని కూడా రిమూవ్ చేయండి that's it so remove this branch also that's it ఇదే కదా మరి 3 ohm 2 ohm సిరీస్ లో so sir net resistance is equals to 5 ohm అలాగే voltage is equals to 10 volt current is equals to V upon R అంటే 10 upon 5 అంటే 2 amperes of current is flowing okay Yes. So it is 449. Another. I think we are good to go with the weak quiz. Okay. Not C. Option D is correct. Okay. Option D is correct. Good petko. It's a steady state. Steady state lo capacitor remove cheyandi, circuit break cheyandi. So if the circuit is broken ante bridge broken, no current will flow. Bridge broken, circuit broken, no current flows ante. Yes. 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 Okay. Kavalante, let us take one more PYQ and then we will go towards your weak quiz. Weak quiz no chala easy questions ra. Okay. Very easy questions are. Kabatti everybody. I need everyone to score. Idigo ee question teeskondi andaru 2005 lo vachina question idi. Leda you can take this question also. Now you can take anyone, okay? Two parallel plates having charges plus Q minus Q certain distance. The plates are dipped in kerosene oil tank. Electric field between them is dash. Okay. Yes, a parallel plate condenser oil between the plates. Plus C, the oil is removed the capacity. Question number 39 teeskondi andaru. Okay. Question number 39. A parallel plate capacitor. Condenser ante capacitor, okay, with oil between the plates. Dielectric constant 2 has a capacitance C. If the oil is removed, then the capacitance becomes dash. So dielectric unnappudu the capacitance increases. Okay. So capacitance C ante ide already increased state lo untundi capacitance C. Ide kada. Arey, how can you say that? 2010 and 1990 lo ochina questions ante there is a very high scope ra. Syllabus is there. Format is there, formulas are there. Chances unnai kada. Okay, cheppandi endu. So, in the initial state itself, initial state lone the capacitance is C. Okay. So if there was dielectric andaru, ide mee dielectric kada K unnappudu capacitance maamulgane increases. So normal capacitance C0 anukunte your after dielectric capacitance becomes C0 into K. Idigo C0 into K value is C itself. What is our C0 value enti sir? C0 value is C divided by K itself. K and dielectric constant, dielectric value is 2, so C by 2 is the answer. Okay, option number 2. Good. Okay. Done? Option D is there. Right. Now there are multiple questions. I'm attaching this PDF. We'll solve cheyandi. Okay, attempt cheyandi. We can do that, but it will just waste a lot of time for us. Okay, everybody. Yes. So I think we can go for the weak quiz now. Okay, weak quiz. I don't know how to take it, sir. Students, I want everybody to open the description section of this video, okay? In description section open cheyandi and there are two links, kada? Rendu links unnai. Weak quiz 1, weak quiz 2. Idigo. So this is the description section of this video. Era entra indi. Ide kada? Yes. So the first link is weak quiz 1. Ee link ni click cheyandi okasari. Done? Yes. So this is the weak quiz link under. Later, if the students are not getting the link, go to www.weakquiz.in and then use this code 271642. Okay, 271642 under. Cheppandi, is it audible? Is it visible? Not clear. I think I am clear itself, right? Yes. I can't see your comments. Hey, where is the comment section? Please wait a minute. Yes, guys. Shall we start the quiz section? Everyone joined, not joined? I don't know how to start it. but let us start it. Okay? Yes. Shall we begin the process, Andaru? Shall we start? Everyone done? Everyone done joining the week quiz? Cheppandi okasari. You can go to the description section. Ee video ki description lo week quiz 1 ane link untundi. You can click that link. Leda మీ browser lo weekquiz.in www.weekquiz.in type chesi. You can type that code 271642. Okay, start. Okay. Right. Shall we start the question? Only 12 people are. I need more question. I need more number of students. Andaru? Yes. Not sufficient students. Right. Join the week quiz. Everybody join the week quiz. Join cheyandi, okay? Join cheyandi. Yes. Start the first question. Done? If the distance between two charges is halved, force becomes dash. Okay? Timer running 16, 14, 15, 12, 11, 10, 8, 7, 6, 5, 4, 3, 2, 1. Right. Time up. Okay. Correct option is option C, 4F. Distance reduced. Your force is inversely proportional to distance squared. So if distance is getting half and force becomes 4 times. Okay, this is leaderboard. Everyone. Yes. Who is the winner? Yes. Dr. Varal. Very good. You will regret. Who is this you will regret? Next question. Andaru. Next question. Okay. Yes. Question number 2. Students, attempt cheyandi. Yes. Look at your screen in 1, 0. This is the question. Electric field inside the conductor at electrostatic equilibrium is dash. I have already given you the formula and the statement also. Okay. Yes. Yeah. Think like that. There might be some temporary change, nothing than that. 4, 3, 2, 1. That's it. Done. Results. Correct answer. Option A. Correct only. Very good. But still there are some 2-3 questions who are students who are giving wrong answers. Okay, you will regret. 1843 points. So this is the leaderboard, guys. Varalakshmi is on the 2nd number, Sai Sadhana is on the 3rd number. Next question, final. Okay. Yes, get ready, everyone. Sir, unit of electric field. I have discussed the unit of electric field also. Okay. B or C? Okay. Result. Correct result is C. Volt per meter kuda. Volt per meter. Potential by length kida. You can also write volt per meter. Okay. Leader volt chuta. So these are the top. You will regret again. Next question. Okay. Answer faster. Twarag answer cheyali, okay? Yes, potential due to point charge varies as dash. 30-second timer. 12 students are attending the week quiz in the live mode. what to leave and what not to leave. Nothing could be said. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Time. Results. Correct option is divided by R, KQ by R kida. It is for the field. R square is for the field. Potential కోసం KQ by R. Silly mistake sir, silly mistake అయింది sir. Exam hall లో కూడా ఎలానే silly mistakes వస్తుంది. Okay, you will have to be extra careful with your silly mistakes. Okay, good, very good guys. Next question now. Okay, next question. Under equipotential surfaces are always dash. Potential same అంటే చెప్పండి. Done. 10, 9, 8, 7, 3, 2, 1. Final answer. Done. Okay, very good, very good. Everybody, very good. Right. There is just a single student. Don't know who he is. Okay. Yes. Next question, and the Varalakshmi, very good. Okay. Next question, guys. Capacitance depends on dash. Charge, potential, geometry, time. చిన్న చిన్న questions ఇది మొత్తం. Time up, students. Results చూద్దాం. Geometry. I have given you the statement also. Capacitance is independent of the charge. Capacitance is independent of the potential. Capacitance only depends on the geometry of the system. Not B, not A. It does not depend on the charge. It does not depend on the system also. Does not depend on the charge. Does not depend on the potential. అయితే ER capacitor ఇదిగో చూడండి. Capacitance only depends on the configuration, that is the geometry of the system. Yes. Next, students. Okay, we need to show the leaderboard. Yes. Very good, Varalakshmi, very good. Who else is there now? Okay. So, Dr. Varalu, Sai Sadhana, you will regret. Ramalakshmi, Somesh, Sripati, Sharmila, N. Gayatri, Lekha, Rashmita, and Abhishek. So these are the top 10 students. Okay. Next question, Andhra. So, a normal capacitor low, if you are adding the dielectric, what will increase? Potential will increase, field will increase, capacitance will increase, energy will increase, or what? None. Students who have not joined V-Quiz, okay, click the description section. First link from V-Quiz will be there, okay. Link ni join cheyandi. Very good guys, very good, okay. Correct answer only. Good. Leaderboard చూద్దాం. Okay, again top 10 students. Right, Dr. Varalu, Sai Sadhana, Rama Lakshmi has come to number 3. You will regret gone. Sharmila, very good. Gayatri, Somesh, Lekha, Rashmita, Nitin, Nihita Ramaji. Okay, yes. Next question, Andhar. Eighth question is the energy stored in the capacitor is directly proportional to what? Option A, V squared, V, 1 by V, Q. V and a potential, Q and a charge. V is potential, Q is a charge. And then, yes, all of you who is there, if quiz join Chedaniki, you can click the description section for week quiz 1 and automatically the quiz will be visible. Okay? Yes. 1-0. Time up, Prabham. So the result, correct answer is correctly option A given by 5 students. Okay. Again, let us look at the leaderboard. Varalu number 1, Sai Sadhna number 2, you will regret number 3, Gayatri number 4, Rama Lakshmi number 5, Sripati Sharmila 6, Somesh 7, Rashmita 8, Lekha 9, Nihit Ramaji 10. Yes, last question under Vipru. And after this week quiz, we will take a break, okay? Yes. Electric flux unit, okay? The unit of electric flux is what? Chappan. Newton meter square per Coulomb, Newton Coulomb square, Joule, watt. Okay, it is a little lengthy question under. Four, 3, 2, 1, see. Time up. Result kavali kada? Good. All 6 are correct options only. So this is the leaderboard under based on your discussion. Varalu 1, Sai Sadhana, number 3 is Gayatri. Okay, you will regret is again gone downwards. Okay, Rama Lakshmi, you will regret, Sharmila, Sumesh, Rashmita, Nihit, and then Lekha. So, are we going into week quiz number 2, Ram? Is this week quiz 2? Let me just verify, students. If it's a week quiz 2, then we will stop here itself. Okay. Yes, week quiz 1 only, okay? Sir. Charge conservation, oh my goodness. Right. Right. Final leaderboard. Final leaderboard. Dr. Varalakshmi is the first, 7,808 points. Second, Sai Sadhana, 6,960 points. Third, Gayatri, 5,034 points. Okay, so this was your week quiz. And before starting the lecture, we will take a break, okay? Yes. So let us take a break for 15 minutes now. It's not a dinner break. Mamul gane, 15-minute break. What is the time, sir? 5:07 kada? Yes. So 5:10 varaku, 5:25 varaku, 5:10 nunchi 5:25 varaku break, okay? Break for 15 minutes. Chapters on. Hopefully, we will cover these 3 chapters. Okay, sir. So let's meet at 5:25, guys. Right. Yes. Punishment, Acha. What punishment will you give? What punishment will you give? Cheppandi. What is the possible punishment at enter? Clear everything? Yes, students, please like the video. Okay, like the session, guys. We are now going to go towards the next chapter. Current electricity. Okay, current electricity and then next chapter, and we will be discussing that from the scratch. So. Yes, we are back with the banger. Now, start with the current electricity. Do I have the PYQs of the current electricity? Current electricity PF. So, add it. Complete it. Okay, current electricity. Right. Other student. So, we will quickly go through the sessions, okay, and PYQ kuda solve cheddam parallel, right? Student, the name of the topic is current electricity, kada? So let me also write the topics down. Chapter names are current electricity. Okay. నిజంగా చెప్పాలంటే ఈ పాయింట్ ఆఫ్ టైంలో యూ షుడ్ హ్యావ్ మ్యాక్సిమం నెంబర్ ఆఫ్ అటెండెన్స్ ఓకే సార్ మనిషి నాట్ విజిబుల్ సార్ ఇస్ దర్ ఎనీ అప్డేట్ ఫ్రమ్ ఎన్టీఏ సేయింగ్ ఓపెన్ ఛాలెంజ్ ఆఫ్ ఎన్టీ అరే నో అప్డేట్ ఓకే నో అప్డేట్ ఫర్ నౌ గైస్ చూడండి దిస్ కరెంట్ ఎలక్ట్రిసిటీ ఇస్ ద హైయెస్ట్ weightage చాప్టర్ ఓకే at least 3 to 4 questions expect you to from a single chapter itself okay and there is literally no chapter that is as much important as the current electricity kabatti okka chinna points ni kuda chaala baga study ardham cheyandi everyone okay I am telling you it is one of the most highly weightage chapter right yes. So let us start with the topics of the current electricity first of all. Okay, so let me just write the topics here. Topic number 1. Drift of electrons, okay? Drift of electrons and current under. Yes. Current and a drift of electrons. Resistance and resistivity. Number 3. Combination of resistors, okay? Combination. Batteries kada? Yes. Cells and batteries. Kirchhoff law, power. Kirchhoff's laws. దాని తర్వాత electric power and heat. అయిపోయింది కదా? And then you have Wheatstone bridge. That's it. So let us start the discussion. Okay. Yes. first discussion under drift of electrons kada. So first discussion ante electric current. It's an electric current. Electric current ante rate of flow of charge. Okay. Electric current ante it's rate of flow of charge ni electric current ani antaru. Okay. Yes. Ippudu if you want the formula for the electric current cheppandi andaru. So మామూలుగా నీ current is equals to dq divided by dt. ఇదే కదా. Yes. Or finite terminals లో ఉంటే your current is nothing but charge upon time. That's it. అర్థమైంది అందరికీ? Now there may be different questions ra. Okay, there may be different questions based on different scenarios. Right? Just wait for a minute. Duration till 10 p.m. Okay, students, this class will be till 10 p.m. Long duration drop. Right? 1000 drop. What 1000 drop? Sir, do we have PYQ? Teesko. A flow of 10 to the power 7 electrons per second in a wire constitutes a current of dash. Okay. 38 kada. 38 years PYQ. It will include this question also. Idigo question teeskondi. Okay. Yes. So first question is this. Flow of 10 to the power 7 electrons per second. Okay. 10 to the power 7 electrons per second. Mari charge calculate. Current kavali. Current kada. Yes. What about current? Other chudandi. So already it has given you the rate of flow of current ra. Idigo. So sir, prati oka second lo there are 10 to the power 7 electrons. Okay. That means 10 to the power 7 electrons per second. This is the current itself ra babu. Ippudu you need to calculate it in terms of ampere. Ampere ante now you need to write the value of charge in terms of coulombs kada. Coulombs. So sir, oka electron kosame charge is equals to E. E value telusa meeku 1.6 10 to the power minus 19. Alage for n number of electrons, charge is n into E ante 10 to the power 7 multiplied by 1.6 into 10 to the power minus 19 coulomb per second. So coulomb per second ante ampere andaru chudandi. So it is nothing but 1.6 multiplied by 10 to the power minus 12 ampere of current. Okay, vachida leda? There is the option. Yes, there is the option. Option 8. Right? Not right. Yes. Students, next Babu, next. Okay. Ippudu let us talk something about the drift velocity. Okay, drift velocity. Andaru chudandi. So drift velocity kosame the discussion would look something like this. Ide me normal cylinder anukondi. Metallic kada. Metal or conducting cylinder. This is your conducting cylinder. Everybody. Yes, good. Hi guys. Hi. Hello everybody. Hello. Chudandi, so this is the electron kada. Electron ఉన్నప్పుడు what you are doing, you are basically applying the battery. Idigo. So this is the battery, sir. So what is happening due to the battery? Battery has a potential V. If battery potential valla the electron will slowly try to jump towards the right side. Ide kada positive terminal kabatti positive charge, and if this is positive charge ante electron is trying to come to the positive charge of the battery. Ippudu chudandi andaru ee cylinder ki length ella anukunte field enni vastayi cheppandi. What is the electric field inside the conductor? Ide kada meeku field kavalante meeru simple ga electric field is nothing but V upon L cheppochu. Okay, point number 1 to be noted. Alage ippudu I am doing entire discussion in terms of electric field only. Endukante electric potential ochindi kada, length L unnappudu electric field kuda V upon L vastayi. Okay, like we have mobile shop patent. So ade done, not done andaru cheppandi. Yes. So when you try to find the net force on the electron, okay, net force on the electron, and electrostatics nunchi formula kadara, E is equals to F upon Q. Electric field is a force by charge kada. Kabatti force on the electron. What is the force on electron, sir? force on electron is nothing but q multiplied by e. Q ante charge is the electric field, okay? E ante electric field ee formula lo aithe e multiplied by e vastayi. This is the force on the electron, okay? So electron paina force ante e into e. అర్థమైంది అందరికి? ఇప్పుడు ఫోర్స్ నుంచి యాక్సిలరేషన్ కావాలి. సో యాక్సిలరేషన్ ఇస్ నథింగ్ బట్ ఫోర్స్ డివైడెడ్ బై మాస్ అందరూ. అయితే E into E force की place లో divided by mass. So this is the acceleration of electron. What is it, sir? E divided by m. ఇదే కదా? Yes. So this becomes the acceleration of electron. మరి ఒకసారి మీ దగ్గర acceleration కూడా వచ్చిందంటే now what you have to do, you basically have to talk about the time. చూడండి. So if this is a single electron inside the conductor, ఇదే కదా? Yes. If this is a single electron inside the conductor అంటే there is one more electron here. ఇదిగో మరి సార్ ఈ రెండు ఎలక్ట్రాన్స్ కి మధ్యలో డిస్టెన్స్ అంటే లాంబ్డా అని అంటారు, ఓకే? అండ్ దిస్ లాంబ్డా ఇస్ నోన్ యాజ్ ద మీన్ ఫ్రీ పాత్ ఆఫ్ ద ఎలక్ట్రాన్స్, ఓకే? లాంబ్డా అంటే మీన్ ఫ్రీ పాత్ అందరూ. ఇప్పుడు చూడండి, సో యాజ్ అ ఫంక్షన్ ఆఫ్ టైం కదా, టైం. సో వాట్ ఈస్ హ్యాపెనింగ్ దిస్ ఎలక్ట్రాన్ విల్ గో అండ్ హిట్ అనదర్ ఎలక్ట్రాన్, ఇదే కదా? సో ఈ హిట్టింగ్ ప్రాసెస్ కోసమే టైం అంటే టౌ. ఈ టౌ అంటే రిలాక్సేషన్ టైం అందరూ. సో ఆల్ ద క్వాంటిటీస్ I am writing over this corner. చూడండి. So electric field వచ్చింది. This is the force, this is the acceleration. ఇప్పుడు terminologies అంటే ఇదే. So these are the terminologies. చాలా జాగ్రత్తగా వినండి, okay? Let me write here itself. So these are the terminologies. Number 1, sir. Lambda అంటే mean free path, okay? What is lambda, sir? Lambda is nothing but your mean free path. అలాగే if you want to talk about tau is nothing but the relaxation time, okay? Relaxation time, that's it. వచ్చిందా లేదా అందరూ? ఇప్పుడు యాక్సిలరేషన్ వచ్చినప్పుడు యూ నీడ్ టు ఫైండ్ ద వెలాసిటీ కదా. మరి సింపుల్ ఫార్ములా యూజ్ చేయండి, v is equals to u plus at. అదే కదా, ఇనిషియల్ స్పీడ్ ఆఫ్ ఎలక్ట్రాన్స్ 0 అనుకోండి. కాబట్టి ఫైనల్ స్పీడ్ అంటే 0 ప్లస్ యాక్సిలరేషన్ కి ప్లేస్ లో ఈ మొత్తం వాల్యూ పెట్టాలి. సో e డివైడెడ్ బై m మల్టిప్లైడ్ బై టైం అంటే టౌ, ఇదే కదా? ఎస్. సో సార్ ఇక్కడ నుంచి మీ డ్రిఫ్ట్ వెలాసిటీ ఫార్ములా వచ్చింది. వాట్ ఈస్ ద ఫార్ములా ఫర్ డ్రిఫ్ట్ వెలాసిటీ? vd is equals to e tau divided by m. గుర్తుపెట్టుకోండి. లేదా మీకు కావాలంటే డ్రిఫ్ట్ వెలాసిటీ is equals to e tau divided by m multiplied by field, ఎలా కూడా చెప్పొచ్చు. బట్ ఇఫ్ యు ఆర్ టెల్లింగ్ దట్ దిస్ బికమ్స్ ద మొబిలిటీ ఆఫ్ ఎలక్ట్రాన్, ఓకే? ఈ టర్మినాలజీ గుర్తుపెట్టుకోండి ఇక్కడ నుంచి. సో మొబిలిటీ ఆఫ్ ఎలక్ట్రాన్, మొబిలిటీని mu అని అంటారు, ఓకే? yes. సో డ్రిఫ్ట్ వెలాసిటీ ఆఫ్ ఎలక్ట్రాన్ ఈజ్ నథింగ్ బట్ మొబిలిటీ ఆఫ్ ఎలక్ట్రాన్ టైమ్స్ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్ E. వచ్చిందా లేదా? ఐ హోప్ ఇట్ ఈస్ అండర్స్టాండబుల్, రైట్? yes. సో దేర్ ఇస్ సంథింగ్ నోన్ యాజ్ మొబిలిటీ ఆఫ్ ఎలక్ట్రాన్స్. ఇప్పుడు అందరూ చూడండి, వాట్ నెక్స్ట్ కండిషన్ ఇస్ రిక్వైర్డ్ రా, ఓకే? yes. సో టేక్ ద సేమ్ సిలిండర్, అందరూ సేమ్ సిలిండర్ లో ఒక అనాలిసిస్ చేద్దాం, ఇదే కదా? So this is the cylinder, okay? yes. అందరూ చెప్పండి, ఇదిగో. సో ఈ సిలిండర్ లో you basically assume some cross section area, అంటే the way we cut the cucumber slides కదా, లేదా watermelon రా. సో ఈ cucumber slides ని కట్ చేసినప్పుడు you get the thin slides కదా. yes. సో అదే this is one of those thin slices అందరూ. ఈ లెంత్ అంటే x అనుకోండి, that's it. Okay, this length is x. అలాగే there are number of electrons that are flowing through this length, ఇదే కదా? so there are lots of electrons. ఇదిగో ఈ చిన్న క్రాస్ సెక్షన్ లోనే చాలా మంది ఎలక్ట్రాన్స్ ఉంటాయి. సో వాట్ ఇస్ హ్యాపెనింగ్ సార్? ప్రతి ఒక్క ఎలక్ట్రాన్ దగ్గర ఒక స్పీడ్ ఉంటుంది, and this electron wants to move further, that's it. ఓకే, yes. మరి ఏం కావాలి మీకు? టోటల్ నెంబర్ ఆఫ్ చార్జ్. టోటల్ చార్జ్ కావాలంటే q is equals to n into e కదా. yes. n అంటే number of electrons, number of free charges, గుర్తుపెట్టుకోండి అందరూ. yes. సో n అంటే ఏంటి సార్? టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్, లేదా q is equals to capital N multiplied by e. what is this n రా? n అంటే టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్, ఓకే? టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్, దట్స్ ఇట్. మరి సార్ ఈ n కోసమే మరి ఒక టర్మినాలజీ డిఫైన్ చేయాలి. వాట్ ఇస్ దట్ టర్మినాలజీ అంటే స్మాల్ n, ఓకే? yes. మరి స్మాల్ n అంటే ఏంటి సార్? స్మాల్ n అంటే నంబర్ ఆఫ్ ఫ్రీ చార్జెస్, ఓకే? నంబర్ ఆఫ్ ఫ్రీ చార్జెస్ అంటే ఫ్రీ ఎలక్ట్రాన్స్ రా. నంబర్ ఆఫ్ ఫ్రీ చార్జెస్ పర్ వాల్యూమ్ రా, లేదా పర్ యూనిట్ వాల్యూమ్. అంటే యూనిట్ వాల్యూమ్ అంటే 1 వాల్యూమ్ కోసమే n చార్జ్ ఉంటుంది, 2 వాల్యూమ్స్ కోసమే 2n, 3 కోసమే 3n, అలాగే x వాల్యూమ్ కోసమే x into n is the total number of charge carriers. ఇదే కదా అంటే total number of charge రా total number of electrons capital N is equals to small n multiplied by volume వచ్చింది కదా. yes ఇప్పుడు ఈ చిన్న క్రాస్ సెక్షన్ లో టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ కావాలి నాకు. ఐ వాంట్ ద టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇన్ దిస్ స్మాల్ క్రాస్ సెక్షన్ రా. కాబట్టి ఏం చేయాలి సార్, ఏరియా ఆఫ్ ద ఫేస్ A అనుకోండి, డిస్టెన్స్ x అనుకోండి, దట్స్ ఇట్, multiply it. కాబట్టి సార్ నంబర్ ఆఫ్ టోటల్ ఎలక్ట్రాన్ is n multiplied by volume is A multiplied by x. అయిపోయింది, ఫినిష్డ్. ఇదే కదా. yes మరి ఏం చేయాలి సార్, you basically have to talk about the total charge. so q is equals to capital N into E. చూడండి capital N E కదా, అంటే n కి ప్లేస్ లో n capital A x multiplied by E. ఇదే so total charge is equals to n A x into E. వచ్చిందా లేదా. yes so once you have the total charge flowing through the circuit, అంటే ఇప్పటి నుంచి మీరు కరెంట్ వాల్యూ క్యాలిక్యులేట్ చేయొచ్చు కదా. yes so డైరెక్ట్ గా కరెంట్ వాల్యూ I is equals to చెప్పండి అందరూ, I is equals to dq divided by dt. అర్థమైందా లేదా. yes so కరెంట్ వాల్యూ I is equals to చెప్పండి అందరూ, so d by dt of q, d by dt of q, d by dt of q అంటే d by dt of n A x E. ఇదిగో n అంటే నంబర్ ఆఫ్ ఫ్రీ చార్జెస్ పర్ వాల్యూమ్, కాన్స్టెంట్ కదా. ఈ మెటీరియల్ కోసమే n కూడా కాన్స్టెంట్. A అంటే ఏరియా ఆఫ్ ద క్రాస్ సెక్షన్, అది కూడా కాన్స్టెంట్. E అంటే చార్జ్ ఆఫ్ ఎలక్ట్రాన్, దట్ ఈస్ ఆల్సో కాన్స్టెంట్. ఇదే కదా. yes అయితే మోస్ట్ ఆఫ్ ద వాల్యూస్ ఆర్ కాన్స్టెంట్, బయటికి రాస్తుంది. సో కరెంట్ ఈజ్ ఈక్వల్స్ టు NAE మల్టిప్లైడ్ బై x. ఇప్పుడు చూడండి x అంటే చిన్న లెంత్ కదా, సో ఈ x అంటే ప్రతి ఒక్క సెక్షన్ కోసమే x వేరే వేరే వస్తాయి. సో ఏం చేయాలి సార్, డిఫరెన్షియేట్ చేయండి. సో సార్ ఇంటూ dx డివైడెడ్ బై dt. ఇదే కదా. yes సో కరెంట్ ఈజ్ ఈక్వల్స్ టు NAE multiplied by dx by dt is known as drift velocity. చూడండి కాబట్టి మీ దగ్గర కరెంట్ ఫార్ములా కూడా వచ్చింది. వాట్ ఈస్ drift velocity? E N A వీనా అని అంటారు. ఓకే, డ్రిఫ్ట్ వెలాసిటీ ఇంటూ చార్జ్ ఇంటూ నంబర్ ఆఫ్ ఫ్రీ ఎలక్ట్రాన్స్ పర్ వాల్యూమ్ మల్టిప్లైడ్ బై ఏరియా, ఏరియా ఆఫ్ ద క్రాస్ సెక్షన్ కూడా చెప్పొచ్చు. ఓకే, సో దిస్ ఈస్ ద ఫార్ములా ఫర్ ద కరెంట్ ఇన్ టర్మ్స్ ఆఫ్ డ్రిఫ్ట్ వెలాసిటీ. వచ్చిందా లేదా అందరూ? సో ఆల్ ఆఫ్ దిస్ ఫార్ములాస్ విల్ డిస్కస్ ఇట్ వన్స్. దాని తర్వాత PYQs పైన జంప్ చేద్దాం. ఓకే, ఇది చూడండి. మరి once you are done writing the current value అంటే ఇక్కడ నుంచి current density is the next terminology that we have to discuss. okay, current density అందరూ చెప్పండి ఏంట్రా ఇది? current density అంటే it is usually represented by the letter J. అందరూ what is the value of current density? it is nothing but current divided by area. ఇదే కదా. But sir, area should also be perpendicular area, that is perpendicular to the direction of a flow of a current. Okay, yes, a relationship between current and a drift. Yes, that is the relationship between current and drift velocity. I is equals to V now. Okay, idigo andaru. So J is equals to I ki place lo raskondi. Drift velocity, charge of electron, number of electrons per volume, area of the cross section divided by area gone. కాబట్టి J value is equals to చెప్పండి ఏంట్రా ఇది? డ్రిఫ్ట్ వెలాసిటీ సార్. వాట్ ఈస్ ద వాల్యూ ఆఫ్ డ్రిఫ్ట్ వెలాసిటీ? ఇదిగో ఇక్కడ డ్రిఫ్ట్ వెలాసిటీకి పని ఉంటుంది. సో హియర్ ద వాల్యూ ఆఫ్ డ్రిఫ్ట్ వెలాసిటీ అంటే E tau E by m కదా. డ్రిఫ్ట్ వెలాసిటీ E tau E by m. డ్రిఫ్ట్ వెలాసిటీ E tau E by m multiplied by E into n is the value of G. అయితే కరెంట్ డెన్సిటీ J is equals to చెప్పండి అందరూ ఏంట్రా ఇది? E square n tau ఎలక్ట్రిక్ ఫీల్డ్ డివైడెడ్ బై మాస్ ఆఫ్ ఎలక్ట్రాన్. m అంటే మాస్ ఆఫ్ ఎలక్ట్రాన్. ఓకే, సో ఇక్కడ నుంచి you send everything this side రా అంటే E వాల్యూ క్యాలిక్యులేట్ చేయాలి. సో ఎలక్ట్రిక్ ఫీల్డ్ వాల్యూ is equals to m divided by NE square tau multiplied by current density J. అందరూ ఇప్పుడు this entire quantity that we have, ఈ క్వాంటిటీని resistivity అని అంటారు. ఓకే, resistivity into J. This quantity is known as the resistivity. ఓకే, resistivity. ఇప్పుడు చూడండి E అంటే ఏంటి సార్? ఎలక్ట్రిక్ ఫీల్డ్. What is the relationship between B and E sir? So sir, E is nothing but dV by dx. అదే కదా సింపుల్ టర్మ్స్ చెప్పాలంటే dV by dx లేదా dV by dl. అదే సో సార్ ఎలక్ట్రిక్ ఫీల్డ్ E is nothing but dV. V అంటే పొటెన్షియల్, ఇక్కడ V అంటే పొటెన్షియల్, స్పీడ్ కాదురా, డోంట్ గెట్ కన్ఫ్యూజ్. dV by dl should be equals to rho multiplied by J. J అంటే కరెంట్ డెన్సిటీ I by A. ఇదే కదా. yes, so dl డివిజన్ లో ఉన్నప్పుడు అక్కడ పంపేయండి, మల్టిప్లికేషన్ లో పోతుంది. that's it. so your dv వాల్యూ, చిన్న పొటెన్షియల్ చేంజ్ ఇన్ ద పొటెన్షియల్ డిఫరెన్స్ is nothing but rho multiplied by I divided by A multiplied by dl. అదే మరి ఇప్పుడు ఏం చేయాలంటే ఇంటిగ్రేట్ చేయాలి. L is equals to 0 నుంచి టోటల్ L వరకు, అలాగే పొటెన్షియల్ డిఫరెన్స్ V 0 నుంచి V వరకు. that's it. so integral dv is V. అలాగే I కాన్స్టెంట్ రా, A కాన్స్టెంట్, రో కాన్స్టెంట్ బయటికి తీసుకోండి. సో I రో డివైడెడ్ బై A మొత్తం కాన్స్టెంట్ వచ్చింది మల్టిప్లైడ్ బై L. ఇదే కదా. ఎస్. సో సార్ ఇక్కడ నుంచి యూ కెన్ ఆల్సో రీరైట్ ద ఎంటైర్ ఎక్స్ప్రెషన్. V is equals to చెప్పండి ఏంటి సార్ అది, I మల్టిప్లైడ్ బై రో L డివైడెడ్ బై A అంటే rho L by A becomes the new terminology. ఈ rho L by A కి ప్లేస్ లో you can write R. R అంటే resistance. ఓకే, అందరూ చూడండి. What is R? R is your resistance. కాబట్టి V is equals to IR వచ్చింది. So this is the derivation of Ohm's law. ఓకే, మీకు కావాలంటే you can always substitute the value of resistivity. What is the value of resistivity, sir? Resistivity V is equals to I into R kada. So let us focus on this terminology ra. So R is equals to rho L divided by A. Kani rho is equals to M divided by NE square tau. That's it. Substitute cheyandi. Kabatti your resistance value comes out to be ML divided by NE square into tau into area A. Vachinda leda. So this is the value of resistance. Ardhamainda leda andaru. So the relationship of resistance with the length, alage relationship of resistance with the area of the cross section, it is right there in front of you. Andaru ide kada. yes, so if you want to talk about resistance with respect to length, andaru, so your resistance is directly proportional to length. ante long wire unnappudu resistance kuda chaala ekkuva untundi, లేదా resistance is inversely proportional to area. ante if the wire is thicker, resistance chaala takkuva untundi. okay, yes, andaru like the video guys. sir, guys, I'm back. yes, welcome. okay, welcome. There you go. So resistance and rho L by A kada. that's it students. 101. let us aim for 150 likes ra. 150 possible ah leda. yes, I think it's possible. 200 likes ah. let us aim for 200 likes guys. 200 likes cheyandi. 200 likes ah. yes. So resistance directly proportional to length, resistance inversely proportional to area. Ide kada. These are the terminologies. Good petkondi. Mari there are some questions in which PYQs lo konni PYQs unnai. In that they say that మీ దగ్గర wire untunda, the length of the wire L, area of the cross section A. Now you are stretching that wire. So ఈ stretching వల్ల the length of the wire increased to double. మరి resistance చెప్పాలి. okay, yes, okay. చూడండి. so let us do the PYQ itself now. correct ah లేదా? yes. so let us directly go towards your Ohm's law. so the resistance of wire is R. if it is melted and stretched to n times its original length, the new resistance becomes stretched. ఇది మళ్ళీ ఒకసారి similar question వచ్చింది కదా. yes, you have again a similar question. what is the answer? చెప్పండి. ఆన్సర్ చెప్పాలి. ఆన్సర్ చెప్పాలి. ఆన్సర్ కావాలి. ఓకే, లెట్ us aim for 200 likes everyone. let's aim for 200 likes guys. yes. so idigo volume of the wire anyhow remains the same kada. yes. అంటే sir volume is nothing but area into length. so area A అనుకోండి, length L అనుకోండి. now if the length has become n into L అంటే area will decrease by A by n. ఇదే కదా. yes, d. sir let us see ra. okay, let us see. చూద్దాం. ఇది కొందాం. so question తీసుకోండి. resistance R. okay, length is increased to n times original length. okay, సో మామూలుగానే your wire has the resistance of R but the length of the wire is somewhere around L. Okay, let us say the length is L and the resistance is R. R is equals to resistivity multiplied by length divided by area. If you have melted this wire and increased the length of this wire by n times. And ఇప్పుడు కొత్త length ఏంటంటే n times the original length. Area కూడా it should reduce okay, area should decrease so ఇప్పుడు ఇదిగో so n times length వచ్చింది కదా. Yes, so n times length వచ్చింది. మరి area తోనే ఏం రావాలి? What is the area, sir? ఆ కోసమే ఇదిగో అందరూ చూడండి. సో L1 A1 should be equals to L2 A2 volumes కదా. volume L1 into A అంటే volume, L2 into A2 అంటే volume. సో L1 L అనుకోండి, A1 A అనుకోండి, L2 కి ప్లేస్ లో NL వచ్చింది, అలాగే A2 కి ప్లేస్ లో A' రాసుకోండి. LL gone. ఓకే, ఇక్కడ నుంచి మీ A' వాల్యూ ఇస్ నథింగ్ బట్ A డివైడెడ్ బై N వచ్చింది. your final area is A divided by L. మరి సార్ ఫైనల్ రెసిస్టెన్స్ RF అంటే రో ఇంటూ లెంత్ ఫైనల్ ఎంత NL డివైడెడ్ బై ఏరియా. ఫైనల్ ఏరియా ఫైనల్ is A by N. ఇదే కదా. సో రెసిస్టెన్స్ ఫైనల్ is equals to రో మల్టిప్లైడ్ బై ఇదిగో ఈ N పైన పోతుందిరా and that becomes N square multiplied by L divided by A. rho multiplied by L divided by A into N square వచ్చింది. That's it. So rho L by A అంటే original resistance. So sir, final resistance is nothing but original resistance multiplied by N square, not N. Okay, N square అంటే ఏంట్రా? Which is the option? N square is option number B. So everyone was saying answer is B. Okay. Yes. Next question another. మరి ఒక క్వశ్చన్ తీసుకోండి. ఓకే, 2013 లో వచ్చిన క్వశ్చన్ ఇది. ఓకే, ఎనీ మోర్ న్యూ రీసెంట్ క్వశ్చన్ నాట్ దేర్. సరే, సో 2013 క్వశ్చన్ చూద్దాం. వైర్ తీసుకోండి రా బాబు. ఎస్, అందరూ 105 పైన స్టాప్ రా. I was expecting around 150 or 100. Like the video guys, video like it. Sorry, a wire of resistance 4 ohm stretched to twice its original length. The resistance of the wire would become dash. Direct formula based kada. Direct formula based andaru. So length L unnappudu resistance R ga. If the length is L, resistance is R. Okay, but if the length is NL, resistance becomes N square into R. So if you are increasing the length of the resistor by n times ante, the resistance will increase by n square times. Okay, n square times andaru. So ekkada length ni chudandi okasari. Your length has increased by 2 times. Okay, new resistance R new is equals to n square multiplied by old resistance. N ante the change in the length. Okay, increase in the length. Mamulgane increase in the length తీసుకోండి. N అంటే ఏంటి సార్? Increase in the length. Okay, increase in the length. Finished. So n square R అంటే ఇక్కడ చూడండి twice its length అంటే n value 2 వచ్చింది. So 2 square multiplied by original resistance 4. That's it. So 2 square into 4 అంటే 4 into 4 అంటే 16 ohms. Option B is the correct answer. Okay. It is a very common question andaru. Chala high weightage question idi. So if you are increasing the resistance of the wire, length of the wire by n times, so what will be the increase in the resistance ante n square. Okay, n square times the resistance will increase. Done? Not done. Yes. Next. Drift questions kada. So let us see about the questions in the drifting part. Ante drift velocity, okay, resistivity and all this stuff. Chudandi. So this is the question andaru. తీసుకోండి క్వశ్చన్ నెంబర్ 10. ఓకే, NEET 2020 లో వచ్చిన క్వశ్చన్ ఇది. A charged particle having drift velocity this much, electric field that much, mobility that much. So there is a relationship between drift velocity, mobility, and then you need to find the electric field. Okay, అరే ఎలక్ట్రిక్ ఫీల్డ్ కూడా ఇచ్చారు కదా. yes, మరి ఏం కావాలి? మొబిలిటీ కావాలి. ఫార్ములా ఫర్ ద మొబిలిటీ, డ్రిఫ్ట్ వెలాసిటీ అండ్ ఎలక్ట్రిక్ ఫీల్డ్ అందరూ. సో డైరెక్ట్ గానే ఫార్ములా ఉంటుంది మీ దగ్గర. ద ఫార్ములా ఇస్ డ్రిఫ్ట్ వెలాసిటీ VD. VD డ్రిఫ్ట్ వెలాసిటీ ఇస్ ఈక్వల్స్ టు, చెప్పండి ఎందుకు, VD ఇస్ ఈక్వల్స్ టు డ్రిఫ్ట్ వెలాసిటీ మొబిలిటీ టైమ్స్ ఎలక్ట్రిక్ ఫీల్డ్. అదే మొబిలిటీ కావాలంటే మ్యూ ఇస్ ఈక్వల్స్ టు డ్రిఫ్ట్ వెలాసిటీ డివైడెడ్ బై ఎలక్ట్రిక్ ఫీల్డ్. ఇదే కదా. డ్రిఫ్ట్ వెలాసిటీ ఎన్ని ఉన్నాయి సార్? drift velocity is a 7.4 10 to the power minus 4, 7.5 10 to the power minus 4. Okay. Divided by electric field enta sir 3 10 to the power minus 7. Okay, so 3 into 10 to the power 10 kada 10 minus 10 minus 10, yes, minus 10. Either mobility is nothing but 75 by 3 into 10 to the power 5. That means 2.5 into 10 to the power 6. That's it. There in the option, there in the option, option fails. Done? Not done. Guys, this video ni okasari like cheyandi. Next question goes Amit. Okay, let us look for the next question. Drift velocity, mobility kadara. చూడండి, every single formula is very important అందరూ, కాబట్టి చాలా జాగ్రత్తగా చేయాలి. ఓకే, ప్రతి ఒక్క క్వశ్చన్ ని కూడా. నెక్స్ట్ క్వశ్చన్ అందరూ, ద మెయిన్ ఫ్రీ పాత్ ఆఫ్ ద ఎలక్ట్రాన్ లాంబ్డా ఇచ్చారు కదా, ఎస్, ఎలక్ట్రిక్ ఫీల్డ్ కూడా ఇచ్చారు. యూ నీడ్ టు ఫైండ్ ద ఎలక్ట్రిక్ ఫీల్డ్ క్యాలిక్యులేట్ చేయాలి కదా, ఎనర్జీ ఇచ్చారు ఆల్రెడీ. ఎస్, ద మెయిన్ ఫ్రీ పాత్ ఆఫ్ ద ఎలక్ట్రాన్ ఇస్ డాష్. The electric field which can give on an average of 2 electron volt energy through an electron in the metal will be dash. చెప్పండి ఎంత? Yes. Hi. Okay. Do it, okay? Do it. Okay. Let's move towards the next topic. Andar, చెప్పండి. So, electrical energy kada. Yes. Next topic andar. Combination of resistors kada. Yes. ఈ చాప్టర్ అయిపోయిన తర్వాత let us take 6 pm 7 8:30. So week quiz number 2 అందరూ చూడండి. So second week quiz, okay? Week quiz number 2 is scheduled at around 8:30 9 pm, okay? 9 pm. Okay? అలాగే let us take the dinner break, okay? For the dinner break at 7 pm. Okay, 7 to 8 dinner break kada. So let us చెప్పండి. So combination of resistors kada. Let us quickly write the formulas. Combination of resistors. First combination ante series combination. Combination number 1 sir, that is going to be series combination. అలాగే parallel combination kada. Yes. చెప్పండి, మీ సిరీస్ కాంబినేషన్ కోసమే ఇదే ఫస్ట్ రెసిస్టర్ R1, సెకండ్ రెసిస్టర్ R2, థర్డ్ రెసిస్టర్ R3, ఇదే కదా. ఎస్, సో యూ విల్ రైట్ సార్ నెట్ రెసిస్టెన్స్ Rnet is equals to R1 plus R2 plus R3 and so on so forth కదా. డైరెక్ట్ సమ్మేషన్ చేయాలి. అలాగే parallel resistors కోసమే, so this is your first resistor R1, second resistor R2, third resistor R3 and so on so forth. So sir, ఈ కేసులో you will write that 1 upon net resistance R8 is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on so forth. వచ్చిందా లేదా? Yes. ఇప్పుడు అందరూ there is a special case known as the Wheatstone bridge. Okay, yes, Wheatstone bridge. ఈ Wheatstone bridge కోసమే there is a typical condition. ఈ condition లో your resistors are neither in series, they are nor in parallel. Okay, yes, అయితే this is the condition of your Wheatstone bridge. చూడండి. Okay, so same way rotate చేయండి. Yes. Correct. This is your Wheatstone bridge. Ante first resistor, ide mee second resistor, third resistor, fourth resistor, alage this one is your fifth resistor. Values teeskondi. Okay, R1, R2, R3, R4 and R5. Okay, yes. So for your Wheatstone bridge andaru chudandi. So if the value of R1 divided by R2 is equals to R3 divided by R4 ante ee state ni we call it the balanced Wheatstone bridge. Okay, balanced Wheatstone bridge. ఈ point of time lo you can basically remove the central resistor ante the central resistor could be removed. ఇదే కదా. So if you are removing the central resistance ante this is the final situation. First resistor ide మీ second resistor, this is your third resistor and this one is your fourth resistor. Values తీసుకోండి. R1, R2, this is R3 and ide R4. ఇప్పుడు చెప్పండి అందరూ. So these two are there in series, అలాగే ఇది కూడా these two are also there in series and then these two they are there in parallel. That's it. Okay, finished. So if you want to discuss some questions, only questions kuda unnai. Okay, so you can definitely talk about the questions. So where are the questions, sir? Where is the question? This one. Okay. 1997. Two old questions right here. తీసుకోండి అందరూ. Okay, the current in the following circuit is dash. So ide 3 ohm 3 ohm 3 ohm 2 volt battery. Okay, let me write it clearly all of you. Yes, so the voltage of this battery is a 2 volt. alage idi kuda 3 ohm, this is also 3 ohm resistance and this is also 3 ohm resistance. Done. Cheppandi. It's a zoom only, okay? It has already been zoomed. See here, 2 by 3, 1, 1 by 8, 2 by 9. So, it's a simple combination, brother. Series parallel chudani. Idigo. So, these two are in series. Students. So, 3 series lo unte 3 and 3 becomes a 6 kada. Yes. Now this is 6 ohm and this 3 ohm, they are in parallel. Kabatti R net value is nothing but R1 into R2 divided by R1 plus R2 kuda cheppochu. That's it. R1 value 3 anukondi, R2 6 anukondi, divided by R1 plus R2 ante 3 plus 6. 3 into 6 18 divided by 3 plus 9 2 ante the net resistor of the system is 2 ohms. But battery kuda 2 volt, resistance kuda 2 ohms unnappudu you will simply say that the current is equals to V upon R. Okay, V value 2, R value 2, current is equals to 1 ampere, option number 2. Okay, very simple question ra. Okay, it's a very simple question. Andaru 1997 lo ochina question ante chaala simple question idi. Okay, yes, next question. Yes, yes, do power not there, not done. Idigo infinite bridge ane oka system. Yeah, what is the equivalent resistance between the points A and B? A is there, B is there. Okay, cheppandi adu 10 10 10 10 10 10. Okay, I think it needs symmetry, okay? So you can do it. Two wires of the same metal have same length, but their cross section area is 3:1. They are joined in series. The resistance of the wire is dash. Total resistance of the combination will be dash. Sorry, calculate chain enter. This is also a doable question, kada? Question number 63. Enta dark, intrabab. This is my slang, okay? That is my slang actually. Cheppandi adu. What is the time now? 7:10 kada. Class duration till 10 p.m. ram. Okay, class duration will be till 10 p.m. Quiz will be at 9 p.m. Quiz tarvata we'll take some problems if possible, and then we will leave the order. Okay. So chuda video on the student. So two wires of same metal have same length. L1 equals to L2 kada. Cross sectional area is 3:1. The resistance of the thicker wire 10 ohm untundi. Chudandi. It's a very good question actually. Okay. Yes. And so resistance cheppandi ra okasari. Resistance is equal to rho L by A kada. Yes. The resistance of the wire is nothing but rho L by A. So sir, R1 is equals to rho L1 by A1. Alage R2 is equals to rho L2 by A2. Done? Not done, right? Ikkada nunchi rho value ochindi R1 A1 divided by L1. Alage rho value ochindi R2 A2 divided by L2. Ide kada? Yes. Mari em ravali sir? R1 A1 by L1 rho is equals to R2 A2 by L2 rho. Ade. Done? Not done. Lengths matrame same untundi. Lengths are same kada. Kabatti R1 A1 area should be equals to R2 A2. That's it. Andaru. Ide kada? Area value ratio chudandi 3:1 ante A1 by A2 3:1 untundi. That's it. So sir, A1 by A2 3:1. Ide kada? Yes. So A1 by A2 3:1. A1 by A2 is equals to 3:1. Kabatti A1 ki place lo 3 times A2 pettandi. That's it. So A1 ki place lo 3 times of A2 multiplied by resistance kuda 10 ohms kada is equals to R2 multiplied by A2 gone. Aithe your second resistance is equals to 30 ohm. Finished. And the first resistance and the second resistance. Okay, array thick kada resistance of the thick wire ra. Thick wire ante A1 ki resistance is R1 kada. Yes. Lengths are same. So R1 A1 is equals to R2 A2 kada. So A1 ante 3 times A2 raskondi. So sir, R1 ditta kada 10 multiplied by 3 times of A2 is equals to R2 multiplied by A2. A2 gone. So R2 is equals to 30. There the options are not there in the options. Sir, 10 by 3 plus 10 kada. So 10 by 3, 30 by 3. And PYQ solve చేసినప్పుడు మాత్రమే ఇలా ఫార్ములా అప్లై చేయాలి అని రావడం లేదు. Yes. That is the problem with almost every single student. Chudandi, idi andaru. The problem is that the resistance of the thicker wire is 10 ohms. Ide kada. That means thick wire ఉన్నప్పుడు resistance కూడా చాలా తక్కువ ఉంటుందిరా. Okay, resistance will be low for thick wires. Okay, and for thin wires resistance will be high కాబట్టి R2 value 30 ohm వచ్చింది, R1 value 10 already ఇచ్చింది కదా. yes, thick wire అంటే resistance తక్కువ 10 ohm ఇదిగో. అలాగే for thin wire the resistance is 30 ohms. మరి మీకు టోటల్ రెసిస్టెన్స్ కావాలంటే ఇదే R1 వాల్యూ, దిస్ ఇస్ R2 వాల్యూ 30 ohm 10 ohm యాడ్ చేయండి, నెట్ రెసిస్టెన్స్ వాల్యూ ఇస్ 40 ohms. ఓకే, ఇఫ్ యు ఆర్ నాట్ అండర్స్టాండింగ్ ఇది దట్ ఈస్ ద మోస్ట్ కామన్ ప్రాబ్లమ్ ఫర్ ఎవ్రీ సింగిల్ స్టూడెంట్. అంటే ఫార్ములా వస్తుందా కానీ క్వశ్చన్స్ రాదు, మరి ఎలా చేయాలి సార్? ప్రాక్టీస్. ఓకే, యూ నీడ్ టు హ్యావ్ ద సొల్యూషన్ రా. ఒక సొల్యూషన్ చూడండి, ఒక 10 క్వశ్చన్ సొల్యూషన్ చూడాలి. So if you think that those 10 question solution are variable, then automatically you will keep on getting the answers. Okay, yes. Next question chuddama. What is the next question in the array? Not this ra. Huh? Where is our main branch ra? Where is our main question paper? Array, ikkada question paper. Yes, this is the question paper kada. Yes, 1995 lo vachina question idi. Now I want you to go through one more question. Answer the question. 6 resistors kada. Yes, ee question teeskondi okasari. That's it. So 1994 question idi, but it's a very good question. Okay, valid question. చూడండి, ప్రతి ఒక్క రెసిస్టర్ అంటే 3 ohm each. ఓకే, three ohm each are connected kada. So 1 2 3 4 5 only ra 6 ade 6 resistors are there. 1 2 3 4 5 6. Okay, and 3 resistors are connected across AC, AD and AE as shown in the figure. మరి ఏం క్యాలిక్యులేట్ చేయాలి మీకు? resistance between points A and B. So this is the first point A, alage this is the second point B. So ఈ రెండు పాయింట్స్ కి మధ్యలో resistance కావాలి కదా. yes, I would recommend you to start this discussion from this ra. ఇదిగో, సో ఈ రెండు parallel లో ఉంటుంది, సిరీస్ లో ఉంటుంది కదా. yes, series then parallel then series then parallel then series parallel series parallel go. Again I am giving you hint. Okay, again I am giving you hint. Again I am giving you hint. So when you are solving the question 3 are series kada, series tarvata parallel then series then parallel then series then parallel then series and then parallel. Final answer వచ్చింది. That's it. అందరూ ఈ వీడియోని లైక్ చేయండి ఒకసారి. 200 likes రా, టార్గెట్ అంటే 200 likes. Let us see how many likes we can get. 6:18 break at 7 p.m. okay, and the break will be given at 7 p.m. to all of you. Okay, చెప్పండి guys. Yes, so let us solve this question. అందరూ చూడండి. So first of all, this 3 and 3 becomes 6 కదా. yes, 6 ohm వచ్చింది. మరి ఇప్పుడు this 6 and 6 they are in parallel. చూడండి, so 6 and 6 parallel అంటే it becomes half. 3 3 3 3 3 3. So ఈ మొత్తం కి ప్లేస్ లో you have to write 3 ohms. okay, so instead of all of this just write 3 ohms as a series. ఇప్పుడు చూడండి 3 3 మళ్ళీ ఒకసారి సిరీస్ లా, సిరీస్ అంటే 3 3 becomes 6, again 6 6 becomes parallel, parallel అంటే మరి ఒకసారి 3 వచ్చింది. ఇదిగో 3 3 becomes 6, 6 6 becomes 3, 3 3 becomes 6, 6 and 3 becomes 2 now. okay, 6 and 3 becomes 2 now. Option A is the correct answer. What? Yeah, Preeti. Yes. Done? Not done. Guys, చెప్పండి ఒకసారి. Right కదా? Yes. So this is everything about power. So this is all about the power itself. Okay. 3 equal resistors series EMF together dissipate 10 watt of power. So power questions we will take it later. That's it ra, that's it. So resistors అయిపోయింది కదా. Resistance in series, parallel, అలాగే Wheatstone bridge also completed. ఇప్పుడు I want to discuss a few more parts. చూడండి అందరూ. Next part ఏంటంటే we need to talk about the what? Guys, let us go to 150 ra. 140 already వచ్చింది కదా. So if you like it, it will easily become 150 now itself. Okay, combination done. Let us talk about the cell now. Okay, కానీ ఆ డిస్కస్ చేసే ముందు I basically want to discuss a simple circuit theory. Okay, circuit theory అందరూ ఇది ఇంపార్టెంట్ డిస్కషన్. ఓకే, చాలా జాగ్రత్తగా వినండి. circuit theory. Circuit theory lo, let us take a most easy and the most simplest circuit ra. So this is the battery. Alage, this is the resistor. వచ్చిందా లేదా yes battery ki potential V అనుకోండి resistance R అనుకోండి అలాగే Ohm's law తోని you can talk about the current so sir V is equals to I into R కాబట్టి current is equals to V upon R కదా yes terminology explain చేయండి ఒకసారి so V అంటే the potential of the battery okay potential of the battery లేదా potential difference created by the battery R is nothing but the resistor resistance value is the value of R వచ్చిందా లేదా అందరూ అలాగే I ante I is the value of the current that is flowing through the resistor done yes ఇప్పుడు జాగ్రత్తగా వినండి okay if you talk about your battery ra మీ battery లో కూడా sir दो push-ups दो push-ups काहे जी काहे को दो push-ups चाहिए तुमको yes अंदर చూడండి so now we are going to talk about the EMF versus potential relationship okay EMF versus potential अंदर చాలా జాగ్రత్తగా వినండి EMF versus potential కదా what is the relationship between EMF and potential చూద్దాం ఇదిగో so first of all మీ బ్యాటరీ లో కూడా కొన్ని internal resistors ఉన్నాయి కదా yes so there is something known as the potential produced by the battery అలాగే there is something known as potential across the resistor okay these two are different things అందరూ high-weightage chapter ide this is only the high-weightage chapter okay చూడండి so if this is the battery ee battery lo kuda chinna internal resistance undi so small r is the internal resistance ide kada and this is the external resistance capital R andaru చూడండి so now when you are talking about the total EMF of the battery idigo so EMF is created by the battery కానీ when it comes out of the battery it becomes a potential అంటే this internal resistance it also consumes some amount of energy కదా yes so capital R అంటే external resistance అనుకోండి ఇప్పుడు చూడండి అందరూ so if there is this current I that is flowing into the circuit ఇదే కదా ఈ మొత్తం system ని you can replace and you can write this way also చూడండి so for this entire system you can shift it outside okay mighty shift cheyొచ్చు అలాగే you can simply talk about the voltage of the battery ide right yes internal resistance has come out ఇప్పుడు చెప్పండి ఒకసారి you will say sir your EMF of the battery అంటే original దీంట్లోంచి potential due to internal resistance gone IR మిగతా అంటే you will say the potential of the battery itself so E minus IR is equals to potential ఇప్పుడు కరెంట్ వాల్యూ కావాలంటే కరెంట్ ని చూడండి ఒకసారి సో EMF is the original voltage కదా బ్యాటరీ కి divided by total resistance so I is equals to E divided by total resistance R plus R series లో ఉంటుంది చూడండి ఒకసారి yes so they are in the series కదా therefore this is the value of the current in the circuit మరి ఈ రెండు ఈక్వేషన్స్ ని కంబైన్ చేసి you get one more equation what is the relationship between that equation sir so E minus I की प्लेस में మొత్తం వాల్యూ సబ్స్టిట్యూట్ చేయండి E డివైడెడ్ బై R ప్లస్ R మల్టిప్లైడ్ బై R ఇస్ ఈక్వల్స్ టు V అదే సో E కామన్ తీసుకోండి యు ఆర్ లెఫ్ట్ విత్ క్యాపిటల్ R డివైడెడ్ బై R ప్లస్ R ఇస్ ఈక్వల్స్ టు V ఇదే కదా yes సో దట్ ఇస్ ద రిలేషన్షిప్ కరెక్ట్ R ప్లస్ R మైనస్ R అదే R డివైడెడ్ బై that's it so sir V కావాలంటే V is equals to EMF divided by capital R divided by R plus small r that's it so this formula has also good number of questions on good పెట్టుకోండి ఇది చాలా ఇంపార్టెంట్ ఫార్ములా అందరూ చాలా మంది క్వశ్చన్స్ వచ్చింది ఇప్పటిదాకా from this formula itself okay no I will not be telling chapters of 11th okay ఎందుకురా కింద టైం వేస్ట్ so as long as I understand I will not be telling the chapters okay sir now based on the two formulas listed okay first one is the battery alage second one is your internal resistance so let us go and let us attempt some of the PYQs what are PYQs all of these are solutions only okay solutions only is there any question resistance between the circuits not there ఈ మొత్తం కదా resistance రా series parallel resistance questions కదా ఇది yes Kirchhoff rules cells in series and parallel okay what did we discuss internal resistance of the cell kada yes do we have the topic of internal resistance of the cell yes we do have the topic of internal resistance kabatti chudandi andaru Question తీసుకోండి. It has appeared in NEET 2013 కదా. Yes, NEET 2013 question ఇది. The internal resistors of the 2.1. Okay, yes, this is the question. తీసుకోండి. The internal resistors of a 2.1 volt cell which gives the current of 0.2 ampere through a resistance of 10 ohm is dash. Yes, Shreya Reddy, చెప్పు. Yes, తీసుకోండి ఎందుకు చెప్పండి. So internal resistance కావాలి. Cell is 2.1 volt, okay, 1 volt. EMF is the cell. EMF of the cell is 2.1 volt. అలాగే 0.2 ampere, correct? External resistance is 10 volt, 10 ohm, and then you need to find the value of internal resistance. అదే చిన్న క్వశ్చన్ రైట్. ఏం కావాలి మీకు? కరెంట్ కావాలి కదా. So I is equals to, చెప్పండి స్టూడెంట్స్. సో కరెంట్ I is equals to E divided by R plus R. Finished. Current, how much current sir? 0.2 ampere. Substitute change. So 0.2 is equals to EMF enta 2.1 divided by R plus R. External resistance is 10. Internal resistance is R. That's it. So 2 is equals to 21 divided by 10 plus R. That's it. Multiply change. So sir, 20 plus 2 times R is equals to 21. That's it. So 21 gone. 2R is equals to 1 and the internal resistance is 0.5. Chinna question kada. That's it. Okay. Not okay. 0.5. Very good. Next part. 73 questions. Array, not 73. 73rd question. Yes. A cell having EMF E, internal resistors R connected across the variable external resistors R. The resistance increase. The plot of the potential difference across V R is given by dash. That's also a very good question. Okay. Chala baga question right. I want everyone to attempt this question from the most sincere perspectives. Okay, Nandal, can we go to 150 likes right now itself? Children, so when was it asked? Means JEE means actually. This NEET kaadu right. This is from JEE means 2012. Cheppandi endhu. So you are given with the variable resistance. Let us do this question also. No problem. EMF internal is the internal EMF E kada. EMF of the cell is epsilon. Okay, right. Alage internal resistance is R connected across a variable external resistance capital R as the value of resistance is increased. The plot of potential difference across R is given by dash. Formula cheppandi sir okasari. V is equals to capital R divided by R plus R multiplied by EMF E. Ide kada? Yes. Okay. మరి ఏం కావాలి మీకు? E వాల్యూ కావాలి or V వాల్యూ కావాలి? Yes. చూద్దాం అందరూ ఇదిగో. సో EMF is nothing but R plus R divided by R multiplied by V. వచ్చిందా లేదా? So you can say EMF is nothing but 1 plus small r divided by capital R into V. That's it. So EMF is nothing but V plus R into V divided by R. That's it. Variable ante R kada. R is the variable part. Andaru R is the variable part. Ante you can say sir Y is equals to idigo ee mottam quantity ni you can call it to be M kada. Yes, M. So sir, inversely proportional to R unnappudu your EMF will look something like this. Student, starting from the point V, okay? V. VR, not here. Value. V value kavali kada. Yes, if you need the value of V, you can take the value of V also, okay? Yes, ఇక్కడ నుంచి you need the value of V actually. Yes. మరి ఏం చేయాలి? V is equals to, correct only, right? Yes. R లేదా you write this way. EMF is nothing but 1 plus R multiplied by, that's it. Okay. So ఇక్కడ నుంచి your V value comes out to be correct only కదా? Yes, correct only. It comes out to be E divided by epsilon, EMF divided by 1 plus R by L. That's it. Okay. So if the R value is 0, same thing. Option A is the correct option. If the R value is 0, and the resistance R value 0 unnappudu V value is epsilon. And it is inversely proportional to R kada. Therefore it goes in a slightly curved manner. Done? Good evening guys, good evening. Yes. Next part of the discussion. You can do it. Okay, same battery supplies a current of 0.5 ampere when connected across a 9 ohm resistor. Internal resistors kavali. That's it. Okay, battery ki EMF and the voltage are constant. But sir, if you are changing the external resistance, the current value is also changing. Yes. So you need to find what? Internal resistance of the battery. Chinna question by 2 ampere flows through the 2 ohm resistors. What formula to use? Cheppandi. So sir, current is nothing but E divided by R plus R. Finished. Ocheda later. EMF is constant draw. Aithe you will write here sir, EMF is equals to I multiplied by R plus R. Ide kada. Substitute cheyandi. So sir, E1 is equals to I1 R1 plus R. Ide kada. E2 E1 same ra. Aithe you will simply say sir, I1 multiplied by R1 plus R should be equals to I2 multiplied by R2 plus R. That's it. Mari R value kavali meeku. I1 R1 I2 R2 is given kada. Yes. Idigo. So I1 is 2, R1 is 2. Substitute cheyandi. So 2 multiplied by 2 plus R is equals to next same battery 0.5 when the connected resistor is 9. So 0.5 multiplied by 9 plus R. Finished. That's it. Equation ochindi substitute chesi solve cheyandi. So 4 plus 2R is equals to 4.5 plus 0.5R. That's it. 4.5 unnappudu you will send there both sides. So 1.5 into R is equals to 1.5 into R is equals to 0.5. So R is equals to 1 by 3 ohm. There in the option 1 by 3 ohm is there. Option B is the option. Done? Not done. The break is coming at 7 p.m. Okay, so this is all about your combination of resistors, internal resistors of the cell. Alage, now we have to discuss something known as what? Something known as combination of batteries. Okay. Yes. Combination of cells. Japan. You can attempt these questions also. Okay. Cells in series and parallel. A battery of EMF 10 volt internal resistance 5 ohm connected across a variable resistance R. The value of power delivery is maximum. R by 2. Okay. Most of the time it is R. Sorry. Anyways, let us discuss about the combination of cells. Yes. Color. We are talking about the concept రెండు రకాలు ఉన్నాయి దీంట్లో కూడా ఫస్ట్ వన్ సిరీస్ సెకండ్ వన్ ప్యారలల్ సో సిరీస్ లో ఉన్నప్పుడు యూ హ్యావ్ టు కన్సిడర్ ద ఇంటర్నల్ రెసిస్టెన్సెస్ ఆల్సో ఓకే డిపెండింగ్ అపాన్ ద టర్మినల్స్ ఆఫ్ ద బ్యాటరీ సో ద టర్మినల్స్ ఆఫ్ ద బ్యాటరీ సేమ్ ఉన్నప్పుడు డైరెక్ట్ గా యాడ్ చేయాలి బ్యాటరీస్ కి ఈఎంఎఫ్స్ కి అలాగే వేరే వేరే టర్మినల్స్ ఉన్నప్పుడు చాలా జాగ్రత్తగా డిపెండింగ్ అపాన్ ద నెట్ ఈఎంఎఫ్ ఆఫ్ ద బ్యాటరీ యూ హ్యావ్ టు యాడ్ ఆర్ యూ హ్యావ్ టు సబ్ట్రాక్ట్ ఓకే yes చూడండి అందరూ సో ఫస్ట్ కాంబినేషన్ is the series combination అలాగే the second combination of the cells is nothing but the parallel combination of the cells కదా yes first combination series second combination is the parallel combination of the cells అందరూ చూడండి సిరీస్ లో వచ్చినప్పుడు this is your first battery అలాగే internal resistance second battery internal resistance this is the best case okay ఇది best case scenario లో your entire set of batteries are having the same potential the same terminologies లేదా same terminals అదే so third battery third internal resistance fourth battery and so on so forth ఇదే కదా yes so E1 అనుకోండి R1 internal resistance E2 R2 E3 R3 E4 R4 and so on so forth yes E4 R4 కదా ఈ పాయింట్ ఆఫ్ టైం లో what do you want sir net potential is equals to E1 plus E2 plus E3 plus అరే మామూలుగానే if you want to add it E net is nothing but equals to E1 plus E2 plus E3 plus E4 plus so on so forth ఇదే కదా అలాగే R net కూడా సిరీస్ లో రా రెసిస్టెన్స్ ఇస్ ఆల్సో ఇన్ సిరీస్ అంటే R1 plus R2 plus R3 plus R4 plus so on so ఇదే కదా మరి ఏం కావాలి సార్ నెట్ పొటెన్షియల్ కావాలంటే యూ విల్ సింప్లీ సే E net minus I times of R సబ్స్టిట్యూట్ చేసి క్యాలిక్యులేట్ చేయొచ్చు ఓకే బట్ వెన్ ద బ్యాటరీస్ ఆర్ ఇన్ parallel సో parallel case లో ఇట్స్ a little complicated case okay this is the most suitable case favorable case easiest case చెప్పొచ్చు but if the battery terminals are reversed లేదా even if you make a little change in the terminals of the battery the situations will change a lot okay చూడండి so you can do it right you can do it other first one internal resistance second one చూడండి ఇప్పుడు టర్మినల్ రివర్స్ అయింది కదా yes అలాగే second internal resistance third internal resistance fourth internal resistance so forth EMF E1 EMF E2 EMF E3 EMF E4 resistance R1 resistance R2 resistance R3 resistance R4 ఇప్పుడు చెప్పండి అందరూ depending upon the net dominant value of the terminals okay you have to take positive and negative terminals okay yes చెప్పండి చెప్పు sir yes Arjun చెప్పు what is the doubt so your net EMF is nothing but E1 minus E2 minus E3 plus E4 అదే కానీ R net కోసం అట్లా కాదు R1 plus R2 plus R3 plus R4 కూడా రాయొచ్చు మరి అలాగే మళ్ళీ ఒకసారి ఈ నెట్ లేదా V కావాలి కదా V net is nothing but E net minus I times of R net కూడా చెప్పొచ్చు చూడండి ఫార్ములా ఫైనల్ ఫార్ములా మాత్రమే సేమ్ ఉంటుంది ఓకే ఏ ఛానల్ లోని కెమిస్ట్రీ అరే లేదురా ఈ రోజు ఫిజిక్స్ కదా మరి ఎందుకు కెమిస్ట్రీ అడుగుతారు I don't know what is the problem with you students okay yes students can we go for 200 legs alage the next combination of the resistors that we have is going to be for parallel combination of the batteries okay parallel combination of the batteries andulo so me parallel combination lo understand so this is your first battery E1 internal resistance R1 E2 internal resistance R2 kada yes E3 internal resistance R3 so ఇదే కదా వాల్యూస్ తీసుకోండి E1 E2 E3 అలాగే internal resistance R1 R2 R3 and so on so forth మరి సార్ if you want the total EMF of the battery అంటే E1 divided by R1 plus E2 divided by R2 plus E3 divided by R3 plus so on so forth whole divided by 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on so forth these are the formulas okay చూడండి ఎక్కడ చూడండి terminals ని చూడండి the terminals are in the same direction కాబట్టి I am just adding it here but if the terminals are changing లేదా if you reverse the terminals అంటే we will not be adding we will be subtracting okay yes మళ్ళీ ఒకసారి game of terminals only ఇదే కదా yes అందరూ so let us see some questions రా ప్రతి ఒక్క కాన్సెప్ట్ తర్వాత మీకు PYQs కావాలి కదా yes you can take these questions as your questions itself okay 86th question అంటే it looks like time saver question so we can definitely attempt question number 86 okay quick to read quick to solve that's it అందరూ చూడండి చేయండి మరి చెప్పండి The batteries of EMF 4 volt, 8 volt with internal resistance 1 ohm, 2 ohm are connected in circuit with the resistance of 9 ohm as shown in the figure. The current and potential difference between the points P and Q are dash. So P and Q and there are the 2 points P and Q. First point P is here. అలాగే second point Q is here. మరి ఏం కావాలి మీకు total current and the potential difference కావాలి that's it. So you can simply say sir if you directly got the value of current so ఏదైనా current ఈ resistors లో పోతున్నా the same current into resistance value become the potential difference across P and Q ఇదే కదా ఇప్పుడు substitute చేసి చెప్పండి so EMF 4 volt is this EMF 8 volt is this internal resistance is 1 ohm and 2 ohm కదా this entire combination is nothing but the combination of batteries in series లో వచ్చినప్పుడు you will definitely talk about the terminals సేమ్ ఉన్నప్పుడు డైరెక్ట్ గా యాడ్ చేయండి terminals వేరే ఉన్నప్పుడు you basically have to take the net EMF of the batteries ఇదే కదా yes ఇప్పుడు చూడండి 4 volt ఇప్పుడు అందరూ జాగ్రత్తగా చూడాలి ఓకే this is the positive plate this is the negative plate అంటే this battery is trying to flow the current in the clockwise direction అలాగే 8 వోల్ట్ కి చూడండి ఒకసారి ఇదే పాజిటివ్ బ్యాటరీ నెగటివ్ టెర్మినల్ పాజిటివ్ టెర్మినల్ కాబట్టి దిస్ బ్యాటరీ ఆఫ్ 8 వోల్ట్ రా ఈ బ్యాటరీని చూసి ఇట్ ఈస్ ట్రైయింగ్ టు రొటేట్ ఇన్ ద యాంటీ క్లాక్ వైజ్ సో 8 వోల్ట్ ఈస్ ద ఆంటీ 4 వోల్ట్ ఈస్ ద అంకల్ సో ఎవరు పెద్దరా whose power is more whose dominance is more anti always dominates sir anti always dominates ఇదే కదా yes కాబట్టి the two batteries are having opposite terminals మరి net EMF కోసమే you basically have to subtract చూడండి terminals చాలా important okay yes ఇదే మీ ఫస్ట్ బ్యాటరీ అలాగే దిస్ ఈజ్ యువర్ సెకండ్ బ్యాటరీ మీరు టర్మినల్స్ ని ఒకసారి అబ్జర్వ్ చేసినప్పుడు యూ విల్ డెఫినెట్లీ కమ్ టు నో ఓకే ఈ 8 వోల్ట్ బ్యాటరీ రా ఇట్ విల్ ట్రై టు రొటేట్ ద కరెంట్ ఇన్ ద యాంటీ క్లాక్ వైజ్ డైరెక్షన్ కానీ 4 వోల్ట్ బ్యాటరీ ఇట్ ఈస్ ట్రైయింగ్ టు రొటేట్ కరెంట్ ఇన్ ద క్లాక్ వైజ్ డైరెక్షన్ కాబట్టి 8 వోల్ట్ ఈజ్ హ్యావింగ్ మోర్ వాల్యూ హెన్స్ ఈ రెండు బ్యాటరీస్ కి ప్లేస్ లో ఒక సింగిల్ బ్యాటరీ రాసుకోండి హూస్ వాల్యూ ఇస్ గోయింగ్ టు బి 4 వోల్ట్ and it should be aligned in the direction of 8 volt battery. But net resistance kosame add these 3 resistors. So 9 plus 2 11, 11 plus 1 12 ohm resistor. Ide. So ochindi kada resistance is 12 ohm, battery is 4 volt. Mari current kavalante directly 1/3 ampere ostundi. So this is your current under 1/3 ampere is the current. No need to see other options also. 1/3 వచ్చినప్పుడు ఒకటే ఆప్షన్ ఉంటుంది కదా వద్దండి. That's it. Okay. Yes, 1/3 ampere, not volt. Current is 1/3 ampere kada. Yes, 1/3 ampere. ఒకటే ఆప్షన్ ఉంటుంది కాబట్టి you just have to write that and leave the other options under. Yes, done, not done, guys. Okay, ఇప్పుడు let us talk about Kirchhoff laws, okay? Kirchhoff laws. Where should I discuss Kirchhoff laws? Batteries in series, parallel, I think. Yes. Now, I want to discuss about Kirchhoff laws. చెప్పండి Kirchhoff laws కదా yes Kirchhoff laws కోసమే మా దగ్గర రెండు laws ఉన్నాయి Kirchhoff laws కదా yes ఫస్ట్ వన్ అంటే కిర్చాఫ్ కరెంట్ లా కేసీఎల్ అని జంక్షన్ లా కూడా అంటారు సెకండ్ లా ఇస్ గోయింగ్ టు బి కేవీఎల్ కిర్చాఫ్ వోల్టేజ్ లా ఓకే కేవీఎల్ లేదా కిర్చాఫ్ వోల్టేజ్ లా స్టేట్మెంట్ చెప్పండి ఒకసారి మీ కిర్చాఫ్ కరెంట్ లా ఇట్ ఈస్ యూజువల్లీ కాల్డ్ యాజ్ జంక్షన్ లా ఆల్సో మరి జంక్షన్ డ్రా చేయండి వైర్ కి జంక్షన్ కదా yes జంక్షన్ లా ఏంటి సార్ ఇది So if you have the junction of the wire అంటే ఒకటే పాయింట్ లో మల్టిపుల్ వైర్స్ కి ఇంటర్సెక్షన్ ఉన్నప్పుడు your Kirchhoff current law లేదా junction law is going to be helpful. అలాగే Kirchhoff voltage law is usually helpful in case of batteries and resistors. That's it, okay? Voltage law అంటే loop law ఇది కంపల్సరీ కాదు okay even if there is no loop you can talk about Kirchhoff law now also okay సరే so ఇదిగో this is the condition అందరూ Kirchhoff voltage law కోసమే there are some set of rules that I want everybody to follow okay yes darken draken or darken సరే so now when you're talking about it అందరూ చెప్పండి so there are some currents కదా ఇదిగో this is current I1 అలాగే ఇదే current I2 అనుకోండి this current is I3 this current is I4 అలాగే this current is I5 similarly this current over here is I6 ఇదే కదా what is the statement of Kirchhoff junction law Kirchhoff current law statement అంటే ఇదే so total incoming current I incoming should be equals to outgoing current total outgoing that's it ఇదే కదా మరి ఇన్కమింగ్ కరెంట్ ఎంత సార్ టోటల్ ఇన్కమింగ్ కరెంట్ చెప్పండి సో ఇన్కమింగ్ కరెంట్ అంటే I1 I2 I3 ఇన్కమింగ్ కదా దట్స్ ఇట్ సో I1 I2 I3 should be equals to outgoing current it is I4 I5 I6 that's it ఇదే కదా 1 2 3 4 5 6 finished కానీ KVL కోసమే కొన్ని సెట్ ఆఫ్ రూల్స్ ఉన్నాయి I want everybody to follow those set of rules rule number 1 అందరూ so whenever we are going yes so whenever we are going from the lower to higher terminal of the battery ide kada yes the potential V increases okay yes so V increases potential increases. అలాగే రివర్స్ చేయండి. రివర్స్ అంటే when we are jumping from higher to lower potential. ఇదే కదా higher to lower terminal. ఈ పాయింట్ ఆఫ్ టైం లో పొటెన్షియల్ డిక్రీజెస్. సో బేసికలీ మామూలుగా చెప్పడానికి your V value decreases. ఓకే, పొటెన్షియల్ వాల్యూ డిక్రీజెస్. అర్థమైంది కదా? yes, పొటెన్షియల్ డిక్రీజెస్. finished. Point number 1 to be noted. అందరూ అలాగే there are two more set of rules that I want everybody to remember. What are the two more sets? చూడండి. So when you are going into the loop, okay, if you are going into the loop అందరూ, so loop లో ట్రావర్స్ చేసినప్పుడు take care of a few things. Okay, yes, inside a loop చూడండి, if this is the current direction, right side కదా, అలాగే మీ లూప్ డైరెక్షన్ కూడా రైట్ లో ఉన్నప్పుడు లూప్ డైరెక్షన్ ఆల్సో రైట్ సైడ్, కరెంట్ డైరెక్షన్ ఆల్సో రైట్ సైడ్, రెసిస్టెన్స్ ఆర్ అనుకోండి. ఓకే, ఇఫ్ లూప్ డైరెక్షన్, ఇఫ్ ద డైరెక్షన్ ఆఫ్ లూప్ ఈజ్ సేమ్ యాజ్ యువర్ కరెంట్ డైరెక్షన్, if the loop direction is same as your current direction, then a point of time lo there will be, okay, there will be a potential drop. Always remember, ప్రతి ఒక్కసారి మీరు లూప్ లో ట్రావర్స్ చేసినప్పుడు మీ లూప్ డైరెక్షన్ అండ్ ద కరెంట్ డైరెక్షన్ సేమ్ ఉన్నప్పుడు the potential drop will always be seen across a resistor. Okay, there will be a potential drop across a resistor and across a resistor. Ide kada? Yes. Similarly, vice versa ante enti sir? If the loop direction is opposite to the current direction, a point of time there will be a potential gain in the circuit. Ide kada? Yes. Second point cheppandi. If loop direction is opposite, if loop direction is opposite to current direction, a point of time go opposite to current direction, then there will be potential gain. Okay, potential gain. ఇప్పుడు జాగ్రత్తగా వినండి, if it is a drop లేదా if it is a gain, value of that drop or value of that gain will always be equals to I times R. I ante the current in the resistor. Okay, then the potential gain is seen. Okay, yes, మరి సార్ డ్రాప్ లేదా గెయిన్ always that is equals to I into R. I ante current going through the resistor. Example చూద్దాం. Okay, let us discuss it with the example. అందరూ ఇదిగో, so if this is the loop, battery రా, అలాగే మరి ఒకసారి రెసిస్టెన్స్, మరి ఒకసారి బ్యాటరీ, then you again have a resistor, then you again have a battery, then again you have a resistor, then again you have a battery, 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 then you have a resistor, మళ్ళీ ఒకసారి బ్యాటరీ, ఓకే, మళ్ళీ ఒకసారి రెసిస్టర్. Okay, values choose. Make sure that you are watching the values in a proper way. Okay, so resistance value తీసుకోండి. resistance R1 అలాగే R2, resistance R3, resistance R4, resistance R5, resistance R6. ఓకే, 6 రెసిస్టర్స్ ఉన్నాయి. వాల్యూస్ V1, V2, V3, V4, V5, ఓకే, V6, V7, V8, V9 అనుకోండి. That's it. అందరూ. So first of all you will have to make sure the direction of the current. Okay, first of all make sure that you are finding the direction of current. Values కావాలి ఆ కోసం. సరే, if you want the values we can also go with the values. కానీ అందరూ try to understand the batteries that are trying to rotate the current in the anti-clockwise direction, they are more dominant. నేను చెప్తున్నా, just listen to me. Okay, believe my words. అందరూ. Yes. So that means we are assuming that the current direction is in the anti-clockwise sense. అలాగే మన లూప్ డైరెక్షన్ కూడా యాంటీ-క్లాక్వైజ్ అజ్యూమ్ చేద్దాం. ఓకే, ఈ పాయింట్ ఆఫ్ టైమ్ లో ఇఫ్ యువర్ లూప్ డైరెక్షన్ అండ్ కరెంట్ డైరెక్షన్ ఇస్ సేమ్, అంటే దిస్ ఈస్ ద రెసిస్టర్, దేర్ విల్ ఆల్వేస్ బి ఎ పొటెన్షియల్ డ్రాప్. ఎందుకు సార్? బికాజ్ లూప్ డైరెక్షన్ అండ్ కరెంట్ డైరెక్షన్ ఆర్ సేమ్. కరెంట్ I అనుకోండి అందరూ. ఎస్, సో స్టార్ట్ ఫ్రమ్ పాయింట్ A అందరూ, స్టార్ట్ ఫ్రమ్ పాయింట్ A. చెప్పండి. సో సార్ పొటెన్షియల్ అట్ పాయింట్ A మైనస్ I ఇంటూ R. ఎందుకు మైనస్ రా? బికాస్ ద కరెంట్ అండ్ ద లూప్ డైరెక్షన్ సేమ్ ఉంటుంది. అదే ఇప్పుడు నెగటివ్ టు పాజిటివ్ కదా, పొటెన్షియల్ గెయిన్ వస్తాయి. అలాగే మళ్ళీ ఒకసారి లూప్ డైరెక్షన్ కరెంట్ డైరెక్షన్ సేమ్ ఉన్నప్పుడు మైనస్ I ఇంటూ R2 రావాలి. plus V2 minus I into R3. ఇదే కదా ఇప్పుడు go on in the upward direction. ఇదే కదా అందరూ. Let us find A here and let us say point B is here. ఇదే కదా point B అంటే ఇదే. So point B వరకు వెళ్దాం. ఓకే, IR3 done. minus V3 ఎందుకంటే సార్ పాజిటివ్ నుంచి నెగటివ్ టెర్మినల్ కదా, అలాగే minus IR4. Similarly you have minus V4 is equals to potential at point B. వచ్చిందా లేదా? Yes. So if you want to find the value of potential at point A minus potential at point B, and it becomes I times of R1 plus R2 plus R3 plus R4 minus of V1 plus V2 plus V3 plus V4. So this is the value of potential difference between points A and B. This is the application of your Kirchhoff voltage law. Done? Not done. Duration will be between 10 p.m. Okay, the break is coming at 7 p.m. Under. Right? Not right. KVL, KCL done. ఇప్పుడు next topic అందరు. Okay. Sir, this is also the application of Wheatstone bridge. Okay, question number 91 చూద్దాం. It has been asked in NEET 2009. Okay, 2009 question ఇది. See the electrical circuit in this figure. Okay, which of the following statement is not correct? Enter. Okay. చూడండి మరి చెప్పండి. 91 question. EMF E1, EMF E2. Okay, EMF E1, EMF E2. E2, yes, E2 is there. So let me just highlight the important information once again. Ide me EMF E2, okay, EMF E2. Alage, this is your EMF E1, right? Resistance capital R, resistance internal small r1, resistance small r2. Here the current is I2, okay? Ide I2 current ra. This is current I2. Alage, ide me current I1 under, okay? Yes. Now I think everything is clear. Cheppandi. Students, ఈ వీడియోని లైక్ చేయండి ఒకసారి, ఓకే? నాకు at least D. Okay. So basically you have to apply Kirchhoff voltage law in both the loops, okay? Direction of current meeku telusu kada? Yes. Idigo. So if you talk in perspective of current I2 ni choose, it will go up kada. So basically your I2 is flowing in this direction. So kabatti you take the loop direction also in the same direction of current. Alage I1 ni kuda choose, your I1 also going in the anti-clockwise direction. So these are the loop directions. So prati oka loop kosame formula raskondi andaru. So in the upper loop the current is I1, alage in the lower loop the current is I2 kada. Yes, cheppandi andaru. Start from a given point, okay? Start from a given point. So ee point nunchi start cheyandi rendu loops kosam ippudu point A anukondi and come back to the same point. So if you are going from point A, so V and A, idigo for the lower loop, okay? For the lower loop, under lower loop kosame cheppali. Okay, potential at point A plus E2 minus I2 R2. Ide kada. Then again it is coming out as minus E1. Again, what is it? I1 kada? Yes, minus I1 R1 is equals to 0. Okay. Alage start for the upper loop. So upper loop kosame cheppandi. Upper loop. What are you going to write, sir? Start from A. So sir, potential at point A minus what is the current flowing I kada? So I1 R1 plus E1 minus I1 into R is equals to 0. Sorry. What do you have to do? You basically have to eliminate it, mari subtract cheyandi ee rendu points. That's it. Okay, subtract the two equations and then you will be getting the equation in terms of E1 and E2. Ide kada? Yes, I2 R2 is there and then you have I1 R1. Idigo. So subtract chesinappudu equation number 1 ochindi. This is the equation number 2. Subtract equation 1 and 2. So we are gone. Alage minus IR1 minus I1 R1 gone. Idigo left is E2 minus E1. Ide kada? E2 minus E1 minus I2 R2. Ide kada? And then again you have what do you have? there, E1 is there. Other, so minus E1 kada. E1 is there plus A. Yes, so minus I to R1 minus E1 minus I1 into R is equals to 0. Okay, now you can basically simplify it, right? So it's very simple stuff now. Okay, so I1 R, I2 R. Yes, correct only. I think we are doing some mistake over here, okay? So I2 is here, I1 is here. So ini kuda I2 teeskondi. Here the two currents are merging kada. So this point of time, the current over here is I1 plus I2. Finished. Now apply cheat. Okay, Kirchhoff voltage law. Start from point A, add all this. Start from point A, add all this for upper loop. Okay, in the upper loop kosam hai. So start from point A. So potential at point A minus I1 into R1 plus E1 kada minus I1 plus I2 multiplied by R is equals to 0. Similarly, next loop. For the next loop, start from point A itself. So potential at point A plus E2 minus I2 R2. Yes. Then if I2 is just getting joined up, so you can say that I1 is contra. Okay. Yes. Minus epsilon 1 EMF 1 minus EMF 1 minus I1 R1 is equals to 0. Okay, now you can subtract and get the answer. E1 gone. Yes, do it. Okay. Right. Now you can do it, okay, because we don't have much time. We'll also have to take a break. So last topic of the discussion, sir. What is the last topic of the discussion? Power and heat, kada? Yes. So let us talk about electric power and heat. Electric heat and power, kada? Yes. Versus potential. Sir. Electric power versus heat. Electric heat. First of all, heat to them. This is the so energy stored in the resistor. Okay. Energy of a resistor. This is Chapandi. So if this is the battery, this battery ki potential V anukondi. And this is the resistor. Chudandi. So whatever energy is stored in the resistor, so the energy in the resistor is nothing but the work done by the battery. Chudandi. Energy in the resistor is nothing but what? Work done by the battery. What is the work done by battery, sir? Work done by battery at Q into V. Not only by the battery, charge, if it is having potential V. And if you are moving in that potential V, the charge and work done is Q into V. Always remember this formula, okay? Yes, so Q into V is energy stored in the battery itself. Okay, we call Q and 8, sir. Q is equals to I into T. Yes. What is Q, sir? So, sir, energy is nothing but Q key place to integral I dt multiplied by voltage raskondi. That's it. Okay. Yes. So, this is the formula for energy. So, if current is constant, energy stored is nothing but I into integral dt. Dt is nothing but T multiplied by V. So, energy stored in the resistor is VIT. That's it. So, this is the heat energy stored in the resistor. But once again, you can write V is equals to IR. Substitute cheyandi, and then you will get the value of energy stored is nothing but V key place to IR raskondi multiplied by I into T. That's it. So, energy stored is nothing but I square into RT. Yes. Similarly, if you want the power kosame, P is equals to dE by dt, leda dW by dt. That's it. So it is nothing but d by dt of energy. Energy is nothing but I square RT. Substitute. Change, differentiate, your power is nothing but I square into R. That's it. Okay, leda I square R and IR into I. Yes. So power is equals to V into R. Finished. Good. Done? Done. So here the chapter is completed, we can say. Okay, students, at least make 150 likes before this everything ends. Let us make 150 likes up. So break at 7 p.m. 7 p.m. Should we take the break now itself? Not now, sir. Break. Input this square. So understand till this point, okay, till this point, current electrostatics, capacitor, current, electricity, okay. Make the topic is 8 magnetic effects of current till 8 and 2 hours left. 8 to 10 magnetic effects of currents. That tarvata we will talk about EMI. Alternating current, if it is possible, we will see. Leda. We will just keep it. A quiz, we will take the quiz after the chapter completes, okay? 8 p.m., 9:30 p.m. we will see the quiz. Quiz low, the questions are there from electrostatics, current, electricity also. Alage, at the same time, the questions are there from your magnetism also, okay? Sir. Yes, so sorry.
क्या तुम आईआईटी के दीवाने हो? आईआईटी की दीवाने आपने लाइन भरपूर
Yes. Hello everybody. So let us go with the volume chapter. Okay. So ippadaaka 3 chapters cover ayindi kada. Yes, what a timing ra. Sir. Next chapter, sir. Peru cheppu. Magnetism, okay? Magnetism andaru. Yes. Magnetism leda magnetic effects of electric current leda moving charges and magnetism ani antaru. Okay? Yes. You are having your dinner, huh? Have it. Okay, eat it while you are listening to the class. Sir. 2 more hours. Topics తీసుకోండి. So the important topics from this chapter. Number 1, sir, Biot-Savart law, okay? Magnetic field. And then you have Ampere circuital law. Okay, 3 laws. 4th one. Force on a moving charge, okay? Force on a moving charge in a magnetic field. Ide kada? Yes. Force on a moving charge in a magnetic field. Alage. Fifth one, and then fifth topic. Force on a current carrying conductor. Next, magnetic moment. Okay, yes. Magnetic moment. ఇది ఈ 6 టాపిక్స్ ఉన్నాయి. ఓకే, yes. మీరు మంచిగా okay. Mostly after this chapter is completed, we will go for the week quiz number 2. Okay, possibly the next chapter లేదా we will end the session here itself. Okay, sir, 15 days road map చేయండి. Already done. Okay, already done. ఈ ఛానల్ పైన వెళ్ళి చూడండి ఒకసారి. I have already done 15 days road maps. అలాగే మీ ఎగ్జామ్ కోసమే 15 days కాదు ఇప్పటి కోసం. So if you leave today's day, it's around 11 days, okay? 11 days. So ప్రతి ఒక్క రోజు ఎక్కడి నుంచి I am going to upload a single video about the strategy, about the confidence boosting, అలాగే exam patterns, అలాగే shortcuts లేదా we also have to do a one video on shortcuts, okay? Yes. So I'm going to make a full video in that I'm just going to talk about shortcuts of physics, okay? కానీ ఈ వీడియోని లైక్ చేయండి first of all. Duration will be till 10 p.m. అందరూ. The duration of this class will be till 10 p.m. and 2 more hours, sir. That's it. Dinner completed. Okay, I was expecting around 150 likes by the break itself, ra. Kani raaledu kada. Yes, students, ఒకసారి లైక్ చేయండి ఈ వీడియోని. Okay, duration will be till 10 p.m. or 10 p.m. Okay, sorry. So start chedam andar chudandi. Before that, let us import the PDF from questions kada. Questions kavali sir. PYQs. So PYQ PDF from. Enter idi. Em jarugutundi sir. Moving charges, magnetism kada. Yes. So we need this PDF. Okay, ఒకసారి ఈ PDF వచ్చిందంటే we can now definitely go for the chapter itself. Okay. Hi, Sean. Hi. Hello, everybody. Hi. Sir. So, let us discuss the chapter. సో ఫస్ట్ టాపిక్ ఏంటంటే Biot-Savart law కదా. yes what is the statement of the Biot-Savart law చూడండి. సో మీ దగ్గర వైర్ ఉన్నప్పుడు this wire actually creates a magnetic field around itself. చూడండి okay. quiz will be at 9 pm రా. okay 9 pm లేదా yes quiz will be by 9 pm అందరూ. okay students 150 చేద్దాం రా. 150 చేయండి. okay 150 26 likes more required. 150 చేయండి అందరూ. ఇదిగో ఇప్పుడు ఇమాజిన్ దిస్ సిచ్యువేషన్ అందరూ. మీ దగ్గర ఒక వైర్ ఉంటుంది. ఈ వైర్ నుంచి కరెంట్ ఐ ఫ్లో చేస్తుంది. దట్స్ ఇట్. అప్పుడు దిస్ కరెంట్ ఈ కరెంట్ వల్ల దేర్ విల్ బి మ్యాగ్నెటిక్ ఫీల్డ్ అరౌండ్ ద వైర్ ఇట్ సెల్ఫ్. ఓకే షార్ట్ కట్ కావాలంటే షార్ట్ కట్ చూడండి. ఇది ఉంది చూడండి. సో ఫర్ దిస్ కరెంట్ ద మ్యాగ్నెటిక్ ఫీల్డ్ విల్ ఆల్వేస్ బి క్లాక్ వైజ్ డైరెక్షన్. సో ఇప్పుడు మీరు నాకు కరెంట్ అజ్యూమ్ చేయండి. ఓకే ఐ యామ్ ద కరెంట్ రా and I am moving forward కదా. so when I am moving forward magnetic field for me will look like this, clockwise. okay yes what is the doubt చెప్పు. అలాగే ఈ కరెంట్ కోసమే కూడా magnetic field will be in the clockwise direction. ఇదే కదా. yes for every current that is flowing the magnetic field that is created is always in the clockwise direction. so if you are seeing that from the current perspective okay చూడండి ఎందుకు అయితే మీరు రైట్ సైడ్ లో చూసినప్పుడు ద మ్యాగ్నెటిక్ ఫీల్డ్ విల్ బి ఇన్ టు ద ప్లేన్ ఆఫ్ ద పేపర్. ఇదే కదా. అలాగే మీరు లెఫ్ట్ సైడ్ ని చూసి ద మ్యాగ్నెటిక్ ఫీల్డ్ విల్ కమ్ అవుట్ ఆఫ్ ద ప్లేన్ ఆఫ్ ద పేపర్. ఇదే. సో దిస్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ ద వైర్. లేదా మీకు డైరెక్షన్ క్యాలిక్యులేట్ చేయాలంటే యూ కెన్ డూ వన్ మోర్ థింగ్ ఆల్సో అందరూ. ఐ విల్ రైట్ ఫర్ టైం పాస్ అని. అరే ఏంటా ఇది ఫోకస్ చేయండి రా ఇక్కడ. యు ఆర్ డూయింగ్ టైం పాస్ ఇది అందరూ. సో వాట్ యూ హ్యావ్ టు డూ నో మీరు ఈ డైరెక్షన్ ఆఫ్ కరెంట్ లో మీ తంబ్ పాయింట్ చేయండి. ఓకే వాట్ ఐమ్ సేయింగ్ మీరు ఈ తంబ్ ని డైరెక్షన్ ఆఫ్ కరెంట్ లో పాయింట్ చేయండి. యూ హ్యావ్ టు పాయింట్ యువర్ తంబ్ ఇన్ ద డైరెక్షన్ ఆఫ్ కరెంట్. పైనకి ఉంటుంది కదా. సో తంబ్ కూడా పైనకి పాయింట్ చేయాలి. ఇప్పుడు ఫింగర్స్ ని కర్ల్ చేయండి రా. సో ఇఫ్ యు ఆర్ కర్లింగ్ యువర్ ఫింగర్స్ అంటే ఇదిగో. సో లెఫ్ట్ రైట్ సైడ్ లో ఫింగర్స్ గోయింగ్ ఇన్ టు ద ప్లేన్ కానీ లెఫ్ట్ సైడ్ నుంచి ఫింగర్స్ కమింగ్ అవుట్ ఆఫ్ ద ప్లేన్ కదా. సో దిస్ ఈస్ ద డైరెక్షన్ ఆఫ్ ద magnetic field. okay direction of the magnetic field. is this wire visible andaru? Is this wire visible? Not visible. yes this wire is visible kada. చూడండి. so if there is this current flowing like this అయితే magnetic field will be produced something like this. visualize చేయండి. okay magnetic field direction is this. okay మరి sir what if you have a loop the rules will change. okay for the loop also the rules will change. చూడండి ఇప్పుడు లూప్ కోసమే if there is this current I flowing like that చూడండి ఇదే కదా మీ కరెంట్ I. మరి ఏం చేయాలి సార్? ఇప్పుడు ఈ లూప్ కోసమే you rotate your 4 fingers in the direction of current. అదే సో ఈ కరెంట్ కి డైరెక్షన్ లో 4 fingers rotate చేయండి. మరి తంబ్ into the plane కదా. it gives you the direction of magnetic field. అందరూ magnetic field V current I వచ్చిందా లేదా? yes Biot-Savart law we are just talking about the magnitude of that current magnetic field. okay చూడండి. so if this is your wire ఈ wire లో current I is flowing మరి ఏం చేయాలి సార్? ఈ వైర్ నుంచి ఒక చిన్న క్రాస్ సెక్షన్ ఏరియా కట్ చేయండి. so let us say this is the small elementary cross sectional area. ఈ లెంత్ dl బార్ అనుకోండి అందరూ. వచ్చింది కదా. yes ఇప్పుడు ఈ వైర్ లోంచి లేదా ఈ క్రాస్ సెక్షనల్ ఏరియా నుంచి ఒక డిస్టెన్స్ ర్యాండమ్ డిస్టెన్స్ r తీసుకోండి అండ్ యు వాంట్ టు ఫైండ్ ద మ్యాగ్నెటిక్ ఫీల్డ్ అట్ పాయింట్ A. ఇప్పుడు ఈ మ్యాగ్నెటిక్ ఫీల్డ్ ఫైండ్ చేయడానికి యు హావ్ ద ఫార్ములా. సో చిన్న మ్యాగ్నెటిక్ ఫీల్డ్ dB బార్ ఇస్ ఈక్వల్స్ టు mu0 I డివైడెడ్ బై 4 pi మల్టిప్లైడ్ బై చెప్పండి అందరూ ఏంటి సార్ ఇది dl బార్ క్రాస్ r బార్ డివైడెడ్ బై r క్యూబ్. ఓకే ఇప్పుడు mu0 ఏంటంటే mu0 is known as the permeability. epsilon naught permittivity, mu naught permeability. okay yes so mu naught ante enti sir? it is known as the permeability of free space లేదా vacuum. okay yes of free space. that's it. అర్థమైంది అందరికి. so this is known as your Biot-Savart law. అందరూ సో నాట్ గోయింగ్ ఇన్ టు మచ్ డీటెయిల్స్. కొన్ని షేప్స్ ఉన్నాయి. ఆ షేప్స్ కోసమే మ్యాగ్నెటిక్ ఫీల్డ్ అర్థం చేసుకోండి, గుర్తుపెట్టుకోండి చాలు. ఓకే that would be more than sufficient. so now let us talk about the shapes. అలాగే మ్యాగ్నెటిక్ ఫీల్డ్ కోసం కూడా ఫార్ములా గుర్తుపెట్టుకోండి. ఓకే ఇట్ ఈస్ మోర్ దెన్ సఫిషియంట్. So first shape is your finite wire andaru. Okay, మీ finite wire now shape number 1 ఏంటి సార్ ఇది? For your finite wire, the first shape is your finite wire. Finite wire అంటే finite current carrying wire. ఇదే కదా? Yes. చెప్పండి. This is the wire. ఇది అందరూ current I అనుకోండి. Due to this wire, I need the magnetic field at some random distance d. ఈ distance d అనుకోండి అందరూ. So ఈ పాయింట్ A పైన నాకు magnetic field కావాలి. ఎలా క్యాలిక్యులేట్ చేయాలి సార్? ఫార్ములా ఉంటుంది ఈ కోసం. Yes. So what to do now? ఇప్పుడు ends ని జాయిన్ చేయండి అందరూ. So join the ends of the wire with the point A. ఇదే కదా? This is the end. వచ్చిందా లేదా? అలాగే ఇక్కడ కూడా జాయిన్ చేయండి. So when you are joining మీ దగ్గర యాంగిల్స్ వస్తాయి. సో ఈ యాంగిల్ θ1, this angle is θ2. మరి magnetic field కావాలి కదా? So magnetic field formula B is nothing but mu naught into I. I ain't sir the current that is flowing in the wire divided by 4 pi multiplied by not 4 pi 4 pi d actually. Okay, mu naught I divided by 4 pi d multiplied by sin of θ1 plus sin of θ2. θ1 θ2 అంటే యాంగిల్స్ చెప్పిన కదా ఇప్పుడు. Yes, sin of θ1 plus sin of θ2. Chidi sir, this is the magnetic field due to the finite wire. Ippudu there are two different cases, okay? Special cases ane cheppochu. So there are two different cases of this entire discussion. Andaru formulas chala important. Formulas are the most important discussion andaru students. So now I want to talk about the next case now. Semi-infinite wire, mari complete infinite wire chudam. Okay? Yes, the second case is nothing but your semi-infinite wire andaru. Semi-infinite wire kada. For your semi-infinite wire, magnetic field kavalante idigo. So this should be your wire. So dot ante infinity paina veltundi. Okay. Yes. So you need the magnetic field at a given point kada. So what do you think is the magnetic field at a given point, sir? Idigo. ఈ పాయింట్ పైన magnetic field కావాలంటే distance calculate చేయండి. So this total distance now, let us say this distance is around d. వచ్చిందా లేదా? Yes. So sir, here ఈ point of time లో your magnetic field B is nothing but mu naught I divided by 4 into pi into d. ఇదే కదా? Yes. So this is the magnetic field. అలాగే if you have completely infinite wire, అప్పుడు you have one more another formula sir for full infinite wire లేదా complete infinite wire. ఇదే కదా third part రా బాబు. Third part అంటే infinite wire. So for this infinite wire magnetic field ఎంత సార్? అదే, that is the doubt. Infinite wire కోసమే distance d అనుకోండి and you want the magnetic field at this distance d అంటే ఫార్ములా గుర్తుపెట్టుకోండి. ఫార్ములా ఇంపార్టెంట్. సో magnetic field B is equals to, చెప్పండి బాబు, magnetic field B is equals to mu naught into I divided by 2 pi d. That's it. Done? Not done. Guys, ఈ వీడియోని లైక్ చేయండి. ఓకే, సో దీస్ ఆర్ ద ఫార్ములాస్ ఫర్ డిఫరెంట్ షేప్స్. మైండ్లో ఉండాలి, ఓకే, ప్రతి ఒక్క ఇన్స్టెంట్లో. డన్ గైస్? ఎస్. ఇప్పుడు లెట్ us discuss some general questions రా. జనరల్ క్వశ్చన్స్ అంటే తెలుసా మీకు? జనరల్ క్వశ్చన్స్ లేదా జనరల్ షేప్స్. ఓకే, షేప్ నెంబర్ 4 3 కంప్లీటెడ్ కదా. షేప్ నెంబర్ 4 ఇదే ఆర్క్ ఆఫ్ ద సర్కిల్. ఆర్క్ ఆఫ్ ద సర్కిల్. చెప్పండి, ఫర్ ద ఆర్క్ ఆఫ్ ద సర్కిల్ వాట్ ఈస్ ద ఫార్ములా ఫర్ ద మ్యాగ్నెటిక్ ఫీల్డ్? కాబట్టి ఒక ఆర్క్ డ్రా చేయండి. అరే ఏంట్రా ఇది? ఇదే ఆర్క్ ఆఫ్ ద సర్కిల్ కదా. Let us say this angle is theta, all of you. And ఈ ఆర్క్ నుంచి కరెంట్ I is flowing, రేడియస్ r అనుకోండి. ఎక్కడ కూడా రేడియస్ r అనుకోండి. సో సార్ మ్యాగ్నెటిక్ ఫీల్డ్ అట్ ద సెంటర్ కావాలరా. మ్యాగ్నెటిక్ ఫీల్డ్ B బార్ at the center. Okay, magnetic field at the center is given by the formula mu naught I into theta divided by 4 pi r. Okay, formula మాత్రమే గుర్తుపెట్టుకోండి. ఇది చాలా ఇంపార్టెంట్ డిస్కషన్. Similarly, if you want the magnetic field for semicircle, అలాగే for a full circular ring కోసమే కూడా రెండు పొజిషన్స్ ఉన్నాయి. ఓకే, yes, fifth position sir, due to the semicircular ring kada at the center. So magnetic field due to semicircular ring at the center కావాలి. Okay, ఎలా calculate చేయాలి sir? So you take a semicircular ring for that. So this is your semicircular ring. ఇదే కదా the center of the semicircular ring. అలాగే first radius, this is your second radius. ఈ angle theta is equals to 1 pi. Pi అంటే 180 degrees కదా. Nothing more, just substitute the value of theta from this equation. That's it. So sir, magnetic field B is equals to mu naught into I into theta divided by 4 into pi into r. ఇదే కదా. మరి theta value pi పెట్టాలి. That is equals to mu naught into I into theta की place లో pi substitute చేయండి divided by 4 pi r. ఇది pi gone. కాబట్టి మిగతా వాల్యూ is mu naught into I divided by 4r. అందరూ ఇది చాలా ఇంపార్టెంట్ స్టేట్మెంట్. PYQs ఉన్నాయిరా. Complete formula based PYQs ఉన్నాయి from this topic. కాబట్టి జాగ్రత్తగా చూడండి. Okay, and last one is the magnetic field due to ring కదా. ring అందరూ. Yes, sixth shape magnetic field due to ring. So if you have to assume that there is this current I flowing into the loop. Okay, yes, ఎప్పుడు full ring ఉన్నప్పుడు you have to draw a circle. ఓకే, ఒక సర్కిల్ డ్రా చేయాలి. ఈ సర్కిల్ నుంచి లేదా ఈ లూప్ సర్క్యులర్ లూప్ నుంచి there is this current I that is flowing కదా. yes, ఇదిగో ఈ కరెంట్ ని I అనుకోండి. అలాగే the same current I is flowing back into the system. ఇదే కదా. మరి టోటల్ మ్యాగ్నెటిక్ ఫీల్డ్ కావాలంటే చెప్పండి ఎంత? θ వాల్యూ ఎంత? ఈ పాయింట్ ఆఫ్ టైం లో సెంటర్ నుంచి θ వాల్యూ is equals to 360 లేదా 2 pi రేడియన్. మరి సేమ్ ఫార్ములా తీసుకోండి. మ్యాగ్నెటిక్ ఫీల్డ్ అట్ ద సెంటర్ is mu naught into I into theta divided by 4 pi r. Substitute the value of theta. So magnetic field is nothing but mu naught into I into theta की place లో 2 pi రాసుకోండి divided by 4 pi into r కదా. pi gone, 2 1s are 2, 2 2s are 4. కాబట్టి your magnetic field at the center is coming out as mu naught I divided by 2 into r. అదే అయిపోయింది అంతే. Done? Not done. Yes guys, ఈ వీడియోని లైక్ చేయండి. again I'm telling you, మళ్ళీ చెప్తున్నాను. Okay, 150 likes sir, 150 likes right now itself. Sorry. So you got this magnetic field due to 6 shapes kada. అయిపోయింది magnetic field. Now let us talk about mu naught I by 2r. Good. mu naught I by 2r. Good. ఇప్పుడు డైరెక్షన్ కావాలంటే డైరెక్షన్ కూడా క్యాలిక్యులేట్ చేయొచ్చు కదా. yes, so curl your fingers along the direction of the current. thumb gives you the direction of magnetic field. Sorry, so ఇప్పుడు if your Biot-Savart law has been completed and we can I think jump into the questions. Motion of the charge in the magnetic field. Curling. Okay. Biot-Savart. ఇక్కడ okay, Biot-Savart ఇదిగో చూడండి. yes, it's a single question actually. ఇది చెప్పాలి కదా. తీసుకో. The magnetic field dV due to small current element dV is to small element carry current dl is dash. Direct Biot-Savart law sir. Simple statement based question kada. Biot-Savart law. mu naught I by 4 pi multiplied by dl bar cross r bar divided by r cube. R cube, where is r cube? R cube is here. కాబట్టి your option is correct. Done? అందరూ ఈ వీడియోని ఒకసారి లైక్ చేయండి. ఓకే, this is my aim. Okay, కానీ మీరు హెల్ప్ చేయొచ్చు. ఓకే, రైట్ అందరూ. సో లెట్ us discuss a few more questions now. Okay, yes, ఈ క్వశ్చన్ అయిపోయింది కదా. నెక్స్ట్ క్వశ్చన్ చూద్దాం అందరూ. సో మ్యాగ్నెటిక్ ఫీల్డ్ ఆన్ ద యాక్సిస్ ఆఫ్ ద సర్క్యులర్ కరెంట్ లూప్. ఇదే a straight conductor carrying current I splits into two parts as shown in the figure. The radius of the circular loop is r. The total magnetic field at the center is dash. So నీకు టోటల్ మ్యాగ్నెటిక్ ఫీల్డ్ కావాలి. చెప్పండి ఎందుకు? So the diagram looks something like this. So let me draw this diagram once again. Okay, so this is the diagram. And then you have a wire. Okay, ఒక wire ఉంటుంది. And there is this current I that is coming from this wire. Okay, and చూడండి అలాగే there is one more wire that is going downwards. It's a very good question actually. Okay, ఇదిగో మరి కరెంట్స్ కావాలంటే కరెంట్స్ తీసుకోండి. The current I is flowing in this wire. అలాగే ఇక్కడ నుంచి it is splitting into two different currents, I1 అలాగే here the current is I2. సెంటర్ పాయింట్ లో మ్యాగ్నెటిక్ ఫీల్డ్ కావాలి. సెంటర్ పాయింట్ అంటే ఇదే, ఈ పాయింట్ పైన మ్యాగ్నెటిక్ ఫీల్డ్ క్యాలిక్యులేట్ చేయాలి. ద రేడియస్ ఆఫ్ దిస్ లూప్ ఇస్ r and that's it. The conditions are given. అయిపోయింది కదా. రేడియస్ r, కరెంట్ I2 and that's it. కరెంట్ I is again going back. So NEET 2019 లో వచ్చిన క్వశ్చన్ ఇది. ఓకే, సేమ్ కరెంట్ I is going back again. చెప్పండి అందరూ. Zero, zero option ledura. Do we have option? Okay, we do have option. Right. We do have option zero. Okay. Good, Hasini, very good. Okay, I hope so. This answer is correct. Cheppandi andaru. So understand. Students, understand change, okay? If you want to talk about the sir, please, what? Ramya, what's the doubt, Ramya? Em cheyal? So what is the doubt, Ramya? Tell me the doubt. What is the doubt? Idi on the student. So if you want to solve this question, student. ఇదే కదా, యాంగిల్ 90 డిగ్రీ రా, నాట్ పాసిబుల్. సెంటర్ పాయింట్ అంటే ఇది. ఓకే, అజ్యూమ్ దిస్ టు బి సెంటర్ పాయింట్. ఇప్పుడు చూడండి ఎందుకు. సో దిస్ కరెంట్ I1 రా, I1 కదా, యాంగిల్ చాలా ఇంపార్టెంట్. ఆర్క్ ఆఫ్ ద సర్కిల్ కదా, ఈ యాంగిల్ θ is equals to 90 degrees. అలాగే దిస్ యాంగిల్ is 270 degrees. ఇదే కదా 270 లేదా 3π/2, ఇది π/2 యాంగిల్. ఇప్పుడు డ్యూ టు దిస్ మ్యాగ్నెటిక్ ఫీల్డ్, అందరూ డ్యూ టు దిస్ ఆర్క్ ఆఫ్ ద సర్కిల్ రా, మ్యాగ్నెటిక్ ఫీల్డ్ డైరెక్షన్ అవుట్ ఆఫ్ ద ప్లేన్ కదా. అలాగే డ్యూ టు దిస్ మ్యాగ్నెటిక్ ఫీల్డ్, డ్యూ టు రిమైనింగ్ ఆర్క్ ఆఫ్ ద సర్కిల్ రా, మ్యాగ్నెటిక్ ఫీల్డ్ ఇంటూ ద ప్లేన్. చూడండి, అయితే ద మ్యాగ్నెటిక్ ఫీల్డ్ B1 బార్, అలాగే మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు దిస్ కరెంట్ ఇస్ B2 బార్. నెట్ మ్యాగ్నెటిక్ ఫీల్డ్ కావాలంటే you will simply write sir B2 bar minus B1 bar. ఎందుకంటే డైరెక్షన్స్ ఆపోజిట్ ఉంటుందిరా. ఓకే, observe it once. So here if you are turning your fingers out of the plane, అలాగే ఇక్కడ టర్న్ చేసినప్పుడు into the plane కదా. yes, substitute చేయండి. B2 bar అంటే ఏంటి సార్, ఫార్ములా కదా, μ0 into I into theta divided by 4πr. theta 2 μ0 I theta 1 divided by 4πr. that's it. అదే కదా. సో మీరు μ0 I divided by 4πr ని కామన్ తీసుకోండి. ఏం మిగిలి ఉన్నాయి సార్, π/2 minus theta 2 minus theta 1. theta 2 అంటే 270 minus theta 1 అంటే 90 degrees వచ్చింది. that's it. ఇదే కదా. I1 I2 కూడా కామన్ రా. I1 I2 ఆల్సో డిఫరెంట్ కదా. yes. resistance or something is given. Okay, straight conductor splits into two parts as shown in the figure. The radius of the circular loop is r, the total magnetic field. Okay, good. And then Mani, this current is also distributing into two different parts kada. What do you want, sir? If you want the value of I1 value is equals to, cheppandi andaru, R2 divided by R1 plus R2 kada. R2 what, sir? R2 is divided over total length ante theta 2 divided by pi multiplied by I1. ఇదే కదా. yes, I1 అంటే theta 2 తీసుకోండి, అలాగే I2 is nothing but theta 1 divided by pi multiplied by I. that's it. okay, substitute చేయండి మరి values. okay, μ0 I2 theta 2 minus μ0 I1 theta. that's it. so μ0 multiplied by I2 కి వాల్యూ సబ్స్టిట్యూట్ చేయండి. theta 1 into I divided by pi కదా, divided by pi multiplied by theta 2 divided by 4πr minus, alage you also have to write the same thing for I1 also. so μ0 multiplied by theta 2 I divided by pi multiplied by theta 1 divided by 4πr. okay, yes. ఇప్పుడు చూడండి అందరూ. so this is the net magnetic field కదా. yes, ఏమొస్తాయి సార్, μ0 theta 1 theta 2 I, μ0 theta 1 theta 2 I. అరే సేమ్ రా బాబు. కాబట్టి మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ జీరో. V net వాల్యూ ఎంత వచ్చింది సార్, జీరో. ఇట్స్ అ వెరీ గుడ్ క్వశ్చన్. ట్రస్ట్ మీ రా, ట్రస్ట్ మీ. సార్ ఇఫ్ ఐ డూ PYQs, enough. okay, that will be more than sufficient. okay, yes, it is literally a very good question guys. very good question. trust me, ఇది JEE level question రా. okay, కాబట్టి give it a very star mark and somebody has said the answer zero in the beginning itself. okay, Andaru naku I just can't tell you the intensity of this question. It's a very good question. 5-star question. Kabatti jagrataga cheyandi once again. Okay. Yes. Next question. This one. 2016. A long wire carrying steady current is bent into circular loop of 1 turn. The magnetic field at the center of the loop is B. It is then bent into circular coil of n turns. The magnetic field at the center of coil n turns will be dash. Good question. I think a very good question. Okay. Yes. N turns unnappudu radius decreases now. Okay. Radius now will decrease if you have n turns. But sir, what will be the new radius? And that's it. Cheppandi guys, cheppandi. Magnitudes are not same. How do you know magnitudes are same? No, magnitudes are not same. So that will come to know only by looking at the calculations. Maamulugane ee question ni choose, you cannot infer that the magnitudes are same. Kabatti you cannot say that the result will be 0. Okay? Cheppandi. Yes. Andaru ee video ni like cheyandi. Let us aim for 200 likes. Okay? Sir, a long wire is bent into circular loop of 1 turn. Idi ondaru chudandi. Kabatti the total circumference kada? Yes. Question number 32. Question number 32. 32 ki answer enti sir? Question number 32 ki answer kavali. So if you have a single turn ante the total length of the wire is nothing but 2 pi r. Ade kada? But if you are turning into n loops lo turn chesinappudu the length now radius now decreases. Ide kada n turns. But sir, smaller radius r anukondi, so 2 pi into small r into n should be equals to the total length, either 2 pi into capital R. Ide kada, this length are same ra. Kabatti 2 pi gone, and the value of r is nothing but capital R divided by n. That's it. So mu naught magnetic field at the center kavali kada. What is the magnetic field at the center, sir? Mu naught I divided by 2 times of radius. Radius ante capital R by n. Ide. Either it is nothing but for a single coil, okay, for a single turn. Kani n turns unnappudu n tone multiply cheyandi. So this n comes up, it becomes n square multiplied by mu naught into I divided by 2 times of r. And the magnetic field due to the normal coil is nothing but mu naught I by 2r. Ide kada mu naught I divided by 2r. So what you have to do, you basically have to substitute this, and it comes out to be n square into b. Okay, n square times b. So that is the total magnetic field at the center. So magnetic field is nothing but n square multiplied by b naught. Is it there? Is it there in the options? Yes, it is there. Under n square b, the option B is the correct answer for that. Okay. Next part. A wire carrying current I has the shape as shown in the figure. No use of this question. Shape student, sorry. So question number 31 kada? Yes. The question is question number 31. Next. This is a wire array. It's also a very good question. Trust me. This is a beautiful question. I want everybody to focus and I want everybody to write the answer for this question. Okay? So, what is the shape? At least you can attempt it, right? Yes, so it's a 3-dimensional figure, x-axis, y-axis, z-axis. And when you're talking about the magnetic field at the center under chudandi, so it means pure killer visualization. If you have a visualization in this piece, it's a piece of cake for you guys. So if it's a wire, the magnetic field at this point will be directed downwards at the minus z-axis. Alage, ee wire ni kuda chusi, the magnetic field is actually directed downwards at the minus z-axis. Okay. So the magnetic field due to the 2 wires is actually directed in the downward direction. But sir, due to the remaining wire ki okasari direction chudandi. So if it's plus x that becomes minus x and minus k. So if this is your current, the magnetic field should go into the plane and it should be minus I minus k. minus I not there. Am I correct only? Yes. So let us make that shape. Question number, what is the question number, sir? Question number 33 kada? Yes, for 33rd question. If you are solving these type of questions, you don't need anything else, okay? These questions are more than sufficient. So this is going to be your x-axis, y-axis, z-axis. But it has changed the values. So the vertical axis is z, alage y, okay? Z and y. So this axis is z-axis, alage this axis is y-axis. And there is this loop in the same dimensions. Dimensions and take y-z axis. Student. Alage you have x-axis also. So x-axis kosam the loop is coming in this way. So this is the structure. It is structure. Sir, magnetic field and only right hand thumb rule, sir. Yes. It depends completely on the shape. So if you have a straight wire, you have to basically point the thumb across the direction of current and rotate the fingers. So the direction of the fingers will give you the direction of magnetic field. Okay. Sir, so now if you want to talk about the current under student, so this is the positive direction of x-axis. Yes. This plus x-axis, that goes your minus x-axis. Okay, negative x-axis. If this is plus z-axis, it becomes minus z-axis. Plus y-axis, and it becomes minus y-axis, which is the layer. Yes. So now, when you're talking about the current direction in the semicircular loop under student, for semicircular loop, radius do you have the value of radius? The radius value is r itself, right? So radius value is r. So the distance, this distance is r. Yes. So distance ochindi. Now I want you to focus here. This point paina focus cheyandi. Infinite unnappudu the magnetic field due to this infinite wire is given by the formula mu naught I divided by 4 pi d. But direction enti sir? Where is the direction? If it is coming out, it is coming out kada. So if it is coming out, the magnetic field will be given in the downward direction. Downward direction ante minus z direction. Alage here also this current is coming out. So what do you have to do? Going inside kada. So if it is going inside ante downward direction. Alage if it is coming outside, so bring it outside. Thumb. Alage the magnetic field is in the downward direction. Kabatti due to the both wires magnetic field is in the downward direction. So sir, mu naught I by 4 pi d plus mari okasari mu naught I by 4 pi d in the downward direction. Downward direction ante minus z direction. Ide kada minus z ante minus k raskondi babu. Okay, negative k. That's it. So mu naught I by 4 pi d plus mu naught I by 4 pi d ante 2 mu naught I. Okay, 2 mu naught I divided by 4 pi d in the minus k cap direction. Ochida leda. ఇప్పుడు magnetic field due to the ring కావాలి. So ఈ ring వల్ల the magnetic field will be directed into the plane of the paper. Into the plane of the paper అంటే minus x direction లో ఉంటాయి. అదే plus what is the magnetic field sir? Mu naught I divided by 2r. Not 2r, 4r, I'm sorry. 4r. ఇది కూడా it should be in the minus I direction. That's it. Okay, we కావాలంటే you can take out common also. So what can you take common sir? Mu naught I divided by 4r. Here also r kada? Yes. So mu naught I divided by 4r ni common తీసుకోండి. So you are left with 2 divided by pi in the minus k direction. అలాగే minus I cap. That's it. ఇదే కదా. So this is the magnetic field. Let the magnetic field B bar. Okay, magnetic field B bar. If it is there in the option, well and good. If it's not there in the option, oh then good. Okay, here you go. He has already taken minus sign kada? Yes. Here you go. He has already taken this minus sign. Kabatti option A is there. So option A kosame you have to take both minus signs common outside తీసుకోండి. So you will simply say what would you say? Mu naught I by అదే. So negative sign బయటికి తీసుకోండి. Mu naught I divided by 4r multiplied by 2 by pi plus 1 kada 2 by pi k cap plus I cap. That's it. ఇది on the student. So if you want to take pi also common, take pi also common. So negative of mu naught I divided by 4 pi r. మరి ఏం మిగిలి ఉన్నాయి sir? You are left with simply 2k plus pi I bar. That's it. So 2k plus pi I. 2k plus pi I kada 2k plus pi I. Done. Option A is the correct answer. Okay. Now. Next part students. Sir, common తీసుకోవచ్చు కదా sir? Yes, you can take common also. It's all up to you. Completely upon. Okay, sir. Let us move to the next topic ఇప్పుడు అందరూ. So let us now shift towards the next topic. Okay. Yes. So the name of the next topic for the discussion is magnetic field. Okay, yes, magnetic field. The next topic is going to be the magnetic field. Andaru, what do you mean by magnetic field? Student, characteristics లేదా properties of magnetic fields అయితే సరే, okay, not D రా, B option D is correct, not D అందరూ ఇదిగో my goal is for 200 likes, it is just to 131, 69 more కావాలిరా, okay, so let us see if you can reach 200 likes or not. Okay, అందరూ చూడండి. So magnetic field properties చెప్పండి చాలు రా ఈ క్లాస్ కోసం. Okay, we also have to finish this class and then start week quiz also. Okay, and the student, magnetic field properties always exist in closed loops. Your magnetic field always exists in the closed loops. Point number 1 అందరూ వచ్చిందా లేదా? Yes. Point number 2, start from north pole and at south pole. Okay, start from north pole, అలాగే the magnetic field and at a north south pole. ఇదే కదా, south. Same properties ra. Property number 3, they do not intersect. Do not intersect. అలాగే చెప్పండి fourth property sir, the direction of tangent కదా. Yes, the direction of tangent, not direction of tangent ra. Tangent gives the direction of magnetic field. Okay, tangent at a point gives the direction of magnetic field. ఇదే కదా, gives the direction of magnetic field. Okay, these are the conditions. ఈ conditions తర్వాత let us go towards the next law. Next law అంటే it is your Ampere circuit law. అందరూ ఇదే కదా. Yes, it is known as Ampere's circuit law. అందరూ గుర్తుపెట్టుకోండి, ఈ Ampere circuit law, it does not have a good significance except if you want to calculate the magnetic fields due to wire. Okay, cylindrical wires, hollow wires, solid wires, depending upon the condition. Okay, yes, Ampere circuit law talks about the formula. What is the formula sir? Closed integral, linear integral, okay, line integral of B bar dotted E bar. ఇదే కదా, it is nothing but mu naught multiplied by internal current లేదా inside current. ఇదే, so this is known as the Ampere circuit law. Application కావాలంటే wires తీసుకోండి. Okay, yes, so there is this current flowing in the wire. ఈ current I1 అనుకోండి, అలాగే this current is I2, here the current is I3, once again ఇక్కడ మీ current I4 అనుకోండి, and that's it, goes on and goes on, current I5, here the current is I6. ఇదే కదా, మరి ఏం చేయాలి సార్? ఈ పాయింట్ ఆఫ్ టైం లో ఒక లూప్ కన్సిడర్ చేయండి, లీనియర్ లూప్. ఓకే, సో దిస్ ఈస్ ద లీనియర్ లూప్. అదే, సో టోటల్ లెంత్ ఆఫ్ దిస్ లూప్ L అనుకోండి, దట్స్ ఇట్. సో సార్ ద టోటల్ మ్యాగ్నెటిక్ ఫీల్డ్ అలాంగ్ దిస్ లూప్ ఇస్ గివెన్ బై ద ఆంపియర్ సర్క్యూట్ లూప్ ఫార్ములా. కాబట్టి మీకు కావాలంటే టోటల్ ఇంటెగ్రల్ ఆఫ్ B బార్ డాట్ DL బార్. DL బార్ అంటే చిన్న చిన్న లెన్స్ రా, ఈ లూప్ పైన చిన్న లెన్స్. ఓకే, DL is equals to mu naught multiplied by internal current ra. Inside current ante loop ki internal point lo unte current. What is the internal current ante sir? I1, I4, I5. That's it. Even if there are 100 currents outside the loop, you don't have to take them. Endukante they are not affecting the magnitude of the magnetic field itself. Okay. Yes. So sir, B multiplied by total integral of DL ante L ochindi kada, is nothing but mu naught multiplied by internal current. What is internal current sir? So internal current going into the plane negative assume chesi, you can simply write I5 minus I1 minus I4. That's it. Okay. Yes. Magnetic field B is nothing but mu naught multiplied by I5 minus I4 minus I1 divided by L. So this is how you apply the Ampere circuit law. Okay. Application parts done. Next part ఏంటంటే force on the moving charge placed inside the magnetic field. Okay guys, ఈ వీడియోని లైక్ చేయండి. నెక్స్ట్ టాపిక్ ఏంటంటే force on a moving charge. ఇదే కదా, force on a moving charge placed inside the magnetic field bar. ఇది అందరూ చూడండి. సో మీకు ఫోర్స్ కావాలంటే if this is the magnetic field, kada, yes, into the plane, 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 into the plane. And I'm having a little doubt, okay? I'm having a little doubt. I don't know. Sir, okavela anti-clockwise unte left hand thumb rule. No. Okay, Gayatri. Left hand, right hand rules unnayina. But cross product vachindante, you don't have to talk about the left hand, right hand thumb rule. Okay. Yes, students, let us first finish the quiz. Okay. Let us first finish the quiz. Dan tarvata we will continue the next syllabus. Okay. Let us take a 15 minutes break. I just got some work. Okay, and then we will continue. Oka nimisham agandi. Okay. Yes. Okay, guys, you can start attempting the quiz, okay? Andar, attempt cheyochu. You can all start attempting the quiz itself. Okay, let me just see and let me just go for the quiz. Possibility. Idigo. So, you have the second link, the week quiz number 2. And that's it. Clear? Kada, Andar. So, you can start attempting the quiz. Okay. Start cheyandi andaru. Magnetic field around the straight wire is given by dash. I don't know if there is the leaderboard coming or not coming, but I want everybody to attend this quiz, okay? Andaru. You want me to answer? Sir, me kosame I am not going to write any answer, okay? Sir, continue. Next question, Andar. Leaderboard. Attempt cheyandi andaru. All of you, I want everybody to attempt this week quiz, okay? Right now itself. Description lo velli link click chesinappudu please attempt the week quiz, okay? I will be back in 10 to 15 minutes, guys, okay? I will be back in 15 minutes. Till then, attempt the week quiz, guys. Yes. Class resumes at 9 p.m. okay? 9 p.m. will be the class resuming time. Okay, till then I want everybody to attempt week quiz, okay? Sir. Yes, guys, clear? I hope it's clear now, and I hope you also have attempted the questions also. Sir, ఇప్పుడు start చేద్దాం. Sir, class duration till 10 PM రా, 1 more hour, okay? Sir, done kada? Yes, done. So, force on a moving charge in the magnetic field. ఇది వంద చూడండి. So, this is your uniform magnetic field B bar going into the plane of the paper. Okay, ఈ magnetic field లో ఒక charge పెట్టండి అందరూ. So if you are keeping this charge, nothing is going to happen కదా. కానీ ఒకసారి ఈ charge ని speed ఇవ్వకపోతే this charge Q, speed V, magnetic field B. If you are giving this speed అంటే it will just perform the circular motion. Okay, no suspense ra, direct answer. Okay, yes. So it is performing the circular motion. My sir, what is going to be the radius? What is going to be the time? What is going to be the frequency? What is going to be the angular speed? Megita things. Okay, sir. Student. So, I think I should have explained these things before. Okay, we are going too far. We are going too far. Yes. So ఈ charge దగ్గర speed ఉన్నప్పుడు అర్థం చేసుకోండి. This charge will experience a force కదా. So F bar is nothing but Q times of V bar cross V bar అందరూ. So this is the force experienced by this charge. కానీ this force is actually making this charge go into a circular motion. Okay, and this is the circular motion అందరూ. చూడండి ఇదే కదా. F is equals to Q into V bar cross V bar. లేదా value రావాలంటే value also you can write it Q into V into B into sin theta. వచ్చిందా లేదా అందరూ? Yes, so this is the value of the magnetic force. Okay, this is the magnetic force అందరూ. Now ఈ కేసులో చూసినప్పుడు your velocity is directed towards the right side. అలాగే magnetic field is into the plane of the paper. కాబట్టి ఈ రెండిటికి మధ్యలో angle 90 degree ఉంటుంది కదా. Yes, therefore sin theta is nothing but sin 90 and the value of sin 90 becomes 1. కాబట్టి your magnetic force F is nothing but Q multiplied by V into B. V అంటే velocity. Okay, don't get confused. కొన్ని students they misunderstand this velocity as potential. Okay, ఇది potential కాదు. ఒక్క నిమిషం ఇవ్వండి అందరూ. हेलो, हाँ, क्यों लगा? Yes, QVB kada. This force last moment there are lots and lots of distractions that are coming. Okay, sorry. So this is your magnetic force. Ochida leda andaru. Ippudu if you want to compare it, circular motion kada. Circular motion unnappudu there should be centripetal force. This force is nothing but your centripetal force. What should be the value of centripetal force, sir? Mass m unnappudu radius r ra. Mass m radius r unnappudu the centripetal force is nothing but mv square by r. Mari equate cheyandi. That's it. So you have to equate it with the centripetal force. F centripetal ante mv square divided by r. That's it. So these are the two formulas, both are same. కాబట్టి Q multiplied by V into V is nothing but m into V square divided by r. వచ్చిందా లేదా? Yes. So velocity gone. మీకు ఏం కావాలి? రేడియస్ కావాలి కదా. సో సార్ Q into V is nothing but mv by r. అలాగే ఇక్కడ నుంచి radius value is nothing but m into V divided by Q into V. That's it. So this is the radius of the moving charge in the external magnetic field. అందరూ ఇప్పుడు ఒకసారి మీ దగ్గర రేడియస్ వచ్చిందంటే you can definitely talk about another aspects also. Okay, yes, రేడియస్ వచ్చింది కదా. Now we have to find the time period of rotation. అందరూ time period కావాలంటే total distance by total speed కదా. Yes, so this is the rotational motion performed by the charge. చూడండి, so this is your circular motion. అలాగే magnetic field కూడా into the plane ఉంటుంది. So this is the magnetic field. అర్థమైంది అందరికీ? Yes, this is your magnetic field. వచ్చిందా లేదా? I hope you understood this. Okay, so magnetic field V అనుకోండి. అలాగే your charge మీ charge is somewhere here. ఇదే మీ charge అందరూ. Yes, ఈ charge దగ్గర speed V ఉన్నాయి. ఇదే కదా, and the radius of the circular path is r. So sir time కావాలంటే time కోసమే total distance distance divided by speed. Distance enta sir? Distance is nothing but 2 pi into radius of that circle divided by speed. V అనుకోండి. So time period is nothing but 2 pi multiplied by radius ki formula expression ఇప్పుడే వచ్చింది కదా, radius is nothing but mv divided by q into b. Substitute చేయండి అందరూ, divided by speed v వస్తుంది, v gone. కాబట్టి your time period of rotation is nothing but 2 pi m divided by q into b. That's it. So this is nothing but your time period of rotation of this charged particle in the magnetic field. Okay, ఇప్పటిదాకా we have seen about the radius of the circular path, అలాగే time period of rotation. Now I want to talk about the frequency. చెప్పండి రా బాబు, what is the formula for frequency? For frequency కోసమే you are having the formula of frequency is nothing but 1 upon time period. So sir, frequency is nothing but 1 upon time period ఏంట్రా, 2 pi m divided by q into b. వచ్చిందా లేదా? Yes, inverted వచ్చింది. So frequency of rotation is nothing but q into b divided by 2 pi m. Hertz, ఇది units hertz. అయితే ఒక సెకండ్ లో how many rotations it is making? It is completely dependent on the charge, dependent on the magnetic field, dependent upon the mass of the charge. That's it. Done? I hope it is understandable. ఇప్పుడు మీకు కావాలంటే angular speed కూడా calculate చేయొచ్చు. We can also talk about the angular momentum, we can talk about the kinetic energy of this charge also రా, ఇదే కదా. yes, ఇప్పుడు చెప్పండి అందరూ, ఫ్రీక్వెన్సీ వచ్చినప్పుడు ఈ ఒమేగా వాల్యూ కావాలి, కానీ ఒమేగా ఇస్ నథింగ్ బట్ v upon r. v వాల్యూ ఇప్పుడే వచ్చింది కదా, వాట్ ఇస్ ద వాల్యూ ఆఫ్ v sir? yes, so v upon r kada, r v divided by radius value ఏంటి sir? r is equals to mv divided by qb. ఇదే the letters are disappearing now. yes guys mv by qb అంటే vv gone, కాబట్టి your angular speed omega is nothing but q into v divided by m. That's it. So this is the angular speed omega. మీకు కావాలంటే definitely you can talk about the kinetic energy, half I omega squared కదా, I అంటే moment of inertia, m r squared multiplied by omega squared, and this is squared. And that's it. You can also talk about the kinetic energy of rotation also. Okay, kinetic energy కావాలంటే మీరు డెఫినెట్ గా kinetic energy is nothing but half I omega squared లేదా half m v squared కూడా రావచ్చు. It's all up to you. Okay, both are coming to be the same only. Next అందరూ next కదా, let us see if there is some PYQs or not. Guys, I need at least 200 likes, huh? So I want everybody to like this video. Okay, there are somewhere around 52 students watching. A point of time, I don't know if it comes to you, how many students will be left? Sir, do we have some question based on that? Torque on the loop, yes, we did not cover that part now. Do we have moving coil galvanometer? We did not cover that also. Sir, I point that. That means we'll have to take the questions from the upper part itself. Okay. Chuddam. 115? Yes. I think the question will be somewhere here itself. చెప్పండి ఎందుకు? Ampere's law. Done. Next question. Yes, next question is this. Solenoid and toroid. Magnetic field at the center cavity. Force between 2 pi. Okay. Did we discuss some more concepts? We did not discuss some more concepts. Force on a moving charge. It's there, it's not there. Okay. Sir. Okay, force between two parallel currents. Okay. Next part, Andar. We want to talk about solenoid kada, because there are no PYQs now. Actually, there is a PYQ. NEET 2025 lo ochina question idi. There is a question that was asked in NEET 2025. Okay, oka nimsham ivandi. Okay, so let us discuss that question first. Okay. Yes, తీసుకోండి అందరూ. An electron, okay, an electron mass తెలుసు కదా మీకు, mass అంటే m is equals to 9 into 10 to the power minus 31 kgs. Okay, it's a NEET 2025 question. Charge కూడా తెలుసు మీకు కదా, moving with the speed of c by 100. Moving with the speed of c by 100. Moving with the speed of c by 100. ఎందుకంటే ఈ పేపర్స్ లో 2025 క్వశ్చన్స్ లేదు. ఓకే, is injected into the magnetic field B bar. Okay, is injected into the magnetic field B bar is equals to 9 into 10 to the power minus 4 Tesla. 9 into 10 to the power minus 4 Tesla. Yes. Perpendicular to direction of motion. Perpendicular to direction of motion. Perpendicular to the direction of motion. Okay, direction of motion. Full stop. We wish to apply a uniform electric field E bar. Full stop. We wish to apply a uniform electric field. Okay, apply a uniform electric field E bar together with the magnetic field so that electron does not deflect. So that electron does not deflect. So that the electron does not deflect. Mari E bar ki value kavali. That's it. Okay, E bar kavali. Then what? Then options are there. Either needed 2025 last year paper. This one. Option A above. Option A. E bar value should be equals to 27 10 to the power 4. Okay, 4. Yes, 4 only. Parallel to B bar. Okay. Alage E bar is parallel to B bar. Option B. Teeskondi. Option B and E bar perpendicular to B bar 27 10 to the power 2. E bar perpendicular to B bar. Option C teeskondi. Option C is 27 10 to the power 4 parallel 27 10 to the power 2. That's it. So E is equals to 27 10 to the power 4. E bar should be perpendicular to B bar. Alage option D. Remaining options kada E is equals to 27 10 to the power 2. Alage E bar is parallel to B bar. That's it. This one. It is a standard question from velocity selector. Sir, AC, EM waves, wave optics, next session. Yes, next session only. Yes, next session. Absolutely. How would I cover the entire chapters now? You see, if you want to learn physics in a proper way, it is going to take the time. Definitely. Yes, Gayatri, next sessions only. Visualize change. So this is the motion of electron. There is this magnetic field applied perpendicular to the path of the electron. So this is your magnetic field. Yes. Let us say this is the magnetic field. Perpendicular. Yes. Speed we are going. So sir, magnetic force acts. What is the direction of magnetic force, sir? Q into V bar cross V bar. V bar cross V bar is in the upward direction. Kani. This force is for the positive charge. Electron negative charge untundi. Kabatti the force will be downward. So there is a downward force acting. So magnetic force is nothing but EVB. So if force ni balance cheyadaniki we needed to apply the electric field also. Mari em direction lo apply cheyali sir? We need the upward force kada. Upward force ante upward field undali. F is equals to QE kada. And if the force we need is in the upward direction, field should also be in the upward direction. No. Electron negative charge. So in negative charge paina upward force kavalante field should be downward direction. So your electric field should be in the downward direction. Kuchinda leda. ఇప్పుడు చూడండి ఎలక్ట్రిక్ ఫీల్డ్ కిందకి ఉంటుంది magnetic field is into the plane of the paper అయితే they are perpendicular parallel options gone wrong point number 1 to be noted మరి sir no deflection kada if you don't want any deflection both the forces should be same what is the force sir q into e is nothing but qvb that's it so q gone e value should be equals to v into b that's it so v and a speed of light enta sir c by 100 multiplied by magnetic field enta 9 into 10 to the power minus 4 C and enta 3 into 10 to the power 8 divided by 100 multiplied by 9 into 10 to the power minus 4. This is mass of electron, charge of electron. It is just given to confuse you. Okay, 100 gone. 6 minus 4 at 2. So 27 into 10 to the power 2. And it is perpendicular. And the option B is the correct option. Okay, good. Very good. Okay, guys, very good. Correct, not 4 ra, 2, it should be 2, right? Because 100 is there in division. So 6 minus 4 ante 2 vastundi. That's it. Okay. Next part, and let us talk about solenoid. Okay. Next topic ఏంటంటే solenoid. Solenoid లో magnetic field formula గుర్తుపెట్టుకోండి ఇంకా చాలు. You don't need anything else. So what is the solenoid, sir? Solenoid అంటే ఒక hollow cylinder తీసుకోండి అందరూ. So you consider a hollow cylinder. ఇదే కదా. అలాగే ఒక వైర్ తీసినప్పుడు you basically turn the wire around this cylinder. Okay, this is your cylinder. Clear up? I hope it's clear, right? So this is known as your solenoid. Andaru ippudu chudandi directions kavali kada. So if you want to take the directions, you take the directions in this way. So it is going up, coming down, again going up, malli paina, upwards, 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 and then it is coming downwards. Vachinda leda andaru ippudu chudandi magnetic field kavalante mee 4 fingers ni rotate cheyandi in the direction of current. So if you are rotating it ante magnetic field is coming in the reverse direction. Clear ah leda? Yes. So that means your magnetic field is coming in the reverse direction. This is the magnetic field. Always forms the closed loops kada. Yes. So it is always forming the closed loops andaru. Okay. So the magnetic field looks something like this. Visualize cheyandi. Okay, ఇది చాలా important discussion. అరే ఏంట్రా ఇది? Yes. Alage, here also you have to do almost similar stuff. Okay. Yes. Ide kada. So this is your solenoid, okay, and the field lines are actually getting curved up, okay, and they closed fields ra idi mottam. Okay, so these are the magnetic field lines to the solenoid. But sir, what is the value of the magnetic field? There are some terminologies that you need to understand for understanding the magnetic field. Okay, chudandi. First terminology ante total number of turns. Okay, capital N anukoni. What is this capital N ra? This represents the total number of turns. Okay, yes. Alage, there is something known as the length of the solenoid ra. Ikkada nunchi ikkada daaka total length L anukondi. That's it, sir. Therefore, number of turns per unit length, okay, small n oka terminology untundi. It is nothing but capital N divided by L. Ante number of turns per unit length, okay, number of turns per unit length. That's it. Therefore, the magnetic field at the center of the solenoid, లేదా inside the solenoid, okay, magnetic field inside the solenoid, okay, inside the solenoid is equals to mu naught multiplied by n into I. అర్థమైంది అందరికీ? This is the magnetic field inside the solenoid. Done? Not done. Done only. Okay. Next topic ra. What is the next topic? Andaru ee video ni like cheyandi okasari. Okay. Yes. Now let us talk about the force on a current carrying conductor. Andaru, okay? Yes. Force on a current carrying conductor. Force on a current carrying conductor. Okay. In a magnetic field, obviously, okay. So this is your magnetic field. అర్థం చేసుకోండి అందరూ. ఇదే కదా. ఈ magnetic field లో ఒక వైర్ పెట్టండి and ఈ వైర్ లోంచి there is this current that is flowing I కదా I. ఇప్పుడు if just you have this wire అంటే length of the wire కావాలి. Length of the wire ఇది అందరూ. సో ఈ length L అనుకోండి. L bar direction కావాలి కదా. Yes. So sir, if you have current length and magnetic field, automatically it will experience a force, sir. Force is given by the formula for the force in the I into in bracket L bar cross B bar. ఇదే కదా. ఇప్పుడు చూడండి ఒకసారి L bar ఇక్కడ పైనకి ఉంటుంది, B bar ఇక్కడ into the plane. So L bar cross B bar is towards the left side. కాబట్టి ఈ వైర్ పైన కూడా ఒక ఫోర్స్ లెఫ్ట్ సైడ్ లో ఉంటుంది. సో I into L bar cross B bar. ఇదే కదా. Yes. కానీ we can also transform this formula in this way. So Fn is equals to I into in bracket not in ILB sin theta. ఇదే కదా. This is the formula. Okay, if your length vector లేదా current direction is perpendicular to magnetic field direction, ఆ point of time లో ILB కూడా రావచ్చు. Okay, it's all up to you. ఇప్పుడు చూడండి L అంటే ఏంట్రా బాబు? ఈ ఫార్ములాలో L అంటే it is not the length, okay? It is the shortest distance between initial and final points. Shortest distance కదా? Yes, shortest distance between the initial and the final points of the conductor. Initial and the final points of the conductor. This is very important, okay? Of the conductor. Either if you talk conductor, okay? Yes. So example and you can take this as the example. So if this is the magnetic field, yes. In magnetic field you have a hexagon rock and it is not completely shut. This is the hexagon. Yes. ప్రతి ఒక్క లెంత్ L అనుకోండి. ఇదే కదా. Yes. So direction of the current is like this. Okay. Yes. అయితే ఏం కావాలి మీకు? You need the total value of the current కదా. Sorry, force. So sir, ఇక్కడ కూడా what are you going to write the force? F bar is nothing but I into in bracket L bar cross B bar. వచ్చిందా లేదా? Yes. What is the L length sir? L phi L not phi L only. ఎందుకంటే shortest distance రా. ఇది shortest initial distance, final distance కదా. Yes. So your L value should be in the opposite direction. This is the value of L. That's it. అర్థమైంది లేదా? Triangle law of vector addition రా. Okay. Try to understand. If you are adding these 2 lengths, 3 lengths, 4 lengths, 5 lengths, the length vector shows vertically upward direction. And that's it. So sir, force is nothing but I into L into B. Kani idi kuda force is in the left side kabatti minus I cap vastundi. That's it. Okay. Next part. If you want to talk about force in the loop, force on the loop, okay? Force on the loop and it is always 0, okay? Endukante length vector is 0 ra. Force on the loop, it is always 0. Endukante if this is your magnetic field, andaru chudandi, okay? Length ante ee formula lo I L bar cross B bar ante length between the initial and final points. Kani loop kosame initial point final point ade kada, length is 0 kabatti force kuda 0 vastundi. Okay, whatever loop it is, circular loop, triangular loop, square loop, rectangular loop, pentagon, hexagon, whatever loop you have, ee loop kosame force is 0. Okay, good petkodi, mark my words. So whenever you are talking about the force on the loop, force is going to be 0. Okay. Done. And then we have the last topic, torque. Okay, magnetic dipole. Under. Yes. Magnetic moment kada. Yes. M bar. So this is the magnetic moment. And just to visualize this situation, okay? So you have a bar magnet. This bar magnet ki north and south poles are like here. So in the north pole, this is the south pole. The magnetic field lines are actually starting from the north pole and going towards the south pole. These are the directions of your magnetic field lines. Yes. Starting from north, ending at the south pole. Alage, if you consider a loop, okay, loop తీసుకోండి, and in this loop I want you to flow some current. So this is the current that is moving through the loop. The magnetic field lines again move from the right side and end at the left side. Something like this. Okay. So these situations are same. So if you see the magnetic field lines due to the bar magnet and magnetic field lines due to a loop, same lines kada. Yes. Okay. No, nothing is there. Okay, nothing is there. We cannot move the camera. If the camera moves, everything will be gone. Chudandi. Next part ra. So magnetic moment లేదా magnetic dipole కూడా అంటారు. Okay. అందరూ చూసుకోండి. So for this magnet ra, the strength of the magnet కదా. So ఈ strength చెప్పడానికి we use some terminology magnetic moment m bar. Just like your dipole moment in electrostatics అందరూ. Okay. మీ electrostatics లో dipole moment లాగా ఇక్కడ we talk about magnetic moment. M bar is nothing but m multiplied by 2d. 2d అంటే distance between the poles. Okay. South to north pole distance అంటే 2d. ఈ ఫార్ములాలో m bar అంటే it is known as a magnetic moment. Okay. ఇది చాలా important. అందరూ magnetic moment. What is a small m ra? Small m is nothing but your pole strength. Pole strength. వచ్చిందా లేదా? Yes. The strength of the magnet. So magnetic moments ఎక్కువ ఉంటుందంటే your magnet is strong. అలాగే ఈ లూప్ కోసమే కూడా we define the similar terminology m bar sir. M bar is nothing but I times of A bar. That's it. Done. I అంటే current in the loop, అలాగే A అంటే area of the loop. So I into A gives the magnetic moment. అదే. Done? Not done. Right. So if you have the magnetic moment అంటే ఈ magnetic moment కి చాలా applications ఉన్నాయి. Application number 1 Application number 1 torque. Okay, torque. అలాగే application number 2 energy for the magnetic moment. Okay, లేదా energy of the magnetic dipole. Done? Not done. ఏంట్రా ఇది? Yes. చెప్పండి అందరూ. సో టార్క్ కోసమే యూ నీడ్ టు హ్యావ్ సమ్ అనదర్ డిస్కషన్. చెప్పండి. సో ఇఫ్ దిస్ ఈజ్ యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ కదా, ఇదే మీ మ్యాగ్నెటిక్ ఫీల్డ్ బీ బార్ అనుకోండి. ఇఫ్ దిస్ ఈజ్ యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ అందరూ, ఈ మ్యాగ్నెటిక్ ఫీల్డ్ లో యూ హ్యావ్ అ లూప్. ఓకే, లూప్. దిస్ ఈజ్ ద లూప్ కదా. చెప్పండి. నౌ ఇఫ్ యూ రొటేట్ దిస్ లూప్ బై అ స్లైట్ యాంగిల్ రా, స్లైట్ యాంగిల్ తోనే రొటేట్ చేసినప్పుడు వాట్ ఈస్ హ్యాపెనింగ్ సార్? It is actually providing a restoring torque. Yes. Do something like this, and then it should come something like this. If you are slightly rotating it, then you are experiencing a torque. So, sir, torque is nothing but m bar cross b bar. M bar ante dipole, magnetic dipole moment. Alage b bar is the magnetic field. Okay, b bar anukoli. This is the magnetic field. And m into b into sin theta. Vachinda leda. Yes. So this is the value of torque. Alage when you talk about the energy of the loop in the magnetic field, this is the magnetic field B bar anukondi. Okay, this is the magnetic field. So if you want to talk about the energy, right, no need to draw the diagram also. Cheppandi. So energy of the dipole kada. Yes, so potential energy formula idi. And the potential energy is nothing but m bar dot b bar. Ardham chesukondi. Magnitude kavali kada, m bar dot b bar. Sare. So if you need the work done to rotate the loop from angle theta 1 to theta 2, from angle theta 1 to angle theta 2. That's it. So work done is nothing but the change in the energy, data change in the potential energy. Aithe mb cos of theta 2 minus mb cos of theta 1. That's it. So mb బయటికి తీసుకోండి, you are left with cos of theta 2 minus cos of theta 1. PYQs ఉంటే we will discuss the PYQs and then we will wind up the session. Okay, yes. Torque on the loop కదా, తీసుకోండి. So 2-3 questions and then we will be done. సరే. A rectangular coil of length 0.12 meter with 0.1 meter having 50 turns of wire is suspended vertically in a uniform magnetic field of length 0.2. Okay. Yes. The coil carries a current of 2 ampere. The plane of the coil is inclined at an angle of 30 degree with the direction of field. The torque required to keep the coil in the stable equilibrium is dash. 2015 lo ochina question idi. Okay. Try it. Okay. Try cheyandi. If you get the answer, let me know it. Everybody, ఈ వీడియోని ఒకసారి లైక్ చేయండి. Second year not completed ra. He did not even complete electrodynamics. How is it possible to complete the second year syllabus? So let us see. చూద్దాం. Rectangular coil length కదా, ఏరియా క్యాలిక్యులేట్ చేయండి రా. ఏరియా క్యాలిక్యులేట్ చేస్తే చాలు. ఓకే, వాట్ ఈస్ ద ఏరియా సార్? 0.12 into 0.1 అంటే 0.1012 ఇదే కదా ఏరియా. ఓకే, ఏరియా. We don't want that రా, we just want the torque కదా. చెప్పండి క్వశ్చన్ నెంబర్ ఎంత సార్ ఇది? దిస్ ఈజ్ క్వశ్చన్ నెంబర్ 60 కదా. yes, క్వశ్చన్ నెంబర్ 60 అందరు. సో ఫర్ క్వశ్చన్ నెంబర్ 60 చెప్పండి, your situation looks something like this. So this is the rectangular loop కదా. ఎన్ని టర్న్స్ ఉన్నప్పుడు ఎన్ని టర్న్స్ తీసుకోండి, that's it. So these are your end turns. లెంత్ ఎంత సార్? your length is around 0.12 meters. width అంటే 0.1 meters ఇదే కదా. మ్యాగ్నెటిక్ ఫీల్డ్ వాల్యూ ఎంత? 0.2 Weber per meter square. లేదా టెస్లా మామూలుగానే టెస్లా. magnetic field is perpendicular to the plane kada. Yes, uniform magnetic field of strength, the coil carries the current, of the plane of the coil is inclined. Sir, so initially what we do is we basically, the plane of the coil is inclined at the angle of 30 degree. Ante initial angle theta cheppandi. Theta is equals to enta? What is the value of theta? Your theta value is nothing but 30 degree. Kani plane of the coil. Okay, it is the plane of the coil. Area vector different, plane different. Okay, theta value 30 degree ఇచ్చినప్పుడు that is the value of the plane of the angle. Okay, plane of the coil with the magnetic field. కానీ ఇది angle between area vector and magnetic field కాదు. angle కోసమే you need to calculate the exact value. ఇదిగో. so this ఎలా చెప్పాలరా మీకు? I don't have anything to explain. What do we have? Do we have something to explain? We don't have anything to explain. That's the biggest tragedy. So please adjust here. Okay, so this is the rectangular loop and this is the area vector. Okay, the student. Alage, if you understand, if you assume that your magnetic field is towards the right side, ide mee magnetic field kada, this is your magnetic field. Kabatti the plane is making an angle of 30 degrees. Okay, the plane itself is making an angle of 30 degrees. Ante you need to calculate the angle between the area. What is the angle between the areas, sir? Yes, Chapani. I don't know how to explain this to you. So this is the plane. Alage, magnetic field is something like this. Okay, this is the magnetic field. This angle is 30 degrees. Kani, it is not the area vector. Okay, area vector kavali meeku kada. So area vector will be perpendicular to the surface of the plane. So this is your area vector A bar. That's it. అయితే ఏరియా వెక్టర్ మ్యాగ్నెటిక్ ఫీల్డ్ చూడండి పర్పెండిక్యులర్ కదా. టోటల్ యాంగిల్ 90 డిగ్రీ ఉండాలి. 90 నుంచి 30 ఆల్రెడీ వచ్చింది. మరి థీటా వాల్యూ 60 డిగ్రీస్. that's it. అదే ఏం కావాలి మీకు? టార్క్ కావాలి కదా. థీటా వాల్యూ వచ్చింది మీ దగ్గర. యాక్చువల్ గానే the theta value is equals to 60 degrees. That's it. Now you want to calculate the torque kadara. So torque tau is equals to m bar cross b bar ante mb sin theta. What is the formula for m, sir? Oka loop, single loop kosame I into a. Kani n loops unnappudu your nia is the magnitude of the torque multiplied by b into sin of theta. That's it. Substitute the complete values, solve it, finish the question itself. n ante entara, how many loops are there? 50 turns. N is equals to 50. Substitute change. So 50 multiplied by current. Current enta, sir? What is the current flowing through the loop? Current is almost what is the current? 2 ampere. Okay, 2 ampere. Current is 2 amperes. Multiplied by area 0.12 into 0.1 ante 0.012. Chida leda. Students, ఒకసారి ఈ వీడియోని లైక్ చేయండి. ఓకే, ప్లీజ్ లైక్ దిస్ వీడియో గైస్, ప్లీజ్ లైక్ దిస్ వీడియో. ఓకే, yes, Done? Area వచ్చిందా? అలాగే you need to have the value of magnetic field. What is the value of magnetic field, sir? What is the value of magnetic field? 0.2. Substitute చేయండి. 0.2 multiplied by sin theta అంటే sin 60 √3/2. That's it. Substitute చేసి calculate చేయండి. So 2 into 0.12 into 0.2. ఇదిగో 0.12 into 0.2 అంటే 50 multiplied by 2 gone కదా. Yes, 50 multiplied by 0.1 to 0.2 అంటే 0.0024 multiplied by √3 తీసుకోండి. And it is somewhere around 50 multiplied by 1.73 into 0.002. Approximate values కావాలంటే తీసుకోవచ్చు. So 5 multiplied by 0.024. ఇదే కదా. So 5 multiplied by 0.024 అంటే 0.120 multiplied by 1.73. That's it. Okay. Approximate గా calculate చేయొచ్చు. So that becomes the torque. Okay. Calculated by yourself. Andar. Done? Not done. Right. Right. Next question. Andar. Just of the PYQs. Okay. Chapter completed. Chapter అయిపోయింది బాబు. Okay. So that was 2015 question. Time consuming. Chala time consuming problems. This మొత్తం problems అంటే. Okay. So a current loop in the magnetic field can be in equilibrium in two orientations. Both the equilibrium states are unstable. Okay. Alage can be equilibrium in two variations. One stable, one unstable. Experiences a torque whether the field is uniform or non-uniform in all orientations. Can be in equilibrium in one orientation. Okay, చెప్పండి. అయితే I am not able to explain you this రా. ఇదిగో. So ఈ loop ఇదిగో you understand this as a loop. Okay, area కదా, whatever area is there you assume it to be a loop. అందరు చూడండి. So when this loop is actually suspended రా, it is only in the equilibrium when the magnetic field is perpendicular to the plane of this loop. అదే only ఒక సింగిల్ కండిషన్, then and only then the torque becomes 0. చిన్న కూడా డిస్టర్బెన్స్ వచ్చినప్పుడు the torque is there and it keeps on moving. Okay, single point of equilibrium is there. That's it. Okay, not two orientations, not possible at all. Okay, I don't know what is it saying. Orientations ante if it is telling me in this way or that way. Idigo. So first orientation is this. Alage second orientation is this. Okay, these are the two orientations. In both of the orientations it can stay in the equilibrium. Okay, but I don't know what is the context of it. Okay, sir please can you respond for messages? Luna Zora, what's your name ra? What are the names, students? A circular coil ABCD carrying a current I is placed in a uniform magnetic field. If the magnetic force on the segment AB is F bar, the force on the remaining segment BCDA is dash. Very good question. Cheppandi. A circular loop ABCD kada, ABCD carrying current I placed in uniform magnetic field. If the magnetic force on the segment AB by the magnetic force is F. Okay, on this segment the magnetic force is F. Andaru chala jagrataga vinandi. So it is talking about the force on the loop. What is the force on the loop? 0. Anduvante length vector is 0 kada. Displacement vector initial final point same kabatti force on the loop 0 itself. Chudandi. So if there is this force ra F unnappudu migita on the remaining coil also the force is minus F. That's it. Then and only then it will balance. Okay, cheppandi. Then the force on the remaining segment BCDA. That's it. Force kavali kada cheppandi. So force on the remaining coil is minus F. Finished. Then and only then it can be in the equilibrium position. Vachinda leda. 2013 question kada idi. Yes. Hey, what is happening now? Huh? Yes. Guys, please like the video. 139 likes, huh? I'm not ending the session until we get 150 likes. Okay, 150 likes and minimum compulsory. Okay, are not C ra? How C are you talking about it ra? Idigo andaru. So if you look at the parts, e force paina it is telling you L bar calculate cheyandi. L bar kavali kada. So L bar is this. Let us say magnetic field is in this direction. Okay, let us say the magnetic field is in this direction. Kabatti L bar cross B bar ante the force experienced is in this direction F. ఇదే కదా. అలాగే ఫోర్స్ ఎక్స్పీరియన్స్డ్ ఇస్ F in this direction. Force experienced is F in this direction. Force experienced is F in this direction. కానీ వెక్టర్స్ కదా, సో F gets cancelled. ఇదే కదా. మరి ఒక టైం మిగతా ఫోర్స్ ఉంది, and that force is simply F opposite to the direction of the original force. అర్థమైందా లేదా? ఓకే. Sir, voice is low. I cannot shout ra. 8 hours, almost 8 hours నుంచి క్లాస్ తీసుకున్నాను. You are telling me to shout. How can I shout? చెప్పు. Yes, guys, 150 ra, 150 cheyandi, 150. Okay. Okay, so there is this question in 2025. Andu. Okay. So let us attempt that 2025 question also. Do we have something? Sir. So let us attempt one question from NEET 2025. Okay. Let us see how many of you can attempt this question. Okay, last time I have attempted it on YouTube itself. I don't know where did I attempt it. Sir, question తీసుకోండి. A model for quantized motion of an electron. Okay, NEET 2025 question ఇది. A model for the quantized model of an electron. Right? Quantized motion, okay? A model for the quantized motion of an electron. Yes, the model for the quantized motion of electron. Electron in uniform magnetic field B. In a uniform magnetic field B. Okay, states that flux passing through the orbit. States that flux passing through the orbit. Okay, flux passing through the orbit. Orbit of the electron is N. Orbit is N is L multiplied by H divided by E. This is the flux. Yes. According to the magnetic moment kavali in the lowest state. Then magnetic moment is what? Magnetic moment. Okay, magnetic moment in the lowest energy state. In the lowest energy state is dash. NEET 2025. Option A. HE by 2 pi m. HE by 2 pi m. Option B. HEB by 2 pi m. Heba by 2 pi m. Alage option C andu cheppandi. What is option C? HE by pi m. Option D, HEB by pi m. I hope so. Yes, HEB divided by pi m. Okay. No, not tomorrow. The next session will be day after tomorrow. 23rd ko kuda. My legs are gone. Okay. Yes, Sindhu cheppu. What is the doubt? Andar. Hey, 143 likes. Change this number. Increase cheyandi. Okay. Change this number. I want everybody to change the number. 144 cheyandi. What are you saying, sir? Bluffing or what? Yes, guys. Getting it, not getting it. Andar. Yes. Okay. Sir, let us see. Okay, chalo. Here you go, Babu. What do you want? magnetic moment kada. Magnetic moment ante simple gaane you don't have to get confused now. Simple formulas, okay. Edina formulas unte raskodi, that's sufficient. Magnetic moment m bar kada. M is equals to I to A. But area kavalante area of the circle kada. Pi r square. Ade substitute cheyu. Okay. What is saying ra? Flux passing through the orbit is this. Aithe flux ante telusa meeku, if this is the orbit. This orbit nunchi there is this magnetic field ra. Magnetic field B multiplied by area A is value NH by 2 pi. Ante B into A, magnetic field into area, NH by 2 pi. NH by E kada, yes. Ante area of the loop is nothing but NH divided by E. Ochinda leda? Yes. Mari em kavali meeku? Current kavali. Current kada. What is the value of current ra? dq by dt. Yes. Ade. Okay. Yes. Current kavali ra. What is current ra? So your current value is nothing but total charge divided by time. Ide kada. But if you have a single charge ra, a single charge unnappudu it is moving in a circular motion. So sir, this total charge divided by the total time of motion. Total time of motion kavali. Ide kada. So total charge is E ra. Kani total time kavalante you basically have to write the total distance by speed. Total distance by speed kada. Yes. So 2 pi r divided by speed. Now radius is the confusing point kada. So if there is this magnetic field moving ra and electron is moving ante, you can talk about radius of the circular orbit, right? mv by qb. That's it. So sir, current is equals to charge divided by 2 pi r ki place lo mv divided by qb. Q ante a into b raskondi. Ade divided by velocity. So vv gone. Aithe మీ దగ్గర current value కూడా వచ్చింది. So current value is nothing but E into B divided by 2 into pi into M. Finished. Aithe E square B divided by 2 pi M. So this is the current value. Substitute చేయండి ఇక్కడ. So sir, current value is nothing but E square B divided by 2 pi M multiplied by area. Area is nothing but NH divided by E gone. Ante NHB divided by 2 pi M. Ade kada. E also should be there kada. Yes. Kani. In the lowest energy state ante N ante shell number babu. Shell number. N is equals to 1 undali. Lowest energy state lo lowest energy kada. N value should be equals to 1. Kabatti HBE migita. HEB divided by 2 pi. Okay. HEB by 2 pi. Done? I hope you understood this. Okay. Yes, under. Something is fishy ra. Always fishy only. Me fishes ra. Fishes. No. HE by 2 pi m. HEB by 2 pi m ra babu. HEB, B also will be there. Endukante your magnetic field is always there. Chudandi. Okay. Yes. Can I know what's going on? Nothing is going on. Everything good. Everything is good. Under. 5 more likes remaining. I hope we could go for 150 ra. Okay. I hope we can go for 150 likes. But I don't know if you will let that happen or not. Okay. Kavalante. We can also discuss some more PYQs. So there is this concept of moving coil galvanometer. Okay. The Kavalante I will take here itself. Sir, student. So last topic ante moving coil. But I don't think you will understand it. Animation until let me show you the animation first. Okay. So that you might understand. Okay. Give me 1 minute. Okay, nimisham ivvandi. Then we will talk about the moving coil galvanometer animation. Lekapothe we might have to understand it by yourself only. Okay. Moving coil galvanometer. Right. Loading up. Not working up. We don't have any animation. this is your moving coil galvanometer. Andu chudandi. Okay, so if you want to go deep into it, so this is how your moving coil galvanometer looks like. Okay, and the galvanometer lo there is a loop, and there are n number of turns. Okay, n number of turns unnayi deetlo, and these n number of turns are placed between the north and the south pole of the magnet. Chudandi, north pole south pole kada. Yes, alage there are n number of turns. Is it visible? Visible a leda? Yes, so there are n number of turns into this moving coil galvanometer. Oka nimisham agandi. Yes. So basically what is happening in there, it is covering a loop. Okay, so basically if you attach a current in there, this current is actually moving through all the coils and coming back. Idigo ee green dot ni chudandi okasari. Idigo this green dot ra, and then it will come back again from this wire. Oh, okay, idigo this is the current, right? So if there is this current in there, మీరు imagine చేయండి loop into the magnetic field. Magnetic field అంటే తెలుసా, north pole south pole. So the magnetic field lines are like this. That's it. ఇదే కదా. Yes. So this coil, this coil is moving. Okay, this coil is moving back and forth, back and forth, back and forth. ఇదే కదా. Springs కూడా ఉన్నాయి. There are some springs also, which are managing the rotational SHM. Okay, circular SHM రా, angular SHM అని అంటారు. Okay, అర్థం చేసుకోండి. So what is happening, sir? Magnetic field లో n loops ఉన్నప్పుడు there is a torque on n number of coils. ఇదే కదా. What is the torque? Torque is nothing but m bar cross b bar. M value ఏంటి సార్? I into a. కానీ ఒకటే టర్మ్ కోసం I into a. But there are n number of turns అంటే NIAB ఇదే. So NIAB into sin theta. That's it. అందరూ అర్థం చేసుకోండి. Here NIAB into sin theta ఇదే కదా. So for your moving explain diagram drawing it is chala kashtam ra. Okay, moving coil galvanometer ide kada. Yes. Chudandi. So in moving coil galvanometer lo you have these number of coils ardham chesukondi. That's it. So n number of turns unnayi, and alage these number of turns they also have the springs, something like this. Okay, yes. And there is this north pole, alage ikkada south pole kuda untundi. Kabatti there are magnetic field lines also. So these are your magnetic field lines, right to left kada. Yes. These are the magnetic fields. So what is happening, sir? This loop, when the current is passing, there is torque acting on this loop. Ide kada. Yes. So sir, torque enta sir, it is nothing but m bar cross b bar. Yes, m bar cross b bar అంటే n multiplied by IAB into sin theta. Okay, this is the torque. Alage this torque should be balanced by what? Guys, please like this video అందరూ. ఒకసారి ఈ వీడియోని లైక్ చేయండి. I'm getting a call. Okay, 1 minute. Sir, what I'm saying? Yes. చూడండి. So this is the torque కదా. ఇదే మీ torque రా. కానీ మామూలుగానే we assume that the coil is actually perpendicular. The area is actually perpendicular to the magnetic field. Kabatti angle 90 degree anukondi. So here the torque is nothing but NIA into B. Ade. Ide kada? Yes. So ippudu ee loop paina focus cheyandi andaru. You focus on that loop itself. Okay? Yes. So when you are focusing on that loop itself, torque is there. Alage you can talk about the angular acceleration. Angular acceleration kada? Yes. Aithe sir, torque could be equated to C into theta. How sir? Idi force is equals to K into X. For example, okay, in your linear SHM graph, alage acceleration is nothing but some C into X kada. If force is proportional to X and your acceleration is also proportional to X, ide kada. Similarly, leda if you write the value of torque in this terminology, it should be proportional to theta itself. ఇప్పుడు చూడండి ఈ value this value is equated and this is your moving coil galvanometer. Sir, ఇప్పటికి 100 సార్లు చెప్పాలి సార్, లైక్ అరే obviously రా. Okay, if you like the video, then and only then this video will be spreading kada, and it will reach to good number of students, right? Sir, okay, so this is the moving coil galvanometer, okay? Adjusting it. We call it, you can also say, sir, deflection, theta is nothing but the angular deflection. So theta is nothing but NIA into B divided by C kuda cheppochu. Ippudu theta is nothing but NAB divided by C kada multiplied by current I. Idigo, this is known as the sensitivity of the galvanometer. Sensitivity of galvanometer. Finished. Chapter completed. Andaru. Let me just rearrange the slides. If everything is clear, then we will end up the session. You need these slides, right? So, 3 chapters అయిపోయింది. There is this post-session test. I want everybody to give this test, okay? The leaderboard will be announced tomorrow itself. Yes. Clear only. Okay. Pardon. I think this is having some problem. Right. So we need to adjust this also. Sir. Okay. Right. So we can wind up the session, guys. Okay. Thank you so much for attending. Okay. Mari like cheyandi, share this video, subscribe the channel. Okay. 8 hours of lecture and just 3 chapters completed. It's a tragedy. Okay, tragedy only. You can't do anything in that case. Yes, so we can wind up the session. Andaru, let us go for 150 ra. Some students are getting irritated. Sir, prati okkasari ade sir. Enti idi? But we don't have any other option, right? How many students are watching? Yes. Everybody. Sir, so this was all about the discussion in the. Okay, మొత్తం absolutely set రా. అరే ఒక పేజ్ లో ప్రాబ్లం ఉంటుంది. ఓకే, సో ఈ ప్రాబ్లం క్లియర్ చేయాలి మొదటిగా. Yes. అరే ఏంటా ఇది? Okay. And that's it, okay? That was all about the discussions. అందరూ చూడండి ఇప్పటిదాకా we have talked about 4 chapters కదా, 4 chapters. Yes, electrostatics, capacitors, current, electricity, magnetism done. I was expecting somewhere around EMI and AC, కానీ these 2 chapters are left as it is. So we will finish them in some other lecture. So this was all about the discussion, okay? Possible అయితే we will take some another discussion at some another time of point of time, okay? So ఇప్పటిదాకా ఏదైనా డౌట్స్ ఉంటే చెప్పొచ్చు మీరు, okay? సార్ వేరే ఆన్సర్ వస్తుంది సార్ ఇందాక 2025 క్వశ్చన్ ఎలా హౌ ఆర్ యూ గెటింగ్ డిఫరెంట్ ఆన్సర్ విచ్ క్వశ్చన్ ఏం క్వశ్చన్ గురించి మాట్లాడతావు వేరే ఆన్సర్ వస్తుంది అంటే పాసిబుల్ లేదు ఛాన్స్ లేదు అసలు ఓకే లాస్ట్ క్వశ్చన్ కదా ఇదే ఐ థింక్ దట్స్ ద లాస్ట్ క్వశ్చన్ అందరూ ఎస్ ఇదిగో సో ఫ్లక్స్ పాసింగ్ త్రూ ద ఆర్బిట్ అంటే ఇదే కదా సో ఫ్లక్స్ ఈస్ బి ఇంటూ ఏ ఏరియా వచ్చింది కదా ఏరియా ఆఫ్ ద ఆర్బిట్ మల్టిప్లైడ్ బై మ్యాగ్నెటిక్ ఫీల్డ్ అదే సో NaH by E ఇక్కడ నుంచి ఓకే area is NaH by EB. I'm sorry. ఇదిగో here is the calculation mistake. Good. Gayatri very good. Okay. ఇదే ఎక్కడ calculation mistake ఉంటుంది అందరూ ఒకసారి చూడండి. ఇదిగో ఈ magnetic field కదరా నేను ఇక్కడ మర్చిపోయాను. కాబట్టి ఇక్కడ నుంచి ఇక్కడ రావాలి. So magnetic field should be written over here itself. ఒకసారి magnetic field వచ్చిందంటే it will get cancelled out రా. Good. Very good guys. Very good. Okay. Yes. కొంచెం mistakes వచ్చినప్పుడు adjust చేయండి. Okay. There's no need to go back to the discussion and explain the answer once again. Okay, sir. B రాదు ఇక్కడ. Okay. Right. So my final answer to HE by 2 pi m is the final answer. Good. Okay. ఇది calculation mistake రా. So మీరు ఏ పారామీటర్స్ ని చూసి జడ్జ్ చేస్తారో నాకు తెలియదు అసలు. Okay. కానీ when I was doing the problem నా expectation ఏంటంటే మీరు నా calculation mistake ని క్యాచ్ చేయండి. So if you are able to do that, it's well and good. If you are not able to do that, okay? Sir. Good, Gayatri, very good, okay? Yes, Gayatri has given me the right answer. Very answer also. Okay. So this was all about the discussion. Let me just give you, export this PDF, and then we can definitely wind up with the session. Okay. Sorry. Replace it. Local distance to downloads from. Great. నా గోల్ కోసమే ఒకళ్ళకి తక్కువ ఉంటుందిరా ఓకే కానీ మీరు కూడా ఎగ్జాక్ట్గా నాలాగా ఉంటుంది ఎస్ सर घर कब जा रहे हैं अभी जो क्लास हो जाएगा तो कर जाएंगे सर चैट बॉक्स अरे डोंट वरी I'm not going to close the chat box it's almost done okay almost done Yes. So that was all for today. So bye everyone. This is me, your physics teacher Ahad sir, signing off from this session. Okay. Report kosam lecture kadra. Okay. Day after tomorrow, maybe in the morning itself, we will take the lecture. Okay. Yes. So with that being said, let us just wind up the session, guys. Everyone, good night. Very good night to all of you. Bye, guys. Bye.